Hi guys, welcome to the course of LangChain for developers. In this course, we'll try to master the entire LangChain for generative AI applications development. So here I'm going to start from the introduction of LangChain and I'll try to cover the entire LangChain functionality with LangChain expression language, that means LCEL. Then I'm also going to cover LangChain ecosystem like LangGraph, LangSmith and LangServe. So if you're a completely beginner and you want to master LangChain for development, this course is for you. At the end of the course, I'm going to also show you how we can implement end-to-end generative AI applications with the help of LangChain. So instead of talking too much, let's start with our LangChain.
So first of all, we'll be discussing the overview of the LangChain, then evaluation of the LangChain and the learning path. Because inside LangChain, there are so many components are available. So first of all, I will give you the entire overview, like why LangChain is important whenever we are developing any kinds of GenAI application. So without LangChain, what will happen and all. So each and everything I'll try to discuss. Then we'll be starting with the practical development. So our discussion about LangChain. Okay, LangChain. Okay, so see, first of all, let's try to understand what is LangChain and why it is required. Okay, so without LangChain, I mean, what will happen? So if I'm using any large language model, so what will happen? So can we build any application without LangChain, these kinds of framework? Is it possible to build the application? So first of all, let me, discuss the drawbacks. If I'm not having the LangChain, so what would be the issue there? Okay, so see, inside generative AI, I think you already know. If I write here, inside generative AI, okay, so what we use, guys, usually, I think you know, we use different tools and technology, right? We use LangChain, we use vector database, then we use large language model, we also use Llama index, then we also use, let's say, different kinds of web application framework, right? So these are the tools and technology we usually use if I want to implement any kinds of GenAI based product, yes or no, right? Now, whenever I'm talking about large language model, okay, whenever I'm talking about large language model, LLM, okay, LLM. So LLM is also having some limited power, okay. So why I'm talking about limited power, I'll just try to clarify. First of all, let's try to understand how many LLM we are having. Okay, so we are having many APIs, yes or no? Nowadays, we are having many LLM APIs. I'm not talking about, let's say, the raw model. I'm talking about the API as of now. Just try to consider API part. So let's say we are having something called OpenAI. Okay, OpenAI API we are having. So OpenAI provides different kinds of large language model. Okay, all the GPT series actually will get here. Then we're also having something called Llama. Okay, Llama is also having their API nowadays. Okay, Llama 2 is there, Llama 3 is there, even Llama 3.1, I think they have also published. Okay, so these are the different model actually they are having. Then apart from that, we're also having something called Mistral. Okay, Mistral. Then I can write, let's say, so on. Okay, so on. That means so many models API we are already having. Okay, so these are what? These are nothing but our large language model, LLM. Okay, these are nothing but our large language model. Okay, now what is the problem? What is the problem? Let's try to understand the problem part. Now, if you see, this LLM is having limited. So here I can write, let's say, limited context. Okay, context window. Yes or no? If you see any kinds of large language model, if you go to their documentation, you will see that it is having one limited context window. What is context window? That means the input limit. So like how many tokens you can pass as an input to that large language model. So this is called actually limited, context window. Okay. Now there is another problem you'll see, outdated knowledge. So outdated knowledge base. So if I'm talking about ChatGPT, I think mostly October 2023 actually they have taken the data over the internet and they train this particular ChatGPT model. That means this is the outdated knowledge base. Let's say if you ask anything, which is relevant to today's actually, let's say information, let's say current information, right? So latest information, so it won't be able to give you the answer. But nowadays, if you see, ChatGPT has been updated a lot. If you also ask something in the real time, let's say I want some latest news, it will also give you the answer. But how they're giving the answer? They're using something called agents. Okay, they're real time fetching the information. I'll be also discussing the agents. What is agents exactly? With the help of agents, we can connect different kinds of APIs. Okay, so no need to worry. As of now, just try to think about whenever I'm talking about large language model, only large language model. I'm not talking about the ChatGPT. ChatGPT is an application, right? And it is using large language model. And what is what are the large language model it is using? GPT series large language model it is using. Okay, so now whenever I'm talking about large language model, definitely it is having outdated knowledge base, because till 2023 October they have taken the data and they train this particular model. Now if you ask anything which is let's say after October, or let's say after 2023, definitely it won't be able to give you the answer. Okay, so that's why we call it as a outdated knowledge base. The next problem you'll see, data privacy. Okay, data privacy. So you can't actually trust any kinds of large language model, because what happens actually, if you, let's say, give your private data, so there is a possibility your data may get leaked actually. So again, it's a data privacy actually problem you will be getting most of the time. Then if I'm talking about the cost, okay, the next one is the cost. Definitely cost is there. So if you are not sure about the, let's say, input, token size, if you're not let's say worried about the output token limit, okay, from your large language model, so definitely your cost will increase there. So you also need to take care about the cost whenever you are using any kinds of large language model. And when I'm talking about large language model, we also need a good configuration machine to execute that if you are using any raw large language model, okay, not any API. So API we can directly access with the help of API request, but whenever I'm talking about raw model, that means you are downloading the model and you are executing in your machine. So definitely you should have good machine. Okay, and if you also fine tune, if you also, let's say, train this kinds of model, it will include lots of cost. Okay, at that end of the day. Then the next problem you will see, no connection. Just let me write, no connection with third party. Okay, third party tools. So we see these kinds of large language model doesn't have any connection with third-party tools. So third-party tools means if I'm talking about any different website, let's say different website, or let's say different any kinds of data sources, it doesn't have any kinds of connection. Okay, now the last one you can write so on again. Okay, that means so many problem you can consider whenever I'm talking about large language model. That means it is having some limited power. Okay, if you see, it is completely having some limited power. Now see, with this limited power, definitely we can't create any kinds of generative AI based application, because whenever I'm talking about generative AI application, so let me just write out. So whenever I'm talking about Gen AI application, Gen AI application, okay, apps. So definitely you need lots of functionality. That means, let me just write down some of them. So let's say you need some data functionality. Let's say data in. That means you can input any kinds of data. Let's say you can input TXT data, you can input PDF data, okay, you can input, let's say, CSV data, you can also input, let's say, SQL data, okay, you can also input something called XLS data, you can also input HTML data, you can also input PNG data, and so on. Okay, so these kinds of functionality definitely your application should have. That means I can pass any kinds of data. It doesn't matter what kinds of format I'm using. It doesn't matter. I can pass any kinds of data. Yes or no, right? So if I'm talking about only large language model, you will see that large language model actually can't take these kinds of data directly. So for this, definitely we have to use some of the external tool. Yes or no? Okay, so that's what I'm just talking about. If I want to build any large language model, if I want to build any, let's say, generative AI based application, so I need these are the actually functionality in that application. Okay, so these are the tools and technology I definitely need. Then whenever I'm talking about, let's say, some of the, let's say, actions, okay, actions of your application. So it can perform, let's say, RAG, it can perform, let's say, agents, okay, it can also give the APIs, it can also format your data, it can manipulate something, okay, then it can, let's say, transform something, transform something, it can store something, it will have some memory, okay, so that it can remember your conversation, okay. Then it can also connect with third party, okay, third party tools, got it, and so on, okay. Then it will also have something called data out. That means it will also give you some kinds of output. I can call it as data out, okay. And data out wise, what it can do, guys, it can return anything, okay, any kinds of, let's say, output it can give. So here I can write anything, whether it's a image, whether it's a, let's say, text, whether it's a video, anything it can actually return as an output, got it. So that's how actually we build any kinds of Gen AI based application, okay, Gen AI based application, got it. But if I'm only using, let's say, LLM, large language model, and see, large language model, it's not like that actually. It will come as an individual model, okay. So it will be published by some of the organizations, some of the company. So let's say I'm talking about OpenAI, okay. So let's say I'm talking about OpenAI here. So OpenAI is a company, OpenAI is an organization. So if you see, OpenAI is also having their own platform, yes or no, I think you saw. If I search for OpenAI, okay, openai.com. So this is the OpenAI platform. I think you already aware about this particular platform, guys, how to use the OpenAI platform. So OpenAI also give you one Python package. I think you remember, guys, Python package OpenAI also give you. So with the help of that Python package, what you can do, at least you can interact with the model. So it won't be having all kinds of functionality, like to build your generative AI based application, but most of the functionality it will also provide you. Okay. Now let's say you have learned this OpenAI framework. It's fine. Let's say you have learned this framework. It's completely fine. Now there is another requirement. You have to use Llama model. Okay. Then what you have to do, you can't use OpenAI framework in the Llama model. Okay. You can't ever use that OpenAI framework in the Llama model to load the Llama model. For this, what you have to do, you have to again learn the Llama framework. So Llama is also having their own framework, okay, from the Meta site. So you also need to learn that particular framework, okay. Now let's say again you have learned the Llama framework. It's completely fine. Now there is another requirement. You have to use Mistral model. Again, you can't use OpenAI and Llama framework to load the Mistral model. Then what you again need to do, again need to learn the Mistral framework, okay. That means if I'm talking about different kinds of large language model, so you also need to actually learn different kinds of framework. And again, it's not actually efficient way, because as a developer, how many framework you will be learning, and it's not possible to remember all the framework. So it would be very difficult for us. So can I use only one kinds of, let's say, framework, one kinds of library, and with help of one kinds of library, I can, let's say, load all kinds of model. I can perform all the operation, whatever operation I've written here. Is it possible? Yes, it is possible. So that is why actually your LangChain comes into picture. Okay, LangChain comes into picture. So LangChain, what they did actually, they created one. But I can say they created one common framework actually. So this particular framework can, let's say, use all kinds of large language model. Not only large language model, all kinds of generative AI service, they can use this particular LangChain framework. That means this is a universal framework. Okay, that means it can support everything. Now you can ask me why we have to choose LangChain. There is another framework in the market called Llama Index. I think you know. Okay, Llama Index. Okay, Llama Index is the alternative of LangChain. So both are good framework. I'm not telling Llama Index is bad, LangChain is good. It's not like that. Both is having actually their different kinds of ability. Okay, I'll be also discussing more about Llama Index later on. As of now, our main intention is to focus on the LangChain, because here, if you see the series actually I'm taking, it is related to the LangChain. Okay, now let's try to understand why LangChain we have to choose. Just try to remove it. So here, let me write why we choose LangChain. Okay, why we choose LangChain. Okay, so what is LangChain? First of all, I already told you LangChain is a orchestration framework. Okay, orchestration framework. Okay, that means it's a complete generative AI framework. So all kinds of orchestration you can perform with the help of LangChain. And inside LangChain, you will see there are different update came nowadays. Okay, so many things they have integrated. Let's say they have integrated LLM ops. Okay, LLM ops technology. That means you will see they are also having ecosystem like LangSmith. Okay, LangSmith very popular nowadays. Then LangServe. Okay, very popular nowadays. Then we're also having something called LangGraph. So with the help of LangGraph, what we can perform? So this is for actually monitoring. This is for actually deployment. Okay, deployment. And this is for actually agents or multi-agents. Okay, multi-agents. So these are nothing but our LLM ops tool, LLM ops tool and technology. LLM ops tools and technology. Okay, now if you see, these are the actually ecosystem. So it is built on top of LangChain exactly. If you see all the, let's say framework, that's all the LLM ops tool, it is built on top of the LangChain. That means they're using LangChain language only. Okay, they're using LangChain language only to implement these kinds of framework. Now whenever you are working in the generative AI market, let's say there is a requirement, you have to implement one generative AI application, and there you have to implement one agents. Okay, that means it will have the multi-agents ability. So definitely, you know that if I want to create the multi-agents, okay, multi-agents in my let's say application, what I have to use? I have to use something called LangGraph. Okay, I have to use something called LangGraph. Now LangGraph you can't use with the help of Llama index. Okay, Llama index actually doesn't support this LangGraph. That means you can't use it. Then what you have to do? You have to use something called LangChain. So definitely you have to learn the LangChain at the end of the day. Yes. Now let's say you want to create a POC deployment. You want to create an API of your application, and you want to use LangServe for this. Then what you have to do, guys? Again, you have to learn the LangChain, because LangChain supports this particular LangServe, right? Then let's say you want to monitor your application. Okay. That time, let's say if you want to use LangSmith, so what you have to use? You have to use the LangChain again. That means if you see here, wherever you go, okay, wherever you go in today's market, at the end of the day, you have to use LangChain only, because LangChain is having all kinds of ability. Okay, all kinds of ability it is having. Okay, there are some alternative as well. Okay, you will also see in the market there are some alternative as well. Let's say LangGraph alternative, you can use something called this one. The alternative of LangGraph, you can use something called Crew AI. Okay, Crew AI. So let me write it. Crew AI. So Crew AI is a framework with the help of, you can also create agents and multi-agents. Okay, but again, I'm talking about the complete LangChain ecosystem. Let's say if I'm having something in the LangChain, so definitely you won't be using any third-party, let's say, tools and technology. Okay, because if you're familiar with LangChain, so most of the, let's say, ecosystem you can automatically work with, because the language is same at the end of the day. But if you ask me which one is the better, okay, see, understanding wise, I will suggest you can learn the Crew AI, because Crew AI, you will see the syntax wise, functionality wise, it is like very easy to understand. Let's say with compared to your LangGraph. So I will show you some of the example in future maybe. So there you can see with the help of both framework, we'll be creating the agents. But there we will automatically try to understand. Okay, so what is the difference between Crew AI and LangGraph? See, Crew AI at the end, they're also using LangChain. Okay, LangChain in the backend. Okay, LangChain in the backend, and they implemented one high level framework. Okay, for the agents and multi-agents. I think you know about, let's say, this one, TensorFlow, guys. I mean, what was the TensorFlow? The previous TensorFlow, I think TensorFlow was separated library, yes or no? But if you see the Keras implementation, internally they're using TensorFlow API only. That means TensorFlow language they're using, and they have created one high level wrapper on top of it. Yes. This is called actually Keras. Then what TensorFlow thought, because Keras got more popularity in the market because of that easy to use, because all the developers started using the Keras. And that time TensorFlow thought actually, can we collaborate with the Keras so that we can bring the Keras in our, let's say, library. That means we can import like that from TensorFlow, import Keras. But previously we used to import Keras like that, import Keras directly, right? So that's why they collaborated, and they actually, they took this particular, let's say, Keras framework in the TensorFlow API. Okay, so the similar wise, so Crew AI is also a library, different library, but at the end of the day, internally they are using LangChain API only. Okay, LangChain language only, but they created one high level wrapper on top of it. Okay, so that whenever you are getting any kinds of agents and multi-agents, you can create in a good way. So you don't need to write too much of code. You don't need to do so many configuration. So they have already created some pre-built functionality. With the help of that, you can directly use them, right? But see, whenever I'm talking about Crew AI, so here you don't have like lots of customization option. That means as a developer, you won't be able to customize your, let's say, agents, because it's a high level wrapper at the end. It will give you some functionality, but let's say you need a customization. You have to customize everything. that time what you can do, you can use LangGraph, because LangGraph will provide this kinds of customization ability. So if I'm talking about Windows and Linux, so which is having more customization, guys? Tell me. Definitely inside Linux, because Linux is kinds of open source, and it has actually given me everything, okay, so that I can customize everything here. But whenever I'm talking about Windows, so we are having some certain, let's say, a modification we can perform. Okay, if I'm talking about Windows, Mac OS, so there are some certain operation we can perform, okay, customization we can perform. But if I'm talking about Linux, everything you can customize. You can even write your own code there. Okay, let's say you don't need this kernel, you can also write your own kernel and you can use it in the Linux operating system. Okay, so now I think this part is clear, guys. Okay, what is this Crew AI and LangGraph? So now I think you got some understanding why we have to choose the LangChain, because nowadays whatever, let's say, evaluation you can see in the field of generative AI, okay, so all the, let's say, technology is coming in the LangChain, okay, very frequently, because they are bringing like so many, let's say, tools and technology for you, so that you can use them to create your generative powered application. Okay, now I think it is clear. That's why we have to choose the LangChain, because it is having all kinds of ability. Now if I'm talking about LangChain evaluation, okay, LangChain also evolved, I think you know, as per your large language model evaluation. So LangChain also evolved. So let's me just discuss about LangChain. Okay, LangChain evaluation. Okay, LangChain evaluation. So see, previously, I think those who have used LangChain, I think you know, LangChain only used to use something called, I think, LLM model. I think inside LLM model, we are having two kinds of model, I think you know. One is completion model. Okay, completion model. And this like chat model. That means if you see from LLM model, that means generation model, completion model, okay, LLM model, they also integrated chat model ability in their framework. Okay, then the second evaluation you can see from legacy, okay, from legacy LangChain to LCEL, that means LangChain expression language. Okay, then they also evolved from LC, okay, LangChain to LangChain ecosystem. They also created ecosystem. Okay, ecosystem means they have created different ecosystem, like I already told you na. So you can see they created LangSmith, LangServe, LangGraph. Okay, so these are the ecosystem, okay, they created. Then one very interesting thing, even I usually explore a lot, from terrible documentation to, here I will just write ... Okay, why ... Now you can tell me, guys, if you're using LangChain documentation, maybe you will be able to answer me. Okay, so previously if you see the LangChain documentation, it was terrible, right? It was very nasty and terrible. Even it was out of brain for me also. When I started learning LangChain, I was to refer the documentation. It was very hard to understand. Okay, now if you see in today's LangChain also, if you see that documentation, I can't say it's they created like easy documentation, but again it's hard to understand most of the syntax, because you will see that and they will be writing too much code. Okay, too much code, and if you go to the documentation, definitely will get confused. Okay, like what is happening here? So again, I can say it's not the exact actually easy documentation they have created. That's why I've given ... That means still it is terrible for the developer. Yes or no, guys? If you see the like Llama in this documentation, it is easy to understand compared to if I'm talking about this LangChain. Personally, I don't prefer the documentation the way actually they have written the documentation, but compared to actually LangChain, Llama in this documentation is a little bit good. Okay, what I feel like. Okay, yes. Now yeah, so these are the actually evaluation actually they did in the field of generative AI. That means first of all, we had actually completion model only inside large language model, then we switched to the chat model. Okay, so let me show you some of the example of completion model and chat model. So for this, what I can do, maybe I can open the playground, OpenAI playground. See, this is the OpenAI playground. So if you see, this is the playground of the OpenAI. Now below you can see this is the completion. Okay, completion actually playground. So here they're using something called completion model. And what is completion model? You can see these are the completion model. So GPT 3.5 Turbo Instruct, GPT 3.5 Turbo Instruct 0914, then Babbage 001 and Dependency 002. Sorry, Babbage 002 and Dependency 002. Okay, so these are actually completion model. And now what is completion model? See, completion model, here you can't pass any kinds of system prompt. That means you only need to give the user input. Okay, user input. That means you can perform the conversation. Okay, here you can perform the conversation. So here you can, let's say, generate something. Let's say here I can write a poem. Okay, poem for me. Okay, so if I see send the prompt here. Okay, so it is telling, yeah, so not so now it is generating the poem for me, and you'll see that it's a generation model. So here you can't perform any kinds of, let's say, conversation. Okay, conversation actually it's not possible. It's a complete actually generation model you are using. Completion model you are using. Okay, now if I switch to the chat model, see, nowadays all the model, this is a chat model, chat completion model, whatever model you can see nowadays. Let's say new model GPT 4o. See, here is the list of the model: 4B Turbo, 4, 3.5 Turbo. Okay, so these are actually chat completion model. Now if I'm talking about Llama, if I'm talking about Mistral, Falcon, whatever model you can see, so all kinds of model are chat completion models nowadays. That means you can also perform the conversation, and this model can take two kinds of input. One is the system instruction. Okay, system instruction. So here you can specify what kinds of, let's say, task you want to perform with the help of your model. So here I can give any kinds of, let's say, system prompt. Let's say you are an expert. Okay, expert to write poem. Okay, poem. Okay, so you can give any kinds of system prompt here. So let's say I've given this one. Now you can give the user input. So I can write I am very happy today. Please tell me a poem. Okay, poem. Now see, if I give it to the model, see, you will get actually a very good response. And you see the response actually you are getting the level with assistant, and whatever input you have given, you are a user. That means you are doing the conversation. Okay, conversation here, and this is called actually chat completion model. Okay, chat completion model. Now let's say you didn't like this particular poem. Now what you can do, I need some let's say excitement in this. Now see, here I haven't specified. Okay, I haven't specified this poem I'm talking about. Okay, I just written I need something excitement in this. Okay, and it will automatically understand I'm talking about this particular poem. The poem actually it has given me. So this is called actually conversation. The way we do the conversation with the human, right? Let's say between 2 person, between 3 person, the same thing actually they have mimic inside the large language model. That means you can perform the conversation with that. Okay, and you can specify any kinds of system instruction here. Okay, so this is called actually chat completion model. Okay, now I think it is clear what is chat completion model, what is completion model only. Okay, now see, previously whatever large language model we used to use, this was actually completion model, and LangChain only was support. LangChain only actually created the functionality related to the LLM model. That means the completion model. But nowadays, if you see, they also created the functionality related to the chat model. That means it can also load all kinds of chat model. Okay, all kinds of large language model. Not only completion model, it can also load any kinds of chat model. Okay, then from legacy to LCEL. That means if you see the previous syntax of the LangChain, it was different. Whenever we used to create the chains, we used to use some of the function from the LangChain. But nowadays, they created something called LangChain expression language. Okay, that means instead of using the function, what we can do, we can create a pipe. Okay, I think you can see nowadays people are using pipe. Okay, so people are using pipe. So with the pipe, actually we can create the chains. So we don't need to use any kinds of, let's say, function for any kinds of chains. Okay, I'll also tell you whenever we'll be doing the practical. That time I'll tell you what is the difference between the legacy LangChain and what is the difference between the this one LangChain expression language. Okay, everything I'll try to clarify. Then they created the ecosystem. That means they brought actually different kinds of ecosystem like LangServe, LangSmith. Then they also brought something called I think LangServe. Okay, so these are the ecosystem, and the from terrible documentation to, I think I can say again, it's a terrible documentation only for I mean developer like us. Yes or no, guys? Okay, so this is the complete evolution of the LangChain. Now see, one thing you just need to remember. So it is very important, guys. Even I always say this to my student. See, this generative AI space is the fastest evolving space in software industry. Okay, software industry. Okay, so no matter how hard I work, the content will never be 100% okay up to date. Okay, it's not possible. How much hard I work, the content won't be never 100% up to date, because it's like very fastest evolving space in the software. Okay, but here note, okay, note it, but here, but you will be ready. Okay, you will be ready for anything. Let's say if I'm teaching you something, definitely you will be ready for anything. Okay, and I always tell here, I do not give you fish. Okay, here I will teach you. I teach you how to fish. Always try to remember this line, guys, because let me show you one example. Let's say if I go to the LangChain let's say, I mean, package. So if I just search LangChain PyPy, let's open this LangChain PyPy. Now, if you go to the release history, now see the release date actually. Okay, just see the release history. So what is the last update, guys, of the LangChain? It's October 9. Okay, October 9. And tell me, when was the October 9? I think it was yesterday only. Okay, yesterday they updated the version of the LangChain. Now you'll see that the previous update, it was October 4, September 26, September 14, September 12, September 6, September 4. Okay, you will see that very frequent update, very frequent update. Now tell me, if I'm teaching you something, okay, if I'm teaching you something, and let's say after 1 month, definitely there would be so many update in the LangChain. Yes or no? There would be so many update in the LangChain, in the generative AI. Now tell me, is it possible for me to again, I mean create the course? Tell me. No, right? But if you see the actually, I mean, concept wise, they're using the same concept, but they're changing some of the syntax. That's it. Okay, previously whatever legacy LangChain we used to use, it's completely fine. All kinds of functionality we can use today, but some of the syntax has been changed. Okay, some syntax has been changed. That means previously we used to use function. Okay, function to create a change, but nowadays what we do, we create a pipe. We use pipe symbol, okay, to create that particular change right now, and this is called actually LCEL. That means LangChain Expression Language. Okay, small modification they are doing, but they're releasing so many version, and people are getting confused. Sir, you created this course, you are using older version of the LangChain, so it's not fair. But you just need to try to understand, okay, why we are creating with the older version of the LangChain. Because if you see older version of the LangChain, you will see there some of the version is stable version. That means they have created this version in such a way all kinds of functionalities are available. Okay, because developer are using, it's not possible for the developer to change their version, different version always. But let's say you have created one software. Let's say you created this ChatGPT. Let's say today you have created, after 1 month, again another version of the LangChain will come. So will you again change that code in your code base? Tell me. again you will change the code in your code base? No, right? So what we'll do, whenever you're creating any kinds of software, first of all, you will try to select one specific, let's say, stable version, stable version of the framework, and with the help of that, you will be developing the entire, let's say, software. Yes or no? Okay. So that's why whenever I'm teaching you something, I'll be using one specific, let's say, framework, a specific framework. I'll be using some specific version. Okay. Because it's not possible. Let's say when I created the content, that time, let's say, I was using this version, but after creating the content, when I started teaching, so they have released so many versions. Again, it's not possible for me to again update my content, right? Yes or no? But if you see, they are not doing, so many major changes here. Small changes they are doing. Sometimes they're bringing some new, let's say, syntax. Sometimes they're bringing some new functionality. That's it. Apart from that, you will see they're using the same legacy LangChain only. Only some of the syntax has been changed. I will do the practical also. That time you will also get it. Okay, some of the functionality they have changed, but apart from that, whatever legacy LangChain used to use, the same functionality will remain here also. Okay, that's why I always tell this line. Okay, so here, how hard I work, okay, in the field of generative AI, but the content will not be ever 100% up to date because of that. Okay, and here I will teach you how to fish, exactly how to learn. Okay, how to learn. Let's say if anything is updating by the framework. Okay, if anything is updating by the framework, or let's say if any new changes is coming, so as a learner, as a developer, definitely you will have the ability to understand, okay, what is coming in that. Okay, so don't always try to rely on your mentor. If you're relying on your mentor, so you ever, it won't be possible for you to be a good developer at the end of the day. You can trust me, guys. Okay, so always you have to learn, learn the concept, like how this concept is being utilized here. Apart from that, if anything is coming in the market, if any new update is coming, you have to explore that. So always you have to do export, guys. 3 things you have to do: export, export, research, and practice. So these 3 things if you have, definitely you will be a good developer. You can solve any kinds of problem statement, trust me, guys. So that's why here I do not give you the fish. Here I'll teach you how to fish. That is my main objective. Yeah, so that's why see, whenever we're learning the latest LangChain, it's not like that everything has been changed in that let's say framework. Some of the, let's say, functionality they have changed, some of the, let's say, new syntax they have introduced, but here we'll use the legacy. Okay, still we'll be using the legacy. Still we'll be using the legacy LangChain, because still it is using LangChain team is also telling you have to use legacy let's say LangChain still if you want to create any kinds of GenAI application, because we are not able to actually, let's say, change all the framework. That means all the syntax, it is not possible to change. Some of the functionality we brought, but still you have to work with the legacy LangChain. Okay, so whenever I'm talking about, let's say, memory, memory nowadays, let's say when you want to add any memory to the application, you will see that people are still using legacy LangChain actually syntax. That means they're using some function, some function, let's say buffer memory function. They're using some, let's say, window buffer memory function. Still they're using that one, because in the second generation LangChain, these kinds of memory they haven't introduced. Okay, they haven't introduced this kinds of memory kinds of functionality. I think recently they published one version. I think they're telling like we integrated actually permanent memory, with this framework. But again, you'll see that they're using the same kinds of things only, at the end. Now let me discuss about the learning path. Learning path, like how we'll be learning this LangChain. Yeah, so first of all, here I already given you the introduction and the overview why LangChain is required and why we'll be using LangChain. Okay, so then next session we'll be discussing about how to talk with LLM with the help of LangChain. That means we'll be using different kinds of large language model. We'll be using OpenAI large language model. Okay, we'll be also using open source large language model. Okay, so all the things we'll be exploring one by one. Okay. Then we'll be discussing about how to work with the data, how to work with data. Let's say if you're having any custom data, custom documents, then how you can load these other documents, how we can connect your large language model. That means we'll be discussing about basics of RAG. Okay, basic RAG we'll be discussing here. Okay. Then fourth, we'll be discussing about something called chains. Okay, chains is the main thing inside LangChain, because at the end you will be creating the chains. It's a step of execution. Nowadays inside LangChain expression language, they introduce something called Runnable. Okay, Runnable. Okay, Runnable. They call it as Runnable. Previously we used to call chains. Now you'll be calling as a Runnable. Okay. Then I'll be also discussing something called memory. Memory. That means if you want to add any memory, that means if I go to the chat GPT, if I'm asking something, it can remember my conversation. Okay, so this kinds of, let's say, memory, how to add, I'll be also teaching you this thing. Then we'll be also discussing about the ecosystem. Okay, ecosystem. That means here we'll be exploring LangSmith, LangServe, and LangGraph. LangGraph. So these kinds of ecosystem we'll also try to understand. Then once everything we have completed, okay, we'll be also doing some development. That means we'll be implementing some level 1 application. Level 1 application. Okay. Apart from that, in the advance, you will see that we are also having something called level 2 application. We are also having something called level 3 application. So this level 3 application is the professional. Okay, professional LLM application. Okay, LLM apps. That means here we'll be using something called full stack development. Okay, full stack development. So these are the actually application level. Okay, and as a generative AI developer, let's say if you want to create a professional application, that time you need to know how to create the level 3 application. Okay, with the full stack development. Okay, so yeah, I think you got the entire learning path. Okay, how we can learn this complete LangChain. And apart from that, you don't have anything inside LangChain. Okay. So guys, now let's see how we can connect with different kinds of large language model with the help of LangChain. So here I will show you how we can connect with OpenAI GPT model. Even I will also show you how we can connect with any kinds of open source model like Llama 3, Mistral, and so on. So as I already told you, OpenAI GPT model is best model so far. So in this program, we'll be using this model. Okay. Whatever project actually we'll be implementing, we'll try to use this model. But if you also want, you can also connect with any kinds of open source model. Okay, that alternative I will also show you how we can connect with open source model. So let's start with our practical demo. How to talk with LLM. Okay, with LangChain. Okay. So see, whenever I'm talking about how to talk with LLM with LangChain, that means we'll be interacting with the large language model. Okay. So here, the first thing we'll be exploring, we'll try to see how we can connect with the most used LLM. Okay, LLM, which is nothing but our OpenAI. All right. Then we'll be also learning connect with alternative, okay, alternative large language model. That means we'll be also exploring some open source. Okay, open source API as well. Fine. Then we'll be also learning talk to LLM in different language. Different language, because most of the people actually they're using English language. Even if you see, these are the large language model is trained with English language, but let's say you want to do with any other language, let's say Spanish or any other language. So is it possible or not? Definitely it is possible, but I'll tell you, okay, I'll tell you some drawbacks you have to remember whenever you are using different language. Then I'll be discussing about introduction to prompt template. Along with that, will be also learning something called chains. Okay, chains and output parser. Output parser. Now you can ask me why here I have written the most used LLM. Okay, the OpenAI. Because see, whatever model you can see in the market, let's say I'm talking about Meta, Llama, or let's say Mistral. Okay, Mistral, Falcon. Okay, so whatever model you are talking about, this model is good. At the end of the day, if you want to build some POC, okay, this is completely good. You can do it. But whenever it comes to actually a real-time project implementation, that means you want to create any robust application, very robust application. Okay, that time it is recommended to use OpenAI. Okay, because OpenAI is the better model so far. Okay, whatever model we are having, like the Meta, Mistral, Falcon. Okay, apart from that, this OpenAI is the very powerful model, and it will give you more accurate response. Okay, and if I'm talking about the cost of the OpenAI, it is also less. It's not actually very much. If you're taking care, let's say all the prompt template, let's say all the small things, definitely you can also reduce the cost. Even I'll also tell you how we can reduce the cost, how we can monitor our application. Okay, everything we'll try to discuss, no need to worry. So see, it is always actually suggested, if you want to create a robust application, if you want to create a real world product which you will be using in the production, that time go with OpenAI model, because OpenAI model is far better than your open source model. That means let's say any other alternative model wise, it's fine, you can use it, there is no issue, but you can use them as a POC. Let's say you want to create a project and you want to just, let's say, create a POC kinds of, let's say, application, that time you can do it. But whenever it will go to the production level, that time I'll suggest try to go with the OpenAI model, because this is far better than your Meta, Llama 2, okay, or let's say Mistral, Falcon, whatever, let's say open source model you are having, it is better than that. Okay, so that's why actually OpenAI is a chargeable, because this model is very good, and if you want to use them in the production, definitely you have to pay some money. Okay, and these are the model are open source because they have make them open source so that you can at least explore the generative AI. You can create different kinds of application as a POC kinds of, okay, let's say application, and you can at least test that particular application. Okay, this is the main idea. Okay, that's why here I have written the connect with the most used LLM. Okay, that means OpenAI model is the most used LLM. Okay, which is nothing but GPT series. Then you are also having some alternative option. Let's say you don't want to, let's say, create the OpenAI API key, you don't need to spend some money. At that time, you can also use the alternative approach. Okay, I'll also tell you how we can connect with the alternative model as well. Okay, then we'll be discussing about talk to LLM with a different language. That means if I want to, let's say, communicate with my large language model in a different language, let's say Hindi, Bengali, whatever, I can also do it. There is no issue. But you will see that English accuracy will be getting more. Whenever I'm talking about English language, you will be getting, a very good accuracy there, because these are the model has been trained with English data. Most of the data will see that all over the internet, it's English data. Yes or no? Okay, so that's why sometimes some hallucination you might get if you're using any other, let's say, language. So that part you have to take care. Got it? Going forward, you'll be also learning how we can fine tune these are the model on top of our custom data. Okay, how we can create a RAG application on top of our custom data. So that time also you can create this kinds of, let's say, project. There is no issue with that. But most of the time, if you want to use a different language, so make sure this language is available. The model actually you are using. Otherwise, you have to fine tune that particular model. Okay. So the first thing will be we have to do the environment setup, because everything will be set up in our local machine. Because most of the, let's say, session, most of the tutorial you will get, people are using Google Collaboratory. Okay, they're using Google Collab to set up everything. And we know that inside Google Collab, actually, we won't be facing any kinds of error, because inside Google Collab, we are having already pre-installed all the package. Yes or no, right? So when it comes to the local setup, people will get the difficulty for sure. So that's why I will more focus on the local setup everything, because at the end of the day, whenever you will be developing something, you have to set up everything in your local machine. Okay, no need to use the Google Collab that time. So that's why we have to learn how we can set up everything in our local machine. That is the idea. Fine. So guys, what I will do, I will open up my local folder. You can see here I have created a folder called LangChain latest. Inside that, I'm going to open up my terminal. Okay, so you can also open up your git bash, anaconda prompt, whatever terminal you are using. Just make sure, try to open it, and make sure you are having anaconda. Okay, anaconda install, everyone. So I'm expecting you are already having the anaconda in your system. Okay, now the first thing what I will do, guys, I'll just try to open up my Visual Code Studio here. So this is my Visual Code Studio. Let me zoom. So here I'm going to create a file called readme, and code would be also available in the description section. Otherwise, what I can do, I can create one GitHub repository. There I will be uploading. You can also get the code from there. Okay. So readme.md. So inside that, I'm going to mention all the command you have to execute to create the environment, to set up your all the requirements. Okay, all the command I'll try to mention here. So the first thing, here let me give a comment how to run. So the first thing, you just need to create an environment. So create, I can write conda create. Okay, conda create -n. Now you just need to give the environment name. Let's say I'll give LLM app. Okay, LLM app. Now you have to specify the Python version. So Python is equal to, let's say I'll take 3.11. Make sure guys you are using 3.11. Why 3.11? Because 3.11 is the stable version so far, okay, inside Python. So that's why we are using, because it supports all kinds of library. So you won't be getting any kinds of installation issue. So see, it's always recommended. Let's say whenever any package or any, let's say, version is coming in the market, if you see the LangChain is like very frequent update, yes or no? Okay, so every day they are bringing new features. So they are doing some small modification, but apart from that, everything is remaining same. So similar wise, Python is having also so many version. So it is having 3.11, 3.12, I think it is also having. So we are not going to use the latest version. Instead of that, we'll be using at least some previous older version. Okay, why previous older version? Because people have already used these at the, let's say, version in their project implementation, and it was working fine. Okay, it was working fine. There is no error. So that's why people has decided, okay, this is the stable version of the Python so far, so you can use them. Got it? So if you search over the internet, you will see different kinds of blog. People have already written, okay, what is the stable version of Python and why you should use it. Okay, everything they have already written. So that's why instead of installing the latest version, always try to install at least some fewer older version. Okay, that will help you a lot. You won't be getting any kinds of error. So that's why here I'll be using Python 3.11. So then I'll give another line -y. That means I want to give the permission to create the environment. All right. Now the second thing, after creating the environment, you have to also activate the environment. For this, you have to execute this command called conda activate. Okay, LLM app. So this is the command, guys. Then to install the requirements, you just need to write pip install. Okay, -r the requirement.txt. So these three commands you have to execute one by one. So for me, I already created the environment. So let me show you. So let me just activate the environment. But for you, if you don't have the environment, guys, just try to execute this line. Okay, once you executed the line, it will create the environment. After that, you have to activate that. See, this is the command I'm executing, conda activate LLM app. Now see, if I press enter, you'll see that LLM app has been activated. That means I already have the environment in my system. But for you, you just need to create it, guys. So see the command and try to create the environment. After that, here I'm going to create a file called requirement.txt. So requirements.txt. So inside requirements, you have to mention all the requirements you need. So let me mention the LangChain package. So here I can write LangChain is equal to. See, if you're not giving any kinds of version, that means it will install the latest version. So if I go to the LangChain documentation, or let's say LangChain PyPy. So LangChain PyPy, open it up. If I go to the release history, you'll see that this is the latest version. Okay, it will install the latest version. But what I told you, so don't try to use the latest version always. If you want to create a robust application, at least just take the fewer version of the old version of that particular package. Okay, so here I'm going to use one version of the LangChain, which is nothing but 0.2, because you can see LangChain is currently 0.2 series. Yeah, 0.2 series of it was the stable version till September. Then they released actually 0.3, but there is no actually new update. The same things, but only the few like let's say change they have done. But again, if you install this one and this one, I mean both will work in the same way. Okay, there is no change. Okay, if you see the documentation, there is no change. Okay, so that's why I was going through some of the documentation and I got to know. So this is the actually stable version of the LangChain right now. So 0.2.10. So this is the stable version of the LangChain right now. So we'll be installing this particular version. Okay. So this version we have defined. Apart from that, here we'll be also using something called OpenAI. Okay, OpenAI large language model. So for this, what I need, guys, OpenAI. Okay, OpenAI. But see, previously, I think you remember whenever we used to use older LangChain. That means if I go to the older LangChain, see, this is the older LangChain. Okay, this is the older LangChain 1 point series. Okay, this is the older LangChain. So OpenAI was available inside LangChain only. Okay, if you only install the LangChain, you can also use the OpenAI from the LangChain. But currently, in the new chains, they have created a separate library for OpenAI. So you have to install like that, LangChain, LangChain hyphen OpenAI. Okay, OpenAI. So this is the like package, guys. But again, I'm going to use one specific version, the stable version. Okay, this is the stable version. Then I'll be also managing my credential for the, let's say, OpenAI, or let's say if I'm using any other third-party API, so I also need the secret key. And to manage the secret key, I'll be using .env. Okay, this particular file. So with the help of that, here I'll be mentioning all of my secret, so that whenever I'll be uploading the code in my GitHub, people won't be getting that particular file. Okay, so this is called actually python.env. So for this, you also need to install python.env. So this is the package we'll be also installing, python.env. Okay, and apart from that, to access that actually alternative model, that means open source model, we'll be using another library called Grok. Okay, Grok, and Grok is also available inside LangChain. LangChain has already created one framework called LangChain Grok. That means if you see the current LangChain, so all the things they have created separately. So if, everything they have been included in their root package. Root package you can use for the LangChain kinds of functionality, but if you want to integrate OpenAI, you have to separately install the LangChain OpenAI. If you want to use Grok, you have to separately install that Grok. Okay, that's how it is also having LangChain community. Okay, different kinds of LangChain library they are having, but it is using the same base LangChain only. But on top of that, they have created one separate library. Okay, this is the idea, because LangChain is a huge framework. If you see, it's a like huge framework. So many, there are lots of functionality they have included. So that's why they have separated. These are the, let's say, different functions, so that they can do the organization of the code. Even as a developer, it would be easy for you to understand. Okay, let's say I need OpenAI, so I will be simply installing LangChain OpenAI. Let's say I need Grok, I'll simply install LangChain Grok. That's it. Okay, so now see, I have specified my version. Now, if you share this project with anyone, okay, anyone, after 6 months also, they will still able to execute this project, because they will be also installing the same version. And whatever, let's say, code you will be writing on the basis of this particular version. Okay, that's why it is always recommended. I hope it is clear. But whenever you are not specifying the version, that means it will install the latest version. And whenever it will install the latest version, let's say if some functionality has been changed in the package, that time your code will break in the production. So now to install, these are the package, guys. What you have to do, open up your terminal and copy this command, pip install -r requirement.txt, and simply execute it here. That's it. So it will automatically install everything. So for me, I already installed. That's why it is telling requirement is already satisfied. But for you, it will take some time. Okay. Great. So that's how we can do the local setup, everyone. Now here simply let's create one file. I'll just name it as file, let's say 01 talk with LLM.ipynv. Okay, so this is the file I'll be creating, and inside that I'll be doing the experiment. So let me select my environment. So Python kernel, so I need this LLM app, this one. Now if you want to test it, simply write a message. So see, execution is done. That means it's working fine. There is no error. All right. So now the first thing we'll be learning about how we can connect actually our this one, our actually most frequent large language model, which is nothing but OpenAI. Okay. And I think I already showed you the OpenAI playground. So it is having two kinds of model. One is the chat model, and there is the completion model. And I already showed you what is the difference between completion model and chat model. I think in the previous session, I already clarified. Okay. In the completion model, you can't pass any kinds of system prompt. That means it will generate something for you. But whenever I'm talking about chat model, it can also perform the conversation. Okay. Like a human. That means you can also give the system prompt, and you can select different model. You can see there are so many model inside chat model. But if you see, some few models are available inside this completion model. Okay. So first of all, let's try to see how we can load the completion model. Then I'll also show you how we can load the chat model, because LangChain supports each and everything. All kinds of model you can load. Okay. Great. Now I'll open up my, this is my notebook. So the first thing, guys, what I have to do, I have to I have to add my OpenAI API key inside my environment variable. So let me add it quickly. So I'm not going to show you my key, guys. So let me just quickly add it. So in other screen, I'll just quickly add it, and I'll show you. So in my other screen, I will add it because I don't want to show my OpenAI API key. Okay, I think you know how to create the OpenAI API key and how to set. So let me show you the key name you have to assign here. I think that would be clear. So first of all, you have to give the OpenAI API key. Okay, inside this double quotation, you have to paste your OpenAI API key. So please go to your OpenAI account and try to create one API key here. And the second thing, I need the grok. Okay, grok API key. So as of now, I don't need it. I'll just try to comment it. So later on, whenever I'll show you the open source large language model, okay, we can access. That time we'll be using grok API. Fine. Now let me copy paste my OpenAI API key quickly. So in the other screen, I'll do it quickly. Just a minute. Okay, so I already set my API key, guys, all of you. So I'm not going to open this file. Otherwise, people will see my API key. You can create your own API key and you can paste it there. That's it. The first thing what I have to do, guys, I have to load this OpenAI API key. Okay. So to load it, you can execute this line of code. So here you can see, here I'm using python.env. So I think you remember, we install python.env. And with the help of .env, we can load any kinds of environment file. Okay, environment file. So here you can see I'm loading it. I'm using operating system package as well as the .env. And from .env, I'm loading load.env and find.env. So here you have to create one function of the load.env. Inside that, you have to mention this particular function find.env. That means automatically it will find this .env file inside your directory. Okay, and once it got, automatically it will load that inside my environment. And what I need, guys, I only need the OpenAI API key. I don't need anything else. Okay, if I open my, let's say this one .env, I think let me show you. So enter key is not visible. See, I only need the OpenAI API key. I also set my grok API key. But as of now, I only need the OpenAI API key. That's why here I'm calling. I only need the OpenAI API key. Okay, and I'm storing inside the variable. That's it. Now let me execute. See, successfully executed. That means it has successfully loaded my API key. Okay. Now before starting with our connecting with large language model, let me show you the list of the model can support like LangChain. LangChain can actually load all kinds of large language model. You can see this is the list of the large language model. If you open the LangChain documentation, okay, you can see this is the newest LangChain documentation. So here they have already mentioned inside LLM, it can also load AI to I large language model, LF alpha. Okay, see, then different large language model you can see. Okay, so 100 of large language model it can load. So let me show you the OpenAI. See, OpenAI also it can load. It can also load the Meta, Llama. Then it can also load the Mistral. Okay, all kinds of model it can load. It is also support grok API. So everything it supports. Got it. So if you want to see them, you can open this particular link and there you can see that. So let me add this link as well in the notebook. So here I can mention. Here I can mention. Okay. So this is the documentation. If you open the documentation, you will see that all kinds of large language model your LangChain can support. Got it. So that's why we call it as a universal framework. That means it can support any kinds of large language model, any kinds of tools and technology. Okay. But if you're not having the LangChain, that times we need to separately learn. Okay, let's say I want to load OpenAI model. I also need to learn the OpenAI framework for that. Okay, this is the main issue. It can also support Hugging Face. Okay, you can see Hugging Face model. It can also support. Okay, great. Now let me open the this one actually our OpenAI model. So I already told you OpenAI is having different kinds of model like chat model as well as the completion model. So first of all, we'll try to learn how we can load the completion model. So let me just comment here. So this is what completion model. Completion model. Okay, to load the completion model. So first of all, import the OpenAI from the LangChain. Just write from LangChain, LangChain OpenAI. Okay, LangChain underscore OpenAI. I want to import OpenAI. Okay. Now let me create a wrapper. I'll just write LLM model. And here I'll just specify the OpenAI. Okay, that's it. Now it will by default. Okay, it will by default load one completion model. Okay, you can also give the model ID here, but I want to load the default completion model. Now see if I execute, it will successfully load the model. And if you want to see the model configuration, you can also print this particular variable. See, this is the entire model configuration, but this will give you as a object. Okay, as an object actually it will provide you. So let me comment. So this thing I don't need. Now, let me first of all show you how we can interact with this particular model. For this, what you can do, you can use a function from this object called invoke. Okay, with the help of invoke, you can send the prompt. Let's say here I'll give one prompt. So let's say this is my prompt. Here I'm asking, tell me one fact about Kennedy family. Okay, if you don't know Kennedy, so let me search on Google. So you can see John F. Kennedy. So John F. Kennedy was an American politician, okay, who served as 35th president of the United States. Okay, so here I'll be asking the question related this Kennedy. Okay, Kennedy family. So here is my prompt, guys. You can see, tell me one fact about the Kennedy family. Okay, now see, if I execute, it will give me one response. Now you can see this is the response I got. But I'm directly printing the response. So I can also store it in a variable. So the variable name I'll give response. Okay, response is equal to my LLM response. Okay, whatever response actually I'm getting. That's it. Now let me execute it again. Okay, now you can simply print this particular response. So print response. Now see, this is the response I got from my large language model. And see, this model is about actually this model, a completion model. Okay, completion model. Got it? That means it will generate something for you. You can't perform the conversation with that model. Okay, conversation kinds of functionality you won't be getting in the completion model. I think I already showed you the dashboard. Okay, the playground. Now see, this is the output I'm getting. It's a one-shot output. Directly it is giving me the output. But whenever, let's say I'm opening ChatGPT. Let's say if I go to the ChatGPT, and if you give any kinds of prompt, let's say here if I give, I'll give the same prompt here. I'll copy. Sorry. I'll copy this prompt. And here I can ask. Now see, it will give me streaming output. See, it is a streaming output. See, it is streaming, right? So after one word, another word is coming. After one word, another word is coming. Okay, it is called streaming output. So can I also generate this kinds of streaming output? Yes, we can also generate. For this, we can use this particular syntax. So simply just write one for loop. So I'll just write a for loop. So for chunk, okay, chunk in LLM model dot, there is a function you have to use called stream. Okay, stream. Now inside that, you have to ask the prompt. Let's say whatever prompt I have given now. So let me give the same prompt again. So this is my prompt. Tell me one fact about Kennedy family. And this is a for loop. So it will have one indentation. Okay, now here I will print this one actually. Print the chunks. Then I will also need to give some parameter. So I'll give another parameter called end. End is equal to empty. And there is another parameter called flash. Okay, flash is equal to true. Now see, if I execute this code, you will see that I will also get streaming output. See, streaming output I got. So I think it was not visible. So what I can do, I can give any other prompt. Let's say I need detail response. See, it is streaming. See, it is streaming. Okay, I'm executing in the VS Code. That's why you can see it is streaming in this way. But if you're executing in that terminal, okay, inside your terminal, you'll see that it will give you streaming output. So let me also show you. Maybe I can create a file here or demo.py. So inside that I can execute the same code. This code I'll try to execute. Okay, now let me execute the file and let me show you. So Python demo.py. Now see, you will see that streaming output. See, it's a streaming output. Okay, like the ChatGPT. I hope you got it. And if you see the previous example, it will give you one-shot output. So now let's say you want to create an application and it will look like a ChatGPT, because streaming output, it looks good whenever it will generate the response. It is feel like it is generating real time. So that's why most of the application will be using streaming output. Fine. Now you can also set some configuration of your model. Okay, so let me show you. If I go to the playground again, see, it is also having some configuration. If I go to the completion model, see, it is also having configuration like temperature, maximum length. Okay, so these are the parameter you can also set. So you can set from the UI also. You can either set from the Python code. And if I want to set from the Python code, guys, what I need to use this particular syntax. So let me again initialize the model. So here I will initialize the model. So let's say this is my updated model right now. And inside that, you can pass any kinds of parameter. Let's say I will give the temperature parameter. So temperature I will give 0.9. Temperature is a creativity parameter. Okay, it's a creativity parameter. So temperature more or less you can give. If you are giving more, that means it will be more creative. If you are giving less, it will be less creative. Okay, I hope it is clear. So here I can write like that instead of, so creative model. Okay, now this is my creative model, because you can see I have initialized 0.9. Okay, 0.9 as my temperature parameter. Now see, if I show you the response right now from my large language model, so I will execute the same line of code. Here I can execute this line of code. Okay, so tell me about, now I'll be using this creative model. Okay, now you'll see that the response would be more creative than your previous one. Okay, now you can see the response would be more creative than your previous one. You can also give any other, let's say, prompt. Let's say I'll write a short 5-line poem about JFK. Okay, that means Kennedy. So you will see that it will give me the poem. So I can print it. So this is the point I got. And now see, I think you remember, if you're using older version of LangChain, whenever you will execute this code, you will get one warning here. Okay, deprecation warning. You will get deprecation warning. Now see, here I'm not getting any kinds of deprecation warning because we are using latest version of the LangChain. So this is all about our completion model. Now let's learn about chat model. Chat model. Okay, so I think you remember we are also having chat model. So different kinds of chat model, and the recent model they published called GPT-4o mini. So I'll also tell you how we can use this model as well. So first of all, let's use GPT 3.5 turbo model. Okay, we'll be using turbo model. So if you want to see the list of the chat model, you can open the documentation. So these are the documentation actually it is having. So they're also telling that's how you have to load this model. Okay, so create the chat. You need to use chat OpenAI function, but previously I was using this one, OpenAI only. But if I want to use chat model, I need to use chat OpenAI. You can see chat OpenAI. Inside that you can specify the model as well as the parameter. Okay, and you can see different kinds of chat model documentation they have already given. And again, I told you this LangChain documentation is not very organized. So if you are going for the first time, definitely will get confused. Okay, so first of all, try to see whatever I'm doing, then you can go to the documentation, then it would be clear for you. Okay, so now let's try to use the chat model. Now, as I already told you, if I want to use chat model, so I have to use this particular syntax. So from LangChain OpenAI, I have to import chat OpenAI. Inside chat OpenAI, you can specify the model. Let's say I want to use this GPT 3.5 turbo. Now you can simply go to the OpenAI model list. So OpenAI models. Okay, so you'll see that list of the models you will get from the OpenAI. So you can see this is a 4 series, but I'm using 3 series actually. GPT 3.5 turbo series. So we go below GPT 3.5 turbo. So here I'm using this model actually, GPT 3.5 turbo 0125 model. You can see this is the model actually I'm using, 0125 model. Got it? Now let me initialize the model. Now see, whenever I'm using chat model, so chat model can take how many input, guys? I think you remember, if I go to the playground, it can take 2 input. One is the system instruction, and there is the user instruction, user prompt. Okay, you can give any kinds of system prompt. You can also give any kinds of user prompt. So here also we can pass the same thing. So let me show you how we can pass. So this is the syntax. So first of all, you just need to create one list. Inside list, you need to create one tuple. Okay, inside the tuple, Here you can see I have given the system. That means this is the system instruction. And this is the system instruction I'm giving. You are the historian expert in Kennedy family, and this is the human prompt. Whatever prompt actually we are giving, this is the human prompt, and this is the prompt I have given. Tell me one curious things about JFK. That means Kennedy family. Okay. Now simply again you can use the same function, invoke function, and inside that you just need to pass the message. Now see, if I execute, you will get the response. Okay, so if I show you the response, see, this is the response. Okay, now if you only print the response, you will see that it will label like a AI message. Okay, it will label like AI message. Let me show you. So I can give the same prompt here. So I'll copy, I'll give it to the system instruction, and this one I will give it to the human instruction. Okay, now if I execute, see that as a user, actually it has taken my prompt. Now assistant. Okay, so ChatGPT will give you user and assistant, and whenever you are using LangChain will take as an AI message. That means whatever response actually it will give you as an AI message, and whatever response you are giving, it will take as a human message. Okay, I hope it is clear. So this is the labeling it usually do. Okay, now from the AI message, what I need, guys, I need the content, because see, inside content I'm having my response, right? Now if you want to extract the content, simply you just need to write response.content. Okay, response.content. Now if I execute, it will only give me the content right now. Now if you also want to see the metadata, you can also see the metadata, like how many tokens it has given you. Okay, how many prompt token, how many total token, how many completion token, all the metadata it will also provide you. Got it? And if you want to see the schema, you can also print the schema as well. So it will show you the entire schema. Like you can see title AI message, and this is the message it has given you. Okay, this is the entire schema. But only I just need the content. Okay, whenever you will be sending any request to the large language model, so you need the content as an output. Going forward, we'll be learning also LangChain expression language. There I'll also show you one amazing, actually, let's say, tools we are having called output parser. Okay, with the help of output parser, we can automatically get our response. Okay, without any kinds of object. So this will I'll also show you how we can do it. And now you can ask me how we can load this GPT-4o model. Okay, simply you can load this GPT-4o model. So let me give you that idea as well. So you just need to use this line of code. So let me comment. See, where you will see this other model, here you just need to change with this model, actually GPT-4o mini. That's it. Now if you execute this line, it will load that model for you. Okay, see, it will load that model. Okay, now we can try. So I'm not going to execute the model, guys. Now after the session, you can try with GPT-4o mini model as well. Okay, now if I'm talking about previous LangChain, guys, the older version of LangChain, old LangChain. So people used to write the syntax like that. So first of all, they used to import these are the library, human message, system message, okay, and chat prompt template, and they used to pass like that. See, system message, that means if you want to pass the system message, you have to pass is inside this particular function, system message. Okay, and if you want to pass the human message, you have to pass inside human message function. You can see the human message actually I'm giving. Okay, then whatever response you are getting, you are again storing to the response. But in the updated version, what they did, instead of using these are the functionality, you can directly pass here. You can directly pass as a list. Okay, you can directly pass as a list. Multiple prompt you can pass inside a list. You don't need to use these are the function again and again. Okay, that is the main advantage you will be using in the latest version of the LangChain. So these kinds of small modification, guys, they have only done. Okay, and rest of the concept will be remain same. Whatever logic you have learned in your previous LangChain also, it will remain same. I hope it is clear now. You see, if I execute this line of code as well, it will give me the same response. Okay, so this is the older syntax. Now let me show you the alternative. So what I can do, I can just write alternative LLM. Okay, so for alternative LLM, here we'll be using one API, free API called Grok. So let me open this Grok website. So let me also give you the link. So go to playground. So here I will also mention the link so that you can also log in with. and make sure you create one account first of all in the Grok. Okay, if you create one account, so you'll get this kinds of window. Now the first thing what you have to do, you have to generate one API key. Just click on the API key and create one API key here, guys. So for me, I already created one API key, and this API key I already set inside my environment. You can see. So this API key I already set inside my environment. See here, I have already set. Okay. Now I'll delete it after the session. Otherwise, people will be using my API. Don't use my API, guys. This is completely free. Just try to open up your account and try to create one API key. Okay. After creating, just try to paste inside your .env file, and you can see this is the playground. That means you can select different model. Let's say I want to use this Llama. Let's say I want to use this model, actually Llama 3.1, this model. Okay, this model I will select, and here you can give the system prompt. So I'll give the same system prompt. So let me go to my notebook. So I'll copy, and here I can paste, and then I will also give my human input. Okay, now simply if I submit, it will give me the response here. Okay, this is the response I got. The same way, whatever way you used to use ChatGPT, the same way you can use, but this is the free one. Okay, alternative one. Now with the help of Grok API, we'll be accessing different kinds of model. You can see we can access Llama model, we can access Llama model, Distill Whisper model. Okay, then we are also having Mistral model, Llama model. So all kinds of not all kinds of but some of the very good model are available inside this Grok API. Okay, and you can access through the API request. This is the main advantage. Now let me show you how we can access it. So we already installed the Grok here. You can see LangChain Grok we already installed. Now simply just load your environment again, because it should load your Grok API. It will load your Grok API. Okay, automatically it will load your Grok API. Okay, then after that you have to use this syntax. So from LangChain _Grok chat Grok. Inside chat Grok, you need to give the model ID. Okay, you can see I'm using Llama 3 7B 8192 model. Okay, you can see here this model is also available, I think, somewhere. See this model, I think. Let me show you. 7B 8192, 7B 8192, 7B, yeah, 8192. So this model actually I'm using. You can also load any other model. You can also load Mistral model. Mistral is also having. You can also load the Mistral model. I'll also show you how we can load the Mistral model. First of all, let me load this model. Okay, so this is the Llama model. And if I want to load the Mistral model, simply give the Mistral model ID. See Mistral X 8X 7B 32768. So if I show you, so this is the model. Mistral, this model actually I'm loading. So any kinds of model you can load. Just give the model ID. That's it. Now see, both model I have loaded. Now again, let me pass the prompt. And how to pass the prompt, guys? Because this is a chat model. Again, I have to pass as a list. The same thing we did in the OpenAI. The same thing we have to follow. First of all, I have to give the system prompt, and I have to give my user prompt. Okay. Again, I'm giving the same thing. You are the historian expert in Kennedy family. How many members of the family died in tragically? Okay. Now if I execute, then now I'll pass this prompt inside my LLM. So chat. I'm first of all using Llama model, llama.invoke. I'm giving the message, so it will give me the response. So you can see the response content. See, okay, amazing content we got. Now we'll also use this one, Mistral model as well. So let me also show you the Mistral model. So Mistral, I'll give the message, and this is the Mistral model response. Okay, and see the execution time is very, I'm very fast here. Okay, very fast here. But if you are downloading these are the model from the Hugging Face and you are executing in your local machine, you won't be able to do it. Okay, you need a good configuration machine at the end. Okay, now see guys, this thing is very important, because going forward, whatever things we'll be doing, we need the large language model. Either we'll be using OpenAI model, either we'll be using, these are the alternative model. So both I have showed you. Now if you have OpenAI account, you can use OpenAI model. And if you don't have an OpenAI account, you can also use, these are the model. Okay, Grok API you can use. So based on that, we'll be learning prompt template, chains, output parser, okay, RAG. So these are the different things we'll be learning inside LangChain. Because many people will get confused. Okay, how we can access, these are the model. Okay, what is the technique we can access? So this is what I just wanted to show you today. And this should be our foundation. With the help of this foundation, we'll be working later on. Okay, everywhere, whatever example I'll show you now, everywhere, this thing I don't need. So everywhere you'll see that I will be using this syntax. This syntax actually will be mostly using chat model, not the completion model, because nowadays people are using chat model. completion model people are not using. It is deprecated. Okay, you have to use the chat model most of the time. So we'll be using chat model most of the time, whether I'm using OpenAI model or whether I'm using any other model. Okay, we'll be using chat model most of the time. Next session, we'll be learning about the prompt template in detail. What is prompt template, what is chains, and what is output parser. Okay, then we'll be also moving to the new concept of the LangChain. So guys, now we'll be learning about prompt template inside LangChain. Because I think you know, if I want to use large language model, I have to pass the prompt. Okay, and to pass the prompt, I have to follow some specific template. So this is called prompt template. So with the help of this prompt template, we'll be integrating all the logics. Then we'll be passing this logic into our large language model. So let's try to see some practical demo of this prompt template. Then I think this part would be more clear. So first of all, let me start with the prompt template. Okay, prompt template. So see, as of now, I think we already saw, if I want to work with the large language model, so what I need to give, definitely I have to give the prompt. So prompt is everything inside large language model. Okay, that means prompt is nothing but, so prompt is nothing but it's a I mean programming language. You can talk about it's a programming language for LLMs. Okay, to perform communication. Okay, so this is called prompt. And now what is prompt template? Prompt templates. Okay, so prompt template is nothing but it's a template. Okay, template means, so here you can pass any kinds of variable. Okay, you can pass any kinds of variable during execution of your code. That means during runtime of your code, you can pass any kinds of variable as an input. Okay, that means you can create a template here. It's not like that you need to always directly pass. Let's say this is my large language model, LLM. Okay, so let me just write, this is my LLM. Okay, so it's not I mean always it's not actually necessary to give the prompt directly. Okay, so you don't need to give the prompt directly as a hard coded. Okay, and you don't need to get the output. Sometimes what you will be doing, you will be creating a template. Instead of giving the hard coding prompt, you will be creating the template so that user can give some input, okay, in real time. And this input actually will change actually real time inside the prompt template, and this prompt actually will be passing to the large language model. So let me show you one example. Let's say let's say I want to design a prompt. Let's say tell me about dash. Okay, tell me about dash. So here I can pass anything. Let's say tell me about India. Okay, then I can also pass tell me about, let's say JFK. That means Kenny's family. I think you remember I was giving some example. So Kennedy family. Okay, Kennedy is actually president of United States. Then I can also pass tell me about, let's say, Tesla. Now you can see this particular prompt is remaining same everywhere. So let's say this is my first prompt, this is second prompt, this is start prompt. So in three prompt actually you can see this part is common, okay, for all the prompts, but here it is only changing. Okay, this part actually it is changing. Okay, this part is changing. So what I can do, instead of, let's say, creating multiple time, okay, this prompt, I can create a template. That means I will create like that. Let's say tell me about, so it would be dash. Okay, so here I'll take the input from the user. Okay, here I'll take the input from the user. That means whatever input user will give me, let's say input is equal to, let's say, India. So what will happen, this input will go to this particular, let's say, curly brackets. I think you learn about f string inside Python, yes or no? Inside f string also we used to pass the input like that. If I want to take any input real time from the user, and if I want to, let's say, modify this particular string, that time I used to use f string. So this is the similar kinds of f string only. Okay, so here we'll be creating a template. Instead of passing that direct prompt, you will be creating a prompt template here. And if someone is giving any kinds of input, this input you will be accepting, okay, and you will be passing it to the template, and this template will create the entire prompt and will pass to the large language model. Okay, then you will be getting the output. So I'll show you some example. After getting the example, it would be more clear. Okay, so let me open up my what I can do. I can open up my code. So this is my VS Code. So here I'll create a file. I'll name it as 02 talk with LLM part 2. I can give part 2, you can give any name. Let's give part 2 only, YNB. So here, first of all, I'll be selecting my kernel. So I think you remember we created this LLM app, okay, this particular environment. Okay, so the first thing, guys, what I have to do, I think you remember, first of all, I have to load my environment, okay, environment file, because inside that I'm having my OpenAI API key and Grok API key, right? So either you can load your OpenAI model, either you can load any kinds of Grok open source model. So I already showed you both of the example. Now, if you don't have the OpenAI account, you can load the Grok model. That means any kinds of open source model, you can load Llama model, Mistral model, it's up to you. Either you can load the OpenAI model if you already have the OpenAI account. So for me, I already have the OpenAI account. I'm going to open up my, I'm going to load my OpenAI model. So for this, I'm going to open, let's say, load this particular OpenAI API key. Okay, you can see I'm loading the OpenAI API key with the help of load env package. Okay, so I'm loading it. Then after that, what I need to do, guys, I'll be loading my large language model. And how to load the large language model? So first of all, I'll load my this model, completion model, completion model. Okay, so what is completion model? Completion model is nothing but it's a simple LLM model. I think I showed you the difference between completion model and the chat model. So I think you remember. So if you don't remember, let me again show you. So you can open this playground of the OpenAI. So this is the playground, guys. So here you can see, guys, you have the completion model. Okay, completion model. So it will only do the completion operation. Let's say if you give anything, it will complete that particular, let's say, sentence, or let's say story, whatever. So here you can't perform the conversation. Okay, conversation kinds of things you can't perform here. But whenever I'm talking about chat model, here you can perform conversation. That means it will work as an assistant. That means here you can pass the system instruction as well as the user instruction. Both you can pass. Okay, so this is what actually you have to remember always. So we are having two kinds of model. One is completion model, and that is like chat completion model. So most of the time we'll be using chat completion model, because nowadays whatever large language model you can see in the market, all the model has trained with the chat completion model. That means with the help of that, you can perform the conversation, and you can also perform different kinds of tasks. Got it? So first of all, let me show you how we can create the prompt template for the completion model. Okay, first of all, we'll be learning the completion model. Then I will also show you how we can perform for the chat completion model. Okay, both will be exploring one by one. So first of all, let me load the completion model. And if I want to, first of all, I'll be loading the completion model. And if I want to load the completion model, this is the syntax from LangChain OpenAI. I'm only importing OpenAI. Okay, and it will load the default model. I think Babbage 003 model, it will load. I'm not sure, but you can see, check the documentation. So in the documentation, they have already written, okay, which model actually they will be loading. Apart from that, I also need to load my chat completion model. So let me also comment here, chat completion. Okay, chat completion model. So this is the syntax to load the chat completion model. So here you just need to import this particular function called chat OpenAI. Inside that, you can give the model ID, which model you want to load. So here I'm loading the GPT 3.5 turbo model. Okay, I already showed you the model list. Inside that, you can select any kinds of model. It's up to you. So both model, I'll try to load it. Then first of all, I'll show you how to create the prompt template. Okay, let me comment here. So prompts and prompt templates. Okay, so this is what actually we'll be explaining here. Okay, now if I want to, so let me just delete this one. It's not required. So if I want to create a prompt template, so I need a function from the LangChain. So just try to import LangChain underscore code dot prompt. Okay, prompts. So here you need to import prompt templates. See, the prompt template actually I'm creating, this is for completion model. Guys, try to remember. Let me just comment here. This is for completion model. Okay, completion model. So for completion model, you have to import this particular function called prompt template. Okay, now let's create the prompt template. So here I'll just take a variable called prompt underscore template. Okay, prompt template, and there is another function you will get called from template. Okay, from template. Inside that you have to pass the prompt. Let's say here I'll give one prompt. Tell me a let's say you can give any kinds of, let's say, variable name. I'll give, let's say, adjective, story. Okay, story about a certain topic. So here I can mention this variable name as a topic. Okay, that means these two would be input from the user. So user can give any kinds of input in this actually bracket. Okay, you can see this is the variable I'm taking called adjective, and this is the variable I'm taking called topic. That means if you complete this particular, let's say, prompt, let's say, tell me about, tell me a curious story about Kennedy family. So this will become a complete prompt. Now you can pass any kinds of input, okay, based on your choice. Okay, what kinds of, let's say, story you want. Okay, you can modify here. That is what actually we call it as a prompt template. Instead of hard coding them, what I'm doing, I'm creating as a input. I'm creating as a variable so that user can pass the input and they can get the response from the model. Okay, this is what actually we are doing. Now this is the template we have created. Now how to, let's say, pass the input. Okay, how to pass the input inside the prompt template. For this, let me create an object. I'll just create object LLM model prompt is equal to, so prompt template dot format. Okay, format. So if you have already learned the Python, guys, if you have learned the string, I think you know what is format, dot format, what it does usually. Okay, so inside dot format, I'll pass, these are the value one by one. So let's say adjective is equal to, I'll give curious. Okay, curious. And topic is equal to, let's say, I'll give the Kennedy family. Kennedy family. Okay, now you can give any kinds of input. It's up to you. Now if I want to pass to the large language model, what I'll do, guys, I'll call my large language model. So I'll call my completion model. Okay, not the chat completion model. So completion model is my LLM prompt. Okay, LLM model prompt. Now see, if I execute, it should give me the answer. Okay, see guys, it is the answer. You can also store in a variable. Let's say I'll store in a response variable. And now you can simply print this response. See guys, this is the response I got. So that's how we can create a prompt template for the completion model. Now see, here I can give any kinds of input. Let's say I can give the topic anything. Let's say I can give Tesla. Okay, Tesla. Now if I execute, see, it will tell me about the Tesla. Okay, curious story about the Tesla. See, okay. Now see, as a user, okay, let's say as an user, I can pass any kinds of input. Now I have the flexibility here. But previously, what I used to do, I was to pass the prompt directly. You can see, I was to pass the prompt directly. That means hard coding. I was hard coding. Let's say I want to change the prompt. What I need to do, I need to come here. Inside that, I need to change the prompt. Okay, but here I created a template. That means this will be my structure of the prompt. And now we can pass any kinds of input. Okay, wherever actually we are creating this particular bracket. That means whenever we are creating this particular template. Got it? And here you can pass any kinds of input. So let's say whenever you will be creating any kinds of web application, that time you can take the input from the user and you can just replace here that variable. Okay, this is the idea. And this is what actually we created for the completion model. Okay, if you are using completion model, that time you will be using this template. Now I'll be discussing about the chat completion model. Okay, how to create for the chat completion model. But mostly we'll be using chat completion model, guys, because I already told you all the models. Nowadays you will see the chat completion model. Okay, not the completion model. So now let's see how we can create for the chat completion model. Okay, for chat completion model, so again you need to import one function from the LangChain core. So LangChain core dot prompts. So I need to import chat prompt template. Okay, this is the function, guys, chat prompt template. And the previous word I imported called prompt template. Now this is what actually called chat prompt template. Okay, this is the different only. Okay, let's try to remember. Now let's create the chat prompt template. So here I already created. So let me show you how it will look like. So this is the prompt template, guys, I created. I think remember whenever I was using the chat model. So here, let me show you the chat model example. Yes, so this is the chat model example. So here I can pass the prompt. How many prompt I can pass, guys? I can pass two kinds of prompt. One is the system prompt, one is the user prompt. So if I go to the playground, I think remember, I can pass the system instruction, I can pass the user instruction. Okay, that means two prompt this particular chat model can support. Chat completion model can support. Okay, so that is why I was passing this two prompt. I think you remember here. I was passing this two prompt. One is the system prompt and this is like our user prompt. That means human prompt. Okay, now here you can see I'm passing the same thing. First of all, I'm giving the system. Okay, system instruction, that means system prompt. So here I'm writing UR and profession. Okay, profession is my variable. That means it is my input variable. Now user can pass any kinds of, let's say, input here. Let's say here user can pass UR and let's say history. Okay, historian, let's say historian expert on the, let's say, Kennedy family, or let's say Tesla. Anything user can pass. So profession wise they can pass, let's say, historian. Topic wise they can let's say pass Canadian family or let's say Tesla. Okay, whatever let's say input user want to give, they can give here. No need to worry. Then human. So human, let's say this is the human prompt I am giving. Hello, Mr. Let's say historian, or let's say anything you can give, anything you can call. And can you please answer a question? Okay, let's say this is the question human is asking. Then again, AI is giving me the answer. Let's say AI, sure. Then human input. That means here I'm passing few short prompt. Okay, I think you remember, guys, inside prompting, we are having some kinds of prompt. So let me just write down. So I'll be also discussing this prompt engineering later on. So there actually will get the idea. So here I can, let's say, give prompt engineering. Okay, prompt engineering. Inside prompt engineering, you are having some types of prompt, like you are having zero shot prompting. Okay, zero shot prompting. You are having few shot prompting. Okay, few shot prompting. So here I'm passing few shot prompting. That means I'm giving few shot. Okay, few shot. That means my model will try to understand, okay, I want to do a conversation. Okay, conversation with the large language model about the this particular, let's say, topic, this particular profession and this particular topic. Okay, and this topic, this profession and topic will I will get input from the user. Okay, this is the idea. Now let me show you how we can pass this. So this is the code. So here you can see I'm calling the chat template, then format masses. So profession is equal to I'm giving historian, topic is equal to I'm giving Kennedy family, and this is the input. I'm asking how many grandchildren had Joseph P. Kennedy. That means how many children, okay, he was having. So this is the question actually I'm asking, because I already told my large language model you are an expert historian about Kennedy family. That means it will only give me the Kennedy family related let's say response, because I already given in the system instruction. Okay, system prompt. Okay, this is called actually chat completion model. That means you have the flexibility. You can give the model, okay, as a power to a specific topic. Okay, I think it is clear now. Now, if I want to pass this message to my large language model, again, I'll call the same thing, chat model.invoke. Now, see, I'm calling the chat model, not the LLM model. Okay, I'm calling the chat model. So chat model.invoke. Inside that, I'm passing this particular message, the prompt template I created. So this is going to be my entire prompt template. Now, see, if I execute, and before that, I will also print the response. Okay, now see, if I execute, it will give me the answer response. See, guys, this is the response I got. Okay, this is the entire response I got. Now again, you can see it is giving me content. So if you only need the content, you can call like that. So I only need the content. Now see, it will give me the entire string. Got it? So this is what actually we can do in case if I want to create the chat completion model prompt template. And this approach actually will be using a lot. Okay, with all kinds of actually chat model. And let me show you how people used to do in the older way. So old way to create the prompt template. See, this is the snippet I collected over the internet. See, this is the old way to create the prompt template. So first of all, you have to import system message from the LangChain core message and prompt human message prompt. Now you'll be creating the chat prompt template, and here you have to pass as a system message. That means the system instruction I was to pass, now this one. Okay, I have to pass inside this particular function, system message. You are an historian expert on the Kennedy family, and they used to give as a hard code. Okay, you can see it's a hard coded, let's say, prompt. Then as a human, whatever human message actually you want to pass, you have to pass inside this particular function called human message prompt template. That means this one. Okay, this one. You have to pass inside that. And whatever input user will give, that means this input. Okay, so you have to pass it here. Now, this is the input, guys. The name of the children of the Joseph Kennedy family. Okay, now see if I execute, it will give me the output. It will also work. There won't be any kinds of issue, but again, this is a older approach. And you can see this approach is a little bit, what I can say, confused to understand. Okay, if you see, it's like more tricky. So you have to use some external function for this to create the prompt. But if I'm talking about this one is like more easy to understand. Okay, so inside this list, you can pass the tuple, multiple tuple, and you can simply create the format, and you can pass this particular format to the large language model, and it will give you the output. But here, in case you have to use so many functions and you have to prepare the prompt. Okay, this is not actually good way to define the prompt. So if you want to print the content, so simply you can write like that. So see, this is the entire content you will be getting. Now, let me show you another few short prompting example, how we can create. So inside LangChain code prompt, I am having one function called few short prompting. Okay, see, most of the time you will be using this approach actually instead of this approach. Okay, this approach, you can use this approach if you want to create a few short prompting. So you can see few short chat message prompt template. Okay, now inside that, first of all, you have to give the example. So this is the example. So here I have given some example. Let's say input hi, output hola, then input by, output, let's say adios. I don't know how to spell this, but this is a Spanish. Okay, Spanish actually, let's say a sentence. Okay, Spanish, let's say language. That means here I want to create a language translation. Okay, language translator. So that is why I'm giving some few short prompt to my large language model. I'm telling, so if user is giving any kinds of English sentence, you have to convert it to the Spanish. Okay, so that's why I'm giving some few short. You can see two input I have given. If it is more than one, that means it's a few short prompting. Got it? So this is the example. Then after that, I'll create one chat prompt template here. So chat prompt template from message. So user will give the, okay, let's say as a human, you will give the input and AI will pass you the output. So this is the structure you are creating. Okay. After that, you have to prepare the template. So for this, you can use this particular syntax. So few short prompt template. Inside that, first of all, you will be passing the example prompt. Okay, the example prompt you have created. Then you have to also give the example. That means your model will try to understand, okay, so user will give me the output, input, and I should return the output. Okay. And what kinds of, let's say, task you want to perform? You want to perform these kinds of tasks. That means if user is giving any kinds of English text, I have to convert it to the Spanish. Okay. So it will be learning from the few short prompting. Okay. This is the idea. Now let me create my final prompt. So to create the final prompt, you have to use this particular syntax. That means chat prompt template from message and system instruction. First of all, you have to give, I think, remember chat model text as system instruction. So this instruction you have to pass. So you are an English Spanish translator, and then you have to pass the few short prompting. The prompt template you have created, you have to pass it here. Then whatever input user will give, this input actually will be passing it here. Okay. Now you can ask me how we can pass to the large language model. Okay. How it can be passed to the large language model. For this, you have to use one amazing, let's say, technique called chain. Guys, now we'll be exploring the chains inside LangChain, because inside LangChain, chains is everything. With the help of chain, actually, you'll be executing all the action. So we'll see this chain in detail. For this practical demo would be better. So let's try to see some demo. What is chains inside LangChain and how it works. We'll be learning about chains right now. Okay. So with the help of chains, actually, we'll be executing this particular prompt template. And what is chains? Chains is nothing but it's a let's say actions. Okay, executable actions. That means it's a step of execution. So first of all, which chain would be executed? So I think you know inside LangChain everything is all about chain. So let me just open up my Blackboard. Let's see. Whenever you are talking about LangChain, so here everything is a chain. Let's say whenever you are preparing the large language model. So this is one executable. Okay, executable. Or you can also call it as runnable. Okay, runnable. That means it can execute. It can execute itself. But if I want to execute the large language model, what I need, guys? I need the prompt. Okay, I need the prompt. So this prompt I will pass to the large language model. Large language model, what it will give me? It will give me some response. Okay, response. Or output, you can also call it as output. Okay, output. Then with the help of output parser, we can format what kinds of output I need from the large language model. Okay, so these three things is important. So one is the prompt, one is the large language model, another is the output. That means output parser. Okay, so if you have these three things, and if you can create these three at least chains, you'll be able to execute any kinds of large language model. Okay, let me show you one example what I'm trying to say. So here what I can do, I can copy the same example and here I can paste. Okay, now see, this is the chains, and this is the latest LangChain syntax, guys. Previously we used to use the chain function from the LangChain, but nowadays you will be using this particular syntax. So first of all, take a variable. You can take any name. I've taken chain. Then first of all, you have to give the prompt. Okay, so prompt, where it will go to the large language model. Okay, so you have to give this pipe symbol. Pipe means this is the chain, you are creating the chain. That means after this executable, okay, your LLM executable will start. So LLM, so not a LLM model, it's a chat model, because I'm using chat model. Okay, now see what is happening. First of all, your prompt would be executed. That means whatever user will give, let's say user has given, let's say how are you. So what will happen? Your model will get how are you sentence, and this how are you sentence will go where? It will go to the large language model. Okay, so large language model take this input and it will give you one output, okay, which is nothing but your output. That means the response, and this response I can also form it with a specific, let's say type. Let's say I want to get the JSON output, I want to get, let's say, text output. I can also give the format with the help of output parser. I will tell you about the output parser. As of now, I'm not telling you about the output parser. I'm only telling you how we can create the chain. Okay, how it create the chain if I want to execute my prompt template. This is the idea. Now see, if I now execute chain dot invoke. Okay, chain dot invoke, and here I think remember user will give what? User will give the input. So inside that you have to pass the input. So input. So make sure it should be a dictionary. Okay, so here you can pass any kinds of input. So I can pass, let's say, how are you. So let's say this is my input. Okay, now see, if I execute the program, it will give me the response. See, this is the response, and this is the Spanish of the how are you. This is the Spanish of the how are you. Now let's say I only need the content. In case, what I can do, guys, I can store inside a variable called response. Okay, and this response I can print simply. So print response dot content. See, this is what actually I will be getting. And if you want to see the entire response, this is the response. This is the entire response. Okay, you can also see the metadata and all, like how many tokens it has given you, every information actually it will also show you. Got it? So this is called chain, simple chain, and no need to worry, I'll discuss the chain in detail. And this is what actually your this one actually LangChain expression language syntax. Okay, the syntax we have written, this one, this is called actually LangChain expression language syntax. That means this is the newly, whatever, let's say, updated LangChain you can see. So people are using this particular syntax, but previously we used to use something called chain. Okay, chain function from the LangChain, but nowadays we don't use that. We create this particular, let's say, pipe symbol. Okay, with the help of pipe symbol we define this is nothing but my chain. That means after this prompt my model will be executed. That means whatever prompt user will give, this prompt would be executed inside the model. Okay, this is a step of execution. I think it is clear. A very important concept, guys, because this is the basic. Okay, whenever I'll be discussing about LangChain expression language in more detail, that time this concept will help you a lot. Just try to, understand, okay, what I'm trying to say. I'll discuss in more detail what is LangChain expression language. I'll also show you what is runnable, what is let's say like executable, different things I'll show you inside that. Okay, so then this part would be more clear. As of now, I only showed you the simple syntax, how we can create the chains, okay, with the help of pipe symbol. So that means what is happening. So let me open up my Blackboard again and let me explain. See, I think you remember. So here we created what? We created this particular prompt template. That means as a system instruction I have given, you are an English Spanish translation, and user can give any kinds of input. Let's say whenever I have given, okay, whenever I have given how are you. Okay, how are you? Let's say this is the user input. How are you? Okay, this is the user input. And how I created the chains. I think you remember how we created the chains. Let's say chain is equal to, first of all, it will take the prompt. Okay, prompt. then I given the pipe symbol, then I executed my chat model. Okay, chat model. That means this is the prompt user has given. That means inside prompt, that means prompt is equal to would be how are you. Okay, and this how are you will pass where? To the chat model. It will pass to the chat model, and chat model will give you the response, and this is what actually we are storing inside response. Okay, I think remember we're storing inside the response. Okay, response will have some of the response. That means it will have some metadata as well as your content. And if you just write like that, response dot content, okay, here you will get the Spanish. Okay, Spanish sentence of the how are you. Okay, Spanish sentence of the how are you. This is what actually it is happening. That means this is going to be my chain. Okay, this is my chain. That means after prompt is executing, then after that LLM model is executing. Now we can create like multiple chain here. You can give another pipe symbol, you can add another executable here. You can give another pipe here, you can also give another executable here. Okay, that's how you can create a complex chain also. Okay, multiple chain also, it is also possible. And this part I will be also discussing whenever I'll be discussing about this one, LangChain expression language. Okay, that means LEC, LangChain expression, LECL. Okay, LangChain expression language. So here actually I'll be discussing more about it. Okay, how to create the, let's say, complex, very complex chain, how we can create multiple runnable and all, everything I'll try to discuss here. Even you can also check the documentation, chain in LangChain. So this is the older version of the LangChain. You can see this is the older documentation. So they're using this chains function. Okay, but I need the latest one. So here I can search simple chain action. I think I saw somewhere. So that's why I told you this documentation is still terrible. It's not actually organized. Okay, so if you're finding something, so it would be hard for you. So here you can see, guys. So they're using this pipe symbol. Okay, so retriever, prompt, model, output parser. I'll tell you what is this retriever, prompt, output parser. So this is like more complex chains they have created with the help of multiple runnable. Okay, so whenever we'll be creating the RAG application, that time I'll tell you, okay, what is a retriever. Then so this is what we have created, prompt and model. Okay, prompt and model. I haven't showed you the output parser as well. Output parser I will also discuss. So that means I'm just giving the prompt directly and to my model, and model is giving the output, and this is what actually I'm storing in the chains. Okay, see. Okay, that's why I need to write this line. So result.content, then it will give me the content. But with the help of output parser, I can directly get the output. Okay, and with the help of output parser, you can also specify the format, what kinds of format you need as an output. Okay, this is also possible. So let me show you one example of the output parser. Now we'll be exploring about the output parser inside LangChain. Let's say you want to reformat the response of the large language model. That time you can use output parser. Okay, inside LangChain. So with the help of output parser, you can reformat the text in any kinds of format, whether it's a JSON format, TXT format. Okay, anything you can perform. So let's see the demo of the output parser, how it can be used inside LangChain. Okay, output parser. So again, let me initialize my chat model. So I'm going to initialize this OpenAI chat model. So GPT 3.5 Turbo 0125. This is the chat model. Then let me show you one example of the parsing output. So here I already created one example. Let me show you. So this is the example, guys. So you can see, first of all, I'm importing this prompt template. Okay, prompt template. And this prompt template I'm creating from template. That means inside that I'm passing one prompt. So return a JSON object with an answer key that answers the following questions. That means I'm telling my model I need a JSON object output. Okay, JSON object output of the following question. That means and to get the JSON format output, you have to import another function from the LangChain, output parser.json. So called simple JSON output parser. You can see I'm initializing this object. Then I'm creating the chain. So first of all, I'm giving the JSON prompt. That means this particular prompt. Then I'm giving the LLM. That means my large language model. So here what I can do, instead of chat model, maybe I can use this model. First of all, I will show you the this model. my LLM model. That means my completion model. So I think you remember this prompt we have created for the completion model previously. So let me show you again. So for completion model, so you can see I'm using prompt template. Okay. And for chat model, I was using chat prompt template. Okay. This is the difference. So first of all, I'll show you the prompt template with the help of this one, completion model. So you can see I've created the chain, and this is the output parser. That means the output parser we have created. That means the output actually my model will give me. This would be a JSON output. Now let me show you. So if I execute the program, now I'll give the input to the model. So here is the input I'm giving, JSON chain dot invoke, and this is the question I'm giving. Okay, the question actually user will provide. What is the biggest country? Now see, if I execute, the output should be a JSON. See, this is the JSON output I got. So this is the key and this is the value. Now if you want to check the type, you can also check the type. For this, you can store inside a variable, and simply you can see the type. See, this is a dictionary. So dictionary is nothing but it's a JSON only at the end. Okay, you can directly convert this dictionary to the JSON, because you can see dictionary also having key value pair. Okay, JSON is also having key value pair. Okay, both are same. That means you can also specify the format. What kinds of format output you need from your large language model. Okay, so this is called actually output parser. Okay, with the help of output parser, you can do it. Got it, guys? So previously I didn't use any kinds of output parser. That's why it was giving me this kinds of response. That means AI message. Okay, AI message object response. And if I want to get the content, I used to call the content. Okay, you can see I used to call the content. But now the output I'm getting, it is returning as a JSON. Okay, it is returning as a JSON because you have specified return a JSON object with an answer key that answers the following questions. And here you have specified the output parser, which is nothing but simple JSON output parser. Got it? So this is what actually you have to remember. And we can also customize it, okay, as per our requirement. Okay, we can also customize it as per our requirement. Let me show you another example. So this is like more advanced one. If you are creating something, let's say you need complete customization output, that time you can do it. So you can use something called pydentic, let's say function from the LangChain to do this. Okay, let me show you. If you want to create any custom output format. So first of all, let me import. These are the library. So I'm importing JSON output parser, and from prompt I'm importing prompt template, and LangChain core, you can see I'm importing pydentic v1 base model and field. Okay, now you have to create a class. So this is the class. So I've created a class called joke. You can give any kinds of name as per your project requirement. I've given a joke. Now you have to inherit with the base model. Okay, base model, whatever model you have imported from the pydentic. And what is pydentic, guys? This is the Python concept. Okay, if you want to understand, you can simply search over the Google what is pydentic inside Python. You will try to understand. Okay, with that of pydentic, we can create a specific format. Okay, this is also possible. And for this, you have to inherit with the base class. Inside that, here I'm creating two variables called setup and punchline. And this variable type is string. Here I have said this should be a string type. Inside field, you have to give the description. So this is the description I have given: question to set up a joke, and inside punchline I have given answer to resolve a joke. Okay, this is my class I have prepared. Now what I will do, this one I will pass to my LLM, but I have to pass as a JSON output parser. Now see, the JSON output parser I imported. Inside that, you have to give this pydentic object is equal to this class, the class actually you have created, the custom class, and prompt template. Okay, so this is my template, answered the question, that means format instruction. So what is format instruction? Let me show you. So let's say if I execute this one, if I execute this JSON parser, let's say JSON parser dot get format instruction. See, what is telling? It is telling a return a JSON object. So here you already given the prompt, return a JSON object. Okay, so if you call this method get format instruction, that means it will also return the same thing, return a JSON object. So this logic actually we are applying here. So you can see parser, the parser we have created, I'm calling get format instruction. That means it will tell you it should be a pydentic, okay, pydentic format. That means the custom class you have created, this particular format. Okay, so this is what actually it will accept. Here it will accept. Then input query, whatever query user will input, and the format instruction. So the get format instruction. So this logic actually, okay, that means you are telling it should be a custom, okay, custom format, the format you want to create. Now here I'm creating the chain. So first of all, I'm giving the prompt, then I'm giving the large language model, then I'm giving the parser, the custom parser I have created, okay. Then I'm doing the invoke operation, chain.invoke query tell me a joke. Now see, if I execute the program, now see the format you have specified, it will give you the same format output. See, setup, I think you remember setup, okay. Question to set up a joke. So this is the question to set up a joke. So why couldn't the bicycle find its way home? And here is the punchline, answer to the resolve the joke. Now you can see, because it's lost its bearings. Got it, guys? And now whatever specified format you have given, okay, the same format is giving you the output. So this one is more advanced one apart from this one, okay, this one. And no need to worry if you are getting it difficult. I will discuss this chain in detail. That time it would be more clear. Whenever we'll be starting with the LangChain expression language, that time it would be more clear, okay. So if you go to the code, I think you will be able to understand. It's not very complex, okay, whatever things I have written. See, this one is the pre-built one. That means I'm simply calling the simple JSON output parser, and my model will give me the output as a JSON format. But if I want to create my custom output format, that time I can use the pydantic. Okay, I can create a class. Inside the class, I can specify how many variable I want. Okay, how many variable I want, and what would be the format, what would be the data type. You can specify everything. Then you need to use the same JSON output parser. Inside that, only you just need to mention the pydantic object is equal to your class, the class you have developed. Then you have to create the prompt template. Inside that, you will be giving this particular get format instruction. That means the parser, that means you are telling this class I want to use, this let's say format I want to use as an output, okay. Then whatever user will give that, it will go to the prompt, then prompt will send to the large language model will give to the parser, and parser will give you the output. And inside parser you have already set it, okay, your custom prompt template. So guys, now we'll be discussing about how we can work with our custom data, because so far actually we did the inference operation with our large language model. But let's say you have some custom documents, and how you can pass these custom documents to the large language model. Let's say you are having PDF document, TXT document, CSV documents, HTML documents, okay, any kinds of file format. So how we can load these are the documents. Then I'll be also discussing about the basic RAG concept, because whenever we use our custom data, we have to follow some certain step. Okay, this is called actually RAG concept. So I'll give you the basics idea about the RAG concept. Then next we'll be also discussing about this RAG in detail. We'll be also implementing the RAG, okay, as a practical way. Then I think this part would be more clear. So let's see how we can work with our custom data. So if you have any custom data with any kinds of specific format, how we can load with the help of LangChain. So first of all, I'll be discussing about data loader. Okay, data loader. That means how to work with custom data. So it can be any kinds of format. It can be PDF format. It can be, let's say, HTML format. It can be, let's say, JSON format, Excel format. Any kinds of data you can consider in that case, right? Now the second thing I'll be discussing about what is RAG. That means introduction to RAG. And what is the full form of RAG? Retrieval. Okay, retrieval augmented generation. Okay, retrieval augmented generation. Then third, we'll be discussing about splitter. That means we'll be breaking down this RAG. Okay, so let me just write down. Yeah, so we'll be breaking down this RAG, and inside a RAG actually we'll see different kinds of component. The first component we'll be discussing about, which is nothing but splitter. Splitter. Okay, then the second component we'll be discussing about embedding. Then we'll be discussing about vector store. Then we'll be discussing about retriever. Okay, retrievers. Then once we got the understanding of this, there is another topic we'll be understanding called top K. Okay, top K inside a retriever. Okay, what is top K inside retriever? I'll try to discuss. Next session will be learning one RAG demo. That means I'll show you one RAG application. Okay, RAG with LangChain. Okay, LangChain expression language. That means we'll be building one RAG system. We'll be using our custom data and we'll be building the RAG system, and we'll be using this LangChain expression language there. Okay, our new LangChain syntax we'll be using to implement the entire, let's say, RAG system. Okay, so this is the idea. Okay, fine. So now see, as of now, I think you remember, as of now, what we have done, we have only done the generation, okay, with the help of large language model. Let's say here we are having one LLM. So as of now, what we have done, we have given a prompt. Okay, we have sent a prompt and my model was giving me some response. Okay, response. And to give the response, actually, that actually information it is using. Okay, so it is using pre-trained knowledge. Pre-trained knowledge. That means during training these kinds of large language model, let's say if I'm talking about GPT 3.5, okay, GPT 3.5 Turbo. So whenever I'm talking about this model is already trained with some data set, right, over the internet. I think in till 2023, I think till October, they train, they collected the data and they train these kinds of model. Okay, if I'm not wrong. So this model is having actually, these are the information. Okay, this model is having, these are the information. Let's say whatever data they used to train the model, it is already having, these are the knowledge. So if I'm asking anything related to that, it will be able to give me the response. But what about you are having some specific data? Let's say if I ask, let's say, let me show you one example. What I can show, guys. So I'll open up my code. So here I'll create a notebook. Just a minute. 03. I'll name it as, let's say, data loader. RAG demo. IP1B. So here, what I can do, I will initialize my LLM first of all. I think you know how to initialize the LLM, yes or no? If I want to initialize the LLM, first of all, I have to load my secret keys. Okay, I have to load my secret keys from where? From the environment. Okay, it is telling plain text because I have to select my kernel. So here I'll be using OpenAI model. That's why I'm loading the OpenAI API key. But if you want to use any other model, let's say you want to use Grok API, you want to, let's say, load Llama model or Mistral model, that is free model, you can use Grok API in that case. Okay, so I already have the OpenAI account. That's why I'll be loading OpenAI model. You can also load the Grok model as free. I already showed you how we can, let's say, load different kinds of model. Now, first of all, let's load the OpenAI API key. After loading it, so first of all, let me load one chat completion model, because I already told you mostly we'll be using chat completion model, okay, instead of completion model. So you can see I'm importing one chat completion model, which is nothing but GPT 3.5 Turbo 0125 model. Okay, so this is the model I have loaded. Now, how to let's say give the prompt to the large language model. I think you remember, let's say if I am using chat model, so that's how I have to give the prompt. So this is the way we can send the prompt. So what I can do, I'll copy this prompt as it is, and here I think just let me copy from previous example. So here is one example I'll copy, and here I'll try to paste it. Now here I can give URN, let's say URN helpful, okay, helpful assistant. Now here I can give one input. Let's say I'll tell me about DSwithBappy. Let's say I'll give my YouTube channel name. Let me see whether it is able to give me the answer or not. So I mean, whenever they train this model, I'm not sure actually they took my data or not. Okay, I mean, let's see. So what I can do, I can print the response here simply. Okay, so now let me execute. See, if I show you the content only, if I print it, see, it is telling, I'm sorry, but I could not find any information on DSwithBappy. It seems like it may be a typo or terms that is not widely recognized. Could you please provide more context or clarify your question so that I can better to assist you? Because whenever they trained this model, that time, that time they were not using my data. Okay, that means my YouTube, information was not there inside the, let's say, data set, whatever data set they used to use. What I'm trying to say, let's say whenever I'm performing the inference operation with the pre-trained model, that trained model we are using, let's say direct model we are using, and if I'm asking any kinds of prompt, it's always not, let's say, possible you will be getting the response. Let's say if you are asking anything which is not available in the knowledge base, okay, in your model knowledge base, that time it won't be giving you the response. Okay, and here is the example I already showed you. If I'm asking related DSwithBappy, it is not able to give me the answer because it hasn't trained with this particular data. So in that case, what I can do? Can I use my custom data? And can I give the information to my model? Is it possible? Yes, it is possible. For this, we have to first of all learn how to load the data, how to load different kinds of data. Let's say here I'm having one data folder. You can see inside data folder, I'm having different kinds of TXT file. Sorry, different kinds of file. Let's say I'm having PDF file, I'm having HTML file, I'm having TXT file, then I'm having CSV file, I'm also having database file. Okay, so these are the different kinds of file I'm having. Now, if I want to load these at the data, and if I want to pass the information to my large language model, how it can be done with the help of LangChain, because I already told you LangChain is a universal framework. It can support everything. That means you can connect all kinds of data sources. You can connect all kinds of technology. Okay, you can connect all kinds of platform. Okay, and it can also load different kinds of large language model with the help of only one framework. Okay, that is what I already given you the intuition in my first session. Okay, so now we'll see how we can load these are the data. Okay, so this is called actually data loader inside LangChain. First of all, we have to learn how we can load different kinds of data, different kinds of format of the data. Then we'll be using that particular knowledge to create our RAG based application. And I'll tell you what is RAG. No need to worry as of now. If you're not familiar with RAG, I'll also give you the intuition about the RAG. Okay, so yeah, so first of all, let's try to see how we can load, let's say, PDF data, HTML data, TXT data. Okay, so these are the data, how we can load it. So this is our main objective. So for this, here I'm going to write a comment. So here I can write data loader. Okay, data loader. Okay, so the first data will be loading, which is nothing but TXT data. That means if you're having any TXT file, how we can load it. So here, so let me just write down here TXT data loading. So for this, you have to import one function from the LangChain community. So all kinds of data loader are available inside LangChain community, guys. Okay, so first of all, write like that, LangChain community. So I already installed LangChain community, I think, remember. So LangChain community is not there. Let me just find. Yeah, so LangChain community is not there, so I can install the LangChain community. So here is the LangChain community. Okay, LangChain -community, and this is the specific version I'm installing. Okay, and try to remember all kinds of data loader functionality are available inside LangChain community, because I already told you it is using core LangChain only, but LangChain has divided. Okay, these are the framework in a different let's say functionality. Let's say if you want to load the model, OpenAI model, you have to install LangChain OpenAI. Let's say if you want to use Grok API, you have to install LangChain Grok. If you want to, let's say, load the data, you have to install LangChain community. Okay, that's how actually it is having different kinds of sector, different kinds of sub framework. Okay, so this is what you have to remember. So for me, I already installed in my environment, but for you, what you have to do, guys, you have to execute this command. So this command, pip install -r requirement.txt. So it will install this particular LangChain community in your let's say environment. So for me, I already have it. So what I'll do, I'll just try to close it. Then here, I'll just try to import. So from LangChain community dot documents loader. Okay, documents loader, import. So text loader. Okay, so because this is a txt file now, so here you are having one function called text loader. That's it. Now you have to specify the location of the text. So inside this particular function, you have to give the location, like which txt file you want to load. Let's say I want to load this txt file. Let's say this one, be good txt file. I'll just try to copy the path, and here I can mention it. Now see, it is copying the entire path, but I don't need the entire path. I only need the relevant path because I'm inside my project working directory. So what I can do, I can again copy it. So right click and try to copy the relevant path. Okay, relative path. So here I can paste it. I can see it is using backward slash. In Windows, by default, it will use backward slash, but what you have to do, you have to use the forward slash. Okay, forward slash. That's it. Now, after loading the data, it will give you the data loader object. So let me create an object here. So I'll store inside a variable. Then after that, you just need to call the load function. So let me just write loader dot load. Okay. Now it will give you the data. So what I can do, I can just store inside a variable called loaded underscore data. Okay. Now see, if I execute the program, you will see that this txt, whatever txt you are having inside this file, this data has been loaded. Okay. Now let me show you. So if I print this data load, right, loaded data, you can see this data has been loaded and it has loaded as a document. You can see it has loaded as a document. The type is document. Okay. Always try to remember, guys, if you are using LangChain, Llama index, whatever orchestration framework, whenever you are loading the data, it will load as a document, because inside Generative AI, we call the data, we call all the custom data as a document. Always try to remember. Okay. We call it as a document. Okay. So this is the document, guys. So first of all, it will show you the meta sources. That means from which file it has loaded the data. You can see it has loaded the data inside data folder. This is the file bgood.txt, and this is the page content. That means whatever content you are having inside that. So here is the content. It has loaded. Okay. It has loaded. So this format you have to give to the large language model. Otherwise it won't be working. So make sure your data is a format of document. Got it? If you're loading any kinds of custom data, always you need to remember. Yeah. So this is for actually txt data loader. Now what about CSV? Let's say I'm having a CSV file. How to load the CSV file? So for this, let me show you the syntax. So here I can write CSV loader. Okay. Now let me show you the different kinds of data your LangChain supports. So data loader, you can see txt loader. So this example I have already given you. List of the built-in data loaders. Yeah. Now you can see your LangChain supports all kinds of platform. You can see you can load the data from AC-ROM, then byte loader. Then you can also use different kinds of loader. You can also use AstraDB, Archive. I think inside Archive actually we are having all kinds of research paper nowadays. Then Azure Data AI. Then see different kinds of Cassandra. Then you can also load Discord data. Okay, Dropbox data. All kinds of social media platform also you can connect. You can also use Figma. See different kinds of data loader are available inside LangChain. It's not only about TXT data loader, PDF data loader, JSON data loader. It's not like that. It's all about all kinds of framework, all kinds of third-party, let's say, platform. You can also connect with the LangChain. It is also possible. See guys, PySpark, Slack, Telegram. Okay. Then if you're having any custom URL, any website, you can also load the data. XML, YouTube transcript, Wikipedia, okay, Twitter, all kinds of data, you can load it. All kinds of data, you can load it. Now simply, let's say you want to learn how to load the CSV data. In that case, what you can do, just click on the CSV. In the documentation, you can see, okay, they have all the tutorial. Okay, it's not like that. Always this documentation would be hard for understand. Sometimes you will see some of the functionality would be easy to understand. Let's say if I'm talking about data loader, if you click on the CSV, you can see how to load the CSV data loader. First of all, you have to import this particular statement, CSV data loader from the LangChain community. After that, you have to give the CSV path and it will load the data as it is. Okay. So that's how, see, they have also given the code snippet. So try to open it up and try to copy the code and try to paste in your notebook. Okay. You will be automatically getting the understanding. So for me, what I will do, I'll show you some of the data loader, but for you, you can explore all the data loader. Let's say you need to load the Slack data, or let's say you need to load the data from the Telegram. So try to go to the documentation, try to open it up, and whatever code they are suggesting, try to copy paste and try to load the data, try to connect with the Telegram. Okay, but I will show you most actually frequent format. Okay, most frequent format, whatever let's say format people are using in their day-to-day life. Okay, so some of the example I'll show here. We have seen how to load the TXT data. Now let me show you the CSV data, how to load the CSV data. So this is the example of the CSV data. First of all, you have to load this particular function from the LangChain community document loader. And this is my CSV data, guys. You can see straight tree list CSV. So this is the comma separated data I'm having. Now if you want to load this particular CSV, I have to use CSV loader. And again, try to call loader.load. Okay, now if I show you the loaded data. Okay, so this is the entire CSV data you'll be getting. See. Okay, this is the entire CSV data you'll be getting. And all the row it is considering as a document. You can see all the row it is considering as a document. Row 0, row 1, row 2, and so on. Okay. Now let me comment it up. Now what about HTML? Let's see if you're having any HTML data. So here I'm having one HTML. Let me try to open it up. So start up HTML. See, this is the HTML page I'm having. And let's say I want to load these are the data. So how it can be performed. Okay, with the help of LangChain, we can easily perform it. Let me show you one example. So here is the example, guys. Okay, so you have to use this unstructured HTML loader, this particular function from the LangChain community. Inside that, you have to give the HTML path. So this is the HTML part. Inside data, I'm having this particular HTML. And make sure whenever you are doing it, okay, whenever you are doing it, you have to install one library called BS4. So inside requirement.txt, I can mention it. BS4 as well as the unstructured. So these two packages you have to install because you will be loading the unstructured data. Inside HTML, you will see unstructured data for this. And it is beautiful soup as well as the unstructured. Okay, these two packages. So those who have performed web scraping, I think you know what is beautiful soup and what is unstructured. Okay, so similar kinds of things LangChain will also apply. It will perform the web scraping and it will extract all the information from the website itself, from the HTML page itself. So this is the idea. So let me save, and after like adding inside requirement, make sure you are running this command, guys. So requirement.txt. So it will install all the package in your systems. For me, I already have installed all the package. That's why I'm not going to install again. That's it. Now let me load the HTML content. So you can simply execute. So it will load the HTML content. So inside this HTML page, we are having so many content. That's why it is taking time because it is extracting all the information one by one. Okay. So it will take some time, guys. What I'll do, I'll stop the execution. But for you, we can execute and you can see whatever content it will extract. So as of now, let me clear the output. Okay. Now the next thing, I'll show you how we can work with the PDF data. So PDF data. So you can see I'm having the PDF documents. Okay. So how to load the PDF document? So this is the snippet to load the PDF document. You have to use PyPDF loader. See, all the import are same. Only you just need to change with respect to your data format. Let's say you need to load the CSV. At the time CSV loader. You need to load the HTML. At the time HTML loader. PDF loader. Okay, that's how you have to only change the function. Inside that you have to specify the PDF. So this is the PDF I want to load. And you have to load this particular PDF. Okay. So loader.load and split. Okay, you can call this particular function. Now if I show you the loaded content. But before that you have to install another library called PyPDF. So inside requirement, I'll try to add PyPDF. Okay. With the PyPDF, it will extract the information from the PDF document itself. Okay. This is the what you have to remember always. Okay. So now let me save and let me execute here. Now you'll see that these are the content I had inside my PDF. So it is having actually 4 pages. If you open the PDF, so this PDF actually 5 pages PDF. So this is the PDF, guys. You can see it is having 1, 2, 3, 4. Okay, 4 pages. So that's why it is telling 4 pages PDF. So you can see it is having 4 pages. Okay, 4 pages, 4 sources, and all the content it has extracted one by one. Okay. Now if you want to see the page content, so simply you can see this is a list. Okay, I want to take the first item. I'll give the first ID, and I only want to see the page content of it. Now see, it will show you the content, whatever content it has extracted. That's it. Okay. Now let me show you how we can Load the data from the Wikipedia. Wikipedia data loader. Okay, for this you have to install one package called Wikipedia. Okay, Wikipedia package you have to install. Then after that, this is the syntax. Okay, this is the syntax. See, now here inside query, actually what you can do, you can give any kinds of what any kinds of, let's say, topic name. So what I can do, let's say here I can mention like that. Let's say query, I want to let's say get the information about, let's say, Tesla. So I'll give the Tesla here in the query. And what I'm telling, I need load maximum documents 1. That means it should only return me 1 documents. You can also increase the number. If you need some more information, you can increase the number. You can give 2, 3, okay, as per your requirement. Now, if I see execute the program, it will give me the content related Tesla. Okay, see. So it is giving me the content related Tesla. Okay. Now there is another thing you can perform. So you can directly, whatever information you are getting, you can directly pass to the large language model and you can perform the question answer on top of it. Okay. That means you can give as a, let's say, context. Okay. Context to your large language model. So how it can be performed, guys. So let me show you another example. So here I'll again create this Wikipedia data loader. Now see, inside query and this load max, you don't need to pass anything. Just write query is equal to name and keep it as default. No need to change anything. And simply execute this line of code. Okay, see here I'm importing prompt template from the prompts. Then chat template from message. I think I already explained. Okay, what is prompt template? How to create the prompt template and all. I already clarified. And here is the human prompt I'm giving. Answer this question. Here is the extra context. And from where I'll get the context? I will get the context from where? I'll get the context from the Wikipedia. Okay, I'll get the context from Wikipedia. Let's say whatever user will ask. Okay, whatever user will ask. So this, let's say, query, first of all, will go to the Wikipedia. Wikipedia will return me the documents. And these documents, I will give the context to my large language model. Okay, and this will give me the answer. Okay, so it's still running. So let me stop the execution and again re-execute again. Okay, so what I can do, I can delete this part. It's not required. So let's say whatever Tesla information I got now, so I can pass as a context. That would be fine. So here I'll give, let's say, Tesla. Tell me about about Tesla. Okay, tell me about Tesla. Now see, whatever answer I'm getting from my Wikipedia, I'm giving as a context. You can see loaded data. The loaded data I'm giving as a context. That means what is happening? Just try to see. Let's say this is my large language model, LLM. Okay, LLM. So here I'm asking, what is Tesla? This is the prompt I'm giving, right? What is Tesla? And here I'm also giving the information about Tesla. And from where? I'm getting from the Wikipedia. Wikipedia is giving me information related Tesla. Okay. This information I'm passing to my large language model as a context. Okay. As a context, actually, I'm passing. Then whenever you are asking, what is Tesla? So what will happen? It will refer this particular context. This context it will refer. Okay. This context it will refer and it will give you the response. Okay, it will give you the response. So let me show you the execution. So if I now execute the program, so now let me do the invoke operation. So chat model invoke, I'm giving the message. Okay. Now let me show you the content. See, this is the response I got from the large language model. Okay. Now see here, what you are doing, you are giving the complete actually data, complete data to the large language model as a context. Now just try to think, if your, let's say, Wikipedia, okay, Wikipedia, let's say Wikipedia return, let's say 10,000 10,000 tokens. 10,000 tokens response. That means 10,000 tokens information. Let's say whenever you given the Tesla in the Wikipedia, let's say Wikipedia return 10,000 tokens. 10,000 tokens, let's information. And you are using GPT 3.5 turbo model. GPT 3.5 turbo model. Now, if I go to the model documentation, let's say OpenAI model, sorry, not pricing, model list. Model OpenAI platform. Let me open it up. Now, if I go to the GPT series, GPT 3.5, GPT 3.5, just let me find out. Yeah, 3.5 turbo. If I'm talking about this model, now see what is the context window, guys. Maximum output tokens. Oh, okay, they have increased the context window. Let's say I'll increase it here. Let's say instead of 10,000, I'll just write 30,000. Okay, 30,000. Let's say 30,000 tokens you are having. Now you can see the model GPT 3.5 turbo takes context window, that is input token. It can take 16,385 16,385 tokens it can take as an input. Okay, this model can take, so let me just write here GPT 3.5 turbo. This model can take 85 tokens as an input. Okay, and it can give the output 4,096 token. 4,096 token it can give you the output. Okay, so this is the limit of this large language model. Now let's say the context, context you got from the Wikipedia, it is, let's say 30,000 token. In that case, if I give this data to my large language model as a context, so will it able to take it as an input? Because you can see the input token limit is 16,385, but you are trying to give 30,000 token. Possible? No, definitely it will give you the input error limit, right? Input error actually it will give you. And whenever you are giving 30,000 tokens to your large language model, that means how your model will charge. If you go to the model pricing, so if I show you OpenAI model pricing, it will charge you based on the token. Okay, token limit actually. Let's say if I am talking about the GPT 3.5 turbo model. So what is the turbo model, guys? Here is the turbo model, GPT 3.5 turbo. Okay, turbo model. Let's say I'm talking about this model. Now see, 1 million token. Okay, 1 million token input. It will charge you $0.50. Okay, and if it is giving you output is equal to 1 million token, it will charge you $1.50. Okay, now just try to think about. Okay, the tokens actually you are giving to the model, that means the input you are giving. If your token size is high, that means it is like huge. That time your charge will also increase, yes or no? Because it will charge you based on the token. If it is taking like big token, if it is giving, let's say, big token output, definitely you will have higher cost that time. Okay, and you can't pass actually 30,000 input to the GPT 3.5 turbo because the input limit is 16,385. Okay, so this is the idea. That's why there is a drawback. This is the drawback actually. We can't directly load our custom data. We can pass to the large language model. It is not possible. Okay, because of that issue, because of the input issue. So what I can tell, guys, you can see the drawbacks. The first drawback I saw, input issue, input limit issue. Okay, then the second drawback you saw, which is nothing but cost, higher cost. Yes or no? Okay, so how to overcome this issue? How we can overcome this issue? Is there any way? we can overcome this issue. I want to use, huge document. Let's say inside this txt file, let's say I'm having very huge amount of data, huge amount. Let's say I'm using one books. Okay, I'm using one books. So inside the books, actually, you'll see there would be 1,000 pages, there would be 2,000 pages, and if you let's say extract all the data, if you extract all the data, and if you, let's say, count the token, how to count the token? So for this, what you can do, you can simply copy some text, and there is a token counter website is there. So OpenAI token calculator, token counter. I think this one, just let me open it up. See here, I can paste the text. Now see, inside this text, actually you are having 98 token and 414 character. Okay. Now there is also price calculator is also there. So based on the token, how much it will charge you. So here I think token price calculator, OpenAI. So here you can see set width and height. So this is for the image. Okay, this is the image model, multi-model. But if I'm talking about text model only, for text model also, I think they have also created the calculator. I'm not sure, but for image model it is available. So you can set the image height and image width. Based on that, you can see the price. Okay, how much it will charge you. But I'm not sure about the text calculator. OpenAI API pricing calculator. Yeah, input token. Input token, let's say you are having 1,000 token as an input and 1,000 token as an output. Number of API call, let's say you have given 100 times. So based on that, see, this is the pricing. So if you're using GPT 4.0 model, so this is the price. Okay, this is the price. So that's how you can see different websites are there nowadays. They will show you the calculator, let's say, how much it will charge you and all. And no need to worry, in future I will also show you how we can track the let's say cost and all. Okay, this thing we can also develop inside our application. So that is the issue actually. That is the drawback. That means there is the input limit and there is the cost issue. Okay, input limit and cost issue. So for this, researcher actually has developed one technique called RAG. Okay, RAG. That means retriever augmented generation. Okay, this technique. Okay, retriever augmented generation. Now inside RAG, what is happening? Okay, what is the idea inside RAG? So that is what I will try to explain. I already created one notebook. Let me take a screenshot of the content and here just let me paste it. Okay, see, this is what actually your RAG. So intro to RAG, you can see load large dataset asset and ask the LLM question about it. That means with the help of RAG. Okay, with the help of RAG, what we can do, we can load large dataset. Okay, large amount of dataset. Okay, large amount of dataset we can load and we can perform the question operation with the help of large language model. Okay, now what if the loaded data is too large? If it is too large, okay, if it is like huge, then that time what we can perform, we'll be using something called RAG technique. See, always try to remember, if you loaded data, that means the data you are loading, let's say you are having a txt file, the data you have loaded. Okay, if it is less than your model, okay, model input limit, okay, that time you can directly pass this data as a context to the large language model. There is no issue. Okay, but if it is like greater than the model input, let's say in this case, actually my model input is, if I show you that model, So here I think I already written. Yeah, 16,385. Let's say after extracting the data, you saw the token is like more than this size. That time what you can do, we can't directly give the data to the large language model. It is not possible. For this, you have to use the RAG technique. Now inside RAG technique, you are having some step. Okay, I can see when you load a documents, you end up with a strings. That means string kinds of data you are having inside that particular, let's say, file. Sometimes the strings will be too large to fit into the context window. That means your input size may be too large, okay, to fit into the model. That means we saw the context window. That means the input limit of the model. Okay, in those occasions, occasions will be using RAG technique. Now inside RAG technique, the first thing you have to perform, you have to split the documents into smaller chunks. So the first thing, guys, you have to remember inside RAG, you have to split the documents into a smaller chunks. Okay, I'll tell you what is chunks. As of now, just try to remember. The first step you have to perform, you have to split the document into smaller chunks. The second step you have to perform, transform text chunks into the numerical chunks. That means you will be having the textual number, text data. And we know that we can't directly pass the text data to the model, any kinds of AI model. It's not possible we can directly pass the text data. So what I have to do, we have to convert this text data to the numerical representation. That means to the vector representation, yes or no? Maybe you have already worked with machine learning, deep learning. I think you know. If you're using any image, if I'm using any text, first of all, I have to do the encoding. I have to generate the embeddings. That means the vector, that particular vector will be passing to the model. Okay, so this is what actually we'll be performing. That means we'll be transforming the text data to the numerical representation. And for this, we'll be using embedding model. Okay, there are different kinds of embedding model are available. We'll be using embedding model for this. Okay, now loaded embeddings to a vector database. That means we have to store this at the embedding to a vector database. If I want to perform the QA operation, if I want to perform the chat operation on top of my custom data, the first thing I have to load my data to the vector database, because vector database is like very powerful database. Okay, very powerful and fast like database. You can't use any kinds of traditional database here. Okay, traditional database doesn't support any kinds of vector store operation. So you have to always use vector database, and there are some vector databases are available. I think you know Pinecone is there, WebAT is there, ChromaDB is there, Files is there. Okay, then Postgres SQL is there. Now we'll be loading the question and retrieve the most relevant embeddings to the responded. That means after storing to the vector database, we'll be creating the retriever. Okay, and what is retriever? Retriever means it will retrieve the similar kinds of response. Let's say you have asked one question, what is Tesla? So the information you have given to the model, it is also related to Tesla information. Now it will retrieve the information related Tesla, like what is Tesla? So what are the similarity, let's say results it will get, it will try to extract, it will try to retrieve. Okay, this is called retriever. Then send the embeddings to the LLM to format the response properly. That means we'll be sending that question as well as the retrieved output to the large language model, and large language model will process and it will give me the answer. Okay, so these are the steps you have to remember if you are performing the RAG system. Now we'll be breaking down each and every component. I will try to understand like what is chunks and how to, let's say, do the splitting operation, how to like generate the embeddings with the help of embedding model, how to create the vector store, how to create the retriever. Okay, and at the end I'll also show you how we can create the complete RAG application. Okay, so these are the part we'll be discussing one by one. I hope, guys, is it clear? So how we can overcome this issue if you are having huge amount of data, and if you want to give this data as a context to the large language model, in that case what we'll be doing, we'll be using RAG technique. So inside RAG technique there are 5 steps we have to perform. Split document into chunks, transform the text chunks into numerical representation, load the embeddings to the vector database, create the retriever, and we'll be sending the retrieved output as well as the query to the large language model, and large language model will give me the response. Okay, this is the entire idea. So this is what we'll be learning, and we can use any kinds of custom data. Let's say the first question I have asked you, remember, so tell me about DSwithBappy, and your model was not able to give me the answer about DSwithBappy, right? Now what we can do, I can create another txt file here. So let's say I'll give DSwithBappy data. Okay, data.txt. Now inside that I can keep some of the information about my YouTube channel. So what I can do, I can, let's say, open up my YouTube channel. I will go to the about section and I'll copy, and this information you can keep inside the txt file. so that I can pass this information to my large language model. Okay, just let me reformat it. Okay, so this is the information about my channel. So whenever I'll create the RAG application, that time I'll tell you. Okay, now after creating the RAG, your model will be able to give me the response related DSwithBappy as well. Okay, that means I can use any kinds of custom document right now. It is possible. But before that, we'll be learning some steps. So these are the steps we'll be learning. How to perform the chunking, how to let's say convert our text to the numerical representation, how to store to the vector database, and how we can create the retriever. Then at the end, we'll be running the RAG technique. Okay, so this part will be covering in the next session. Next session, we'll try to wrap up everything. So guys, now we'll be discussing about different RAG component. I think you remember I was talking about RAG is having some component like splitter, embedding, vector store, retriever, and top K and so on, right? So now let's try to see all of the component in a practical way, like how we can develop them one by one. Okay, then after that we'll be also implementing one basic RAG application. Whenever I'm talking about RAG, actually we'll be performing these are the steps inside RAG. That means these are the component you are having inside RAG. So first thing, we'll be splitting the data into smaller chunks. Then we'll be transform text chunks into numerical representation with the help of embedding model. Then we'll be loading this embedding model to a vector database. Okay, then we'll be loading the question. We'll be actually creating the retriever. Then with the help of this retriever, we'll be passing the retrieved answer to the large language model as well as the question. Then my large language model will be able to give me the response. Okay, with respect to that. So these are the actually component we'll be trying to understand. Okay, so first of all, let's try to discuss about this one is splitting. So here I have already written. So first of all, we'll be discussing about is splitting. Okay, this one. So what is splitting and why we should perform the splitting operation and why it is required. So first of all, we'll be discussing about splitting. Splitting. Splitting or splitter. See, what is splitter? It's nothing but divide a large data asset in small parts. Okay, so this is called actually splitting. Now let me show you one example what I'm trying to say. So I already have one example, just let me show you. So this is the example, guys. You can see let's say you are having one let's say a large amount of data. Let's say you are having one original text. Let's say you have loaded this data from the txt file, pdf file, okay, JSON file, or any kinds of file. You have loaded the data, and let's say this is my entire corpus. Okay, this is my entire corpus. Now what I told you, I can't directly pass this data to my large language model. It's not possible because large language model is having some input limit. Okay, that means context window, fixed context window. Okay, so what we can perform splitting. What is splitting? Splitting means you will be actually dividing the large amount of data in a smaller part. So let's say this is my entire data, and now after splitting, you will see that you will be getting different chunks. So this is your first chunks, this is the second chunks, this is the third chunks, and this is the fourth chunks. Now how it is creating the chunks? So there are some technique we'll be following to perform this splitting operation. So we'll be using something called recursive character text splitter. Then we'll be using something called character text splitter. Okay, these two methods will be applying. Then we can divide this larger amount of data in a smaller part. Now you can see inside the text actually you will be having new line. Okay, new line. So why am I talking about new line? Let me show you one example. So let me open up my previous example. So inside data, so if I open this particular file, let's say bgood.txt, now you can see after this line there is an empty space. Okay, there is an empty space. That means whenever I'm talking about actually programming language, how program will get to know after this sentence there is a space. Okay, after this sentence there is a space. That means it is starting from here, because by default here it will consider as a /n. /n means new line. Okay, new line. That means after this sentence there is no text. That means you have to go to the new line. Okay, so if you load any kinds of data with the help of Python programming or any other programming, you will see these kinds of actually symbol. Okay, /n, /t. So these are the symbol actually you'll be seeing. So whenever you are having the /n, that means it's a new line. That means one sentence is completed and it is talking about the next sentence. Now if you see here this example, so here this is the sentence we are having. Now here we are having a /n. /n means this is a new line. It is writing in the new line. Okay, new line it is writing. So whenever I perform the splitting operation, that means this is considering my first chunks. Okay, now again it is splitting with respect to the /n. With respect to the /n, it is splitting. Now this sentence is considering as my second chunks. Okay, now again we are having the /n. Again it will split with respect to that. Then we'll be getting the third chunks. Then there is another /n. It will split. Then we'll be getting the chunks 4. So that's how actually we can get the chunks. So that means we are having a bigger data. That means huge amount of data. We'll be applying the splitting operation, and split will split the data with respect to the /n. And here we'll be getting different kinds of chunks. Okay, so this is the idea of chunking. Now you can ask me how we can perform the chunking. Inside LangChain, actually, we're having two kinds of method. So the first method, you'll be using something called character text splitter. Okay, character text splitter. I will tell you how character text splitter will work. Then there is another one called recursive character. I think it's a recursive text splitter or character text splitter. Just a minute. Yeah, recursive character splitter. Okay, so these two methods actually we'll be learning. Now, first of all, let me show you how we can use the character text splitter. So I'll open up my code, and here I'm going to create a file 04. I will name it as, let's say, rag components. Okay, so here I'll select the kernel. I'll select this kernel. Fine. Then after that, first of all, I'll be loading the env file, because I will be using the OpenAI model. In case you can use any other model, you can use Grok model or any model, you can use it. It's up to you. So let me load this OpenAI API key. All right. Then the next thing, we'll be loading that data. So inside data, we are having different kinds of data. We are having HTML, PDF, TXT. So let's load one TXT data. So here I'll be loading this data, actually begood.txt. So you can see this data actually I'll be loading, and you can see this data is a little bit, bigger data. You can see we're having huge amount of text inside this file. Now I can't directly pass this data to my large language model. For this, first of all, I have to perform the splitting operation. That means we'll be dividing the this bigger text to smaller chunks. Okay, this is the idea. Now, first of all, let me load the data. So this syntax will load the data. I think you remember. Now this is the entire loaded data. Okay, entire loaded data. Now, if you want to see the page content, simply you can call the page content. You'll see the content of the data. Now, if I want to use character text splitter, this is the syntax, guys. Okay, you can see. First of all, you have to import a character text splitter from the LangChain _ text.splitter. Okay, so from here you have to import this particular character text splitter. After that, you have to initialize one object of the character text splitter, and it will take some of the parameter. So the first parameter, it will take separator. Okay, separator. Now you can ask me what is separator. So here I have given one example. So I already told you, whenever you are loading any kinds of data. So if I show you with the help of LangChain, I loaded the data. Now you can see this /n is visible. Yes or no, guys? So if I show you the data, this /n is visible. See, okay, /n is visible. That means /n means it is referring the new line. That means after this line, okay, another line will start. Okay, which is nothing but this one. So that's why we are having this kinds of separator. So what I'm telling, so wherever you are getting this /n, that means if you see here, we are having the /n. See, /n. Okay, /n. So wherever you are having the /, so you can see / we are having also here. Then if you find here, you are having most of the /. Okay, /. So wherever you are getting the /, try to separate the data with respect to that. and chunk size I'm giving 1000. That means what will happen? So let's say here this is the entire corpus. So let me clear. Let's say this is the entire corpus. So whenever it is creating the first chunks, okay, so let's say it will create from here. Then here, what is the parameter I have given? I have given chunk size is equal to 1000. That means it will count 1000 token. So let's say this is first token, second token, third token, fourth token, fifth token. That's how it will count. How many, guys? 1000. Let's say in this sentence we are having 1000 tokens. That means it will consider as my first chunk 1. Okay, chunk 1. So first of all, it will count 1000 token, whether it is having or not in this particular chunk. Then it will try to split that particular sentence. Okay, otherwise it won't be splitting. Okay, so this is the parameter you have to assign. Now you can ask me how to define this chunk size based on the model context input. Let's say if your model is taking 4096 token as an input, that time you can keep 1000 chunk size. Okay, so I've seen most of the people, they are using 1000 chunk size, and chunks overlap they're using 200. Okay, now you can ask me what is chunks overlap. Chunks overlap means you are overlapping the chunks. That means whenever you are creating the second chunks, second chunks again, it will start from here. Yes or no? It will start from here. But what you have given chunk overlap is equal to 200. That means it will go back 200 tokens. That means it will go back 200 tokens. Let's say 1, 2, 3, 4, 5. That's how it will go back 200 tokens. Let's say 200 tokens ends here. Then it will start the chunks from here. Then again it will count 1000. 1, 2, 3, 4, 5, 6, 7, 8. Let's say 1000 ends here. Okay, ends here. So this is going to be your chunk 2. Okay, so this is called chunk overlap. Now you can see there is an overlap. Okay, there is overlap you got. And with this overlap, your model will try to understand after this sentence is coming, because there is an overlap. There is a common token is coming. Okay, that's how your model will automatically get to know after this particular sentence, this particular chunks is coming. Okay, after this chunks is coming. That's how you have to perform for all that, let's say, data you are having. Okay, unless and until this chunks is getting over, so you will be keep on applying this particular chunking, and you don't need to manually perform. So LangChain will automatically take care. So with the help of this character text splitter, will be automatically performing this thing. But I showed you, okay, what will be happening internally. So whatever code they have written internally, they are doing like that. That means they are looking for these kinds of double slash. They are separating the data. They are counting the chunk size first of all. If chunk size is missing, then they are also checking the chunks overlap, like how many chunks overlap you have to take care. So based on that, you will be taking the chunks overlap. Then what you will be doing, you will be creating the next chunks. That's how you have to complete for all the data you are having. And after that, you will be getting your chunk, like how many chunk you will be getting. Okay, after splitting your entire corpus. So this is the idea about chunk overlap as well as the chunk size. Got it? And length function, because it should count like how many tokens it is having. Okay, and how it will count with the help of length function. Okay, is separator regex is equal to false, so you don't need to give it true. Just try to keep it as false. Let's say you want to use any regular expression and all that, that regular expression you can also use. Okay, so this is like very powerful function they have created. You can send so many parameter. So if you go to the documentation of character text splitter, you will see there are so many let's say parameter it can take. But we are not going to use all the parameter. Just keep it everything as default. Only you just need to change this chunk size and chunks overlap. Okay, these two you have to change. Let's say you don't need chunk size 1000. You want to increase. In case you can increase, and if you want to decrease, in case you can decrease. Okay, that's how you have to change the parameter. That's it. Okay, so now let me execute and let me show you the output. So now this is the final code. So you have to call this object text splitter. Then there is a function called create documents. Inside that you have to pass your documents. So the documents actually we got. Okay, so we are giving the paste content only. Okay, the text only. You can see inside that I'm passing the text. Now see if I execute, so it will have all the chunk right now. See, so how many chunks it has created? If you want to see that, just pass it to the length function. So it has created 2 chunks. You can see first document and second document. All right. Now if you open this txt file, this bgood txt file, now you can see the first here. So if you count, okay, if you count all the token, that empty token also, you will see that it is getting 1000, okay, 1000 token, because this empty space would be also counted. Okay, that's why you can see in the first chunks it is getting this one, be good, and the second chunks it is getting this one. Okay, this is the idea. Now you can take any big document and you can try, you will see that it will create so many chunks. So later on, whenever we'll be creating the RAG based application, that time we'll be loading the bigger documents. Okay, that time I'll show you, it will create so many chunks for you. Okay, now if you want to see them, simply you can give the ID. Let's say I want to see the first chunks. This is the first chunks. If you want to see the second chunks, you can also see the second chunks. Okay, this is called actually character text splitter. Character text splitter. Now the second splitting we'll be learning called recursive character text splitter. Okay, this one. And for this you have to import it from the LangChain. So this is the syntax: LangChain text splitter, recursive character text splitter, and this is the syntax. Okay, recursive character text splitter. Now you can ask me how recursive will work. So let me first of all give you one text and let me show you how it will work. So what I'll do, I'll just try to pass the text. So here is the chunks I got. Now see how it is working. So let me open up my Blackboard. See, whenever I'm talking about recursive character text splitter, so it will actually perform the splitting with recursively. Okay, what is recursive? I think you know. Recursive means repetitively. That means first of all it will split the documents with respect to double slash. Okay, double slash. Sorry, double slash n. Okay, double slash n. You can see double slash n. Okay, so once double slash n is completed, then it will actually split with respect to the single slash n. That means in some times actually we'll see in the text you will be having single slash n as well. Let me show you. So here, see, there you will get double slash, then you will be also getting single slash. See, single slash. That means two kinds of slash n you will be getting. One is the double slash. Double slash means two new line, and single slash means one new line. So first of all, it will split the documents with respect to double slash n. Then it will again it will apply another loop. Okay, so let's say in the first loop, it will first of all split with respect to the double slash n. Okay, then inside that they will be performing another loop. Let's say second loop. Then it will split the document with respect to the single slash n. Okay, then it will perform the splitting operation. So this is what actually recursive character text splitter. That's why they are calling it recursive. That means they are performing recursively. Okay, this is the idea. So both technique you can use. Okay, with the help of both technique you can split your data. Either you can use character, either you can use recursive. Okay, both will work fine in that case. Okay, so we have learned the first technique, which is nothing but our splitting. Okay, splitting. Now what is the second technique? Second technique is nothing but I have to know how to do the embeddings, like how to generate the embeddings. Okay, so let's try to see how we can generate the embedding. So for embedding, we'll be again opening this file. And I can comment it. So what is the embedding? Here I can comment. So embedding is nothing but here transform the small parts of the text into the number, that means vector, that are easily stored to the vector store and searched by the vector database. Okay, so how we can generate the embeddings? For this, what we'll be using, guys, we'll be using embedding model. Embedding is also a large language model. Okay, it's a large language model. With the help of that, you will be generating the vector embedding. Show the embedding model. Okay, so you can load different kinds of embedding model. So here I'm going to load OpenAI embedding model. So OpenAI is having also embedding model. You can see OpenAI embeddings. Okay, embedding models. So it is having different embedding model. See, text embedding 3 small, text embedding 3 large, text embedding ADA. So that's how it is having different kinds of embedding model. Okay, so let's load one embedding model. So by default, I think it will load this model, text embedding ADA. Okay, this model maybe it will load by default. So let me load this embedding model. Okay, that means what will happen? So here we'll be using embedding model. So let's say this is my embedding model. Okay, embedding model. And he will be giving the input text. Input text. Okay, and this will return you the vector. Vectors embedding. That means numerical data. Okay, numerical data. Okay, so that you can store it to the vector database. Vector database DB. Okay, this is the idea. Now let me show you. So let's say here I'll be taking list of the sentence. Okay, so chunks of text we are having, let's say hi there, hello, what's your name, okay, James Bond, and so on. Now we'll try to convert these are the sentence to the numerical representation. So for this I'll be passing this list to the vector embedding model. You can see embedding model dot embed document. So this document I'm passing inside the embedding model and it will give me the embeddings. Now you can also see the embeddings. Let me show you. See, this is the embedding, guys. Now you can see this is the numerical representation. Okay, numerical representation. I can see it's a minus 0 you are having. You can also see the plus 0 as well. Okay, that means it's a coordinate. So it has created one higher dimensional coordinate space. So that's how it has created one coordinate space. Okay, and these are the coordinate number. Okay, like minus coordinate, plus coordinate, I think you know. That's how it is storing the vector. Let's say this vector will store here, another vector will store here, another vector will store here, another vector will store here. Okay, that's how it is storing the vector in the multi-dimensional space. Okay, based on that it will decide which vector is closely. Let's say these are the vector are close, then these are the vector are close. Okay, these are the vector are close. So that's how it will make a cluster. And whenever you are doing the similarity search operation or vector search operation, that's how it will identify. Let's say if there is another vector, let's say this vector is there. Now this vector is close to this particular cluster. That means this cluster it will consider. So that's actually it is performing similarity search operation. I can see this is the vector representation, entire vector representation of your data. Okay. Now if you want to see the dimension, what is the dimension of the OpenAI embedding? So this is the dimension. You can simply check the length. See, 1536 dimensional vector you are getting. That means one sentence. Okay, one sentence is representing in the 1536 dimensional space. So as a human, we can only visualize 3-dimensional, guys. This is a 3-dimensional, but our data is storing 1536 dimension. Okay, it has created 1536 dimension. Okay, in that space actually it has stored all of my embeddings, all of the vector. So as a human being, it's not possible for us to visualize that one. Okay, I hope you got it. So now let me open up my code. Now if you want to see the first 5 numbers, you can also do the list slicing, because at the end it's a list. Okay, you can see the first 5 number. Okay, yeah, and these are like the pre-trained model. Okay, the model actually we are using, these are the pre-trained model. So that's why these are the vector is pretty good. If you give to the model, so model can understand easily. Okay, this is the idea. So we have learned how we can perform the splitting operation, and we have also learned how we can convert our text to the embeddings. That means vector representation with the help of embedding model. Now the next thing we'll be learning about vector store. Okay, we'll be learning about vector store. Vector store, that means vector database. So there are some vector databases are available, like ChromaDB is there, Fice is there, Pinecone is there, WebAT is there. Okay, then PostgreSQL is there. Nowadays actually Red Hat also created the vector database. That's how we are having different kinds of vector database. So let me show you some of them. So what is vector database? Vector database is nothing but it stored the embedding in a very fast searchable stored the embeddings in a very fast searchable database. Okay, this is called actually vector database. Now let me show you some of the example of the vector database. First of all, let me show you the ChromaDB example. So this is the ChromaDB. You can see if I want to plot the ChromaDB, guys, if I want to import the ChromaDB is already available inside LangChain Chroma. Now if I open the requirement.txt, so LangChain Chroma we haven't mentioned. So first of all, we have to install one package. So this is the package, guys, we have to install called LangChain Chroma. Okay, so try to open up your terminal and try to install the requirements again. Then it will install the LangChain Chroma. So LangChain, what they did, they created separate library for the vector database. Let's say you want to use LangChain ChromaDB, you have to install LangChain Chroma. Let's say you want to use any other vector database, that time you have to install with respect to that name. Okay, so that's how they have created different kinds of functionality. So here we are importing the Chroma from the LangChain Chroma, you can see. Then we are loading the text loader, that means we'll be loading the text embedding model, because first of all I have to generate the embeddings from the text. And why splitter? Because my data would be huge. Okay, first of all I have to create the chunk. Okay, with the help of that chunk actually we'll be creating the embeddings. That means it's a step of execution, guys. Try to remember, first of all you have to load the data with the help of text loader. Then you have to perform the splitting operation. That means you can see I'm performing the splitting operation. After splitting, we are getting the chunk. So with the help of embedding model, we'll be creating the vector embedding. Okay, and this particular vector embedding will be storing to the vector database. So this is the step of the execution. So here I have already written, I think, remember. So here split numerical representation, then load the embeddings to the vector database. Okay, then we'll be getting the retriever. Then we can perform the RAG operation. That means we can perform the query operation on top of it with the help of large language model. So here is the example. First of all, I'm loading the data. So I'm loading this data actually. So inside the data, I'm having one file called state of union.txt. So state of union.txt. So this is the data actually I'm loading. Okay. After that, I'm performing the character test splitter, and chunk size 1000, chunks overlap 0. I haven't given any kinds of chunks overlap. Then I'm splitting the data. Okay. Now let me show you how many chunks you will be getting. So this is the chunks. See, you are getting so many chunks. So let me show you the length. You are getting 42 chunks here, guys. 42 chunks you are getting. Okay. Now this thing, what I will be doing, will be generating the vector embedding. Okay, and will be storing to the ChromaDB. And ChromaDB is nothing but it's a local database. So it will store everything in your memory. In memory, it will store the data, guys. Okay, always try to remember ChromaDB is a local vector database. So for this, you have to give the chunks, okay, inside the ChromaDB. So there is a function called from document. You have to give the entire chunks, and you have to give the embedding model. So what it will do, it will take the embedding model. That means it will perform this operation. It will take the input data. It will take the embedding model. It will give you the vector store. Okay, vector embedding, and it will store to the vector database, which is nothing but my ChromaDB. Okay, so this is what actually we are doing in this line. And with the help of one line, actually we are able to perform because we are using LangChain. Okay, if you are not using LangChain, that time you have to write the manual code. So that's why actually we are using LangChain. LangChain is a complete orchestration framework. So it will give you all kinds of functionality so that with the help of very less line of code, you can perform all the jobs. Okay, now let me execute. See, it is storing. It is converting all of the data in the like vector representation, and it will store in the vector database. Okay. Now, see, it has loaded. That means this vector DB, this is my object right now. This is my vector database object right now. You can see this is an object. Now I can perform similarity search operation. Okay. That means, let's say here I'll be asking one question. What did the president say about the John Lewis Voting Rights Act? So if you open these documents now, so it is related this John Lewis and all. So these are the information we are having. Now here what I'm doing, I'm calling the vector database object and I'm performing similarity search operation. So this question I'm giving, that means what will happen? So whenever you are asking this question, it will go to the knowledge base, that means to the vector dimension, and here it will search the similar results. Okay, similar results from this particular vector, and it will give you the similarity response. Now let me show you. So these are the similar results I got, guys. 4 similar results you got. Okay, but I don't want this kinds of output. I want the exact output. So the question I have asked, I want the exact output. Let's say this question, if I ask to the chat GPT, okay, if I ask to the chat GPT will give me the exact answer, yes or no. See, it will give you the exact answer. Okay, exact answer. What is the answer actually you are looking for? But in case here I'm not getting the exact answer. Okay, I'm getting the similarity answer only. Okay, so how to get the exact answer for this will be connecting our large language model. So whenever we'll be creating the RAG, that time I'll tell you, okay, how to connect the large language model. As of now, we are only doing the similarity search operation. Okay, this is the idea. Fine. Now there is another way you can retrieve the information. So this is called actually retriever. Let me show you one retriever example. Vector store as retriever. That means finding the embedding and the best answer your question. So it will give you the retrieve output. Even it will also show you the metadata. That means source document, like from where it is retrieving the data. So let me show you one example. So what I will do now, let me show you another vector database example. So first of all, let me load one data. So I'm loading the state union txt again. Then we'll be using FIAS. Okay, FIAS is another vector database. You can see FIAS is another vector database. Again, it's a local vector database. Okay, it will store the data locally. Now again, I'm importing OpenAI embeddings and character text splitter. First of all, loading the documents, doing the chunking. That means creating the chunks, doing the splitting operation. After that, initializing the embedding model. And you can see inside FIAS, I'm giving the chunks as well as my embedding model. That means it will convert my text to the vector embedding and it will store to the vector database, which is nothing but FIAS. Okay, and it will give me the vector DB object. So this is the vector DB object. Okay, now we'll be creating something called retriever. How to create the retriever? That's how we can create the retriever. Vector DB. There is a function called as retriever. Okay, as retriever. See, always try to remember, whenever you are creating RAG based application, you have to use this function as retriever, not the similarity search. Okay, similarity search. So we won't be using this method. We'll be using this method because this is more powerful. Why? Let me show you. So let me ask one question. So I'll be asking this question. The retriever.invoke, what did he said about Ketanji Brown Jackson? Okay, let's say this is my question. Now, if I show you the response, see, it will give you by default 4 response. Okay, 4 response, 4 retrieved output. Now you can see it is also giving you the meta sources, like which document it is referring, from which page content it is giving you the information. See, it is giving each and everything. Okay, these are the most relevant answer it has filtered out from the txt document, the documents actually you have given. Okay, see, it is referring this document actually. Okay, so that's why it is more powerful than your similarity search, because similarity search is not giving this kind of particular metadata information. But I want to understand which document it is referring, which line it is referring. Okay, if I want to understand, I'll be using the retriever at that time. I hope it is clear. Okay, now if you want to see the length, simply you can also see the length. So here it has given me by default 4, because at retriever it will give you by default 4. Okay, 4 response. You can also tweak this parameter. For this, there is a parameter called top k. I'll tell you how to change the parameter. So let me show you how we can change the parameter. So whenever I created the retriever, so here I can mention this parameter, search keyword. Here, search keyword k is equal to, so here if I give 2, it will only give me 2 answer. Let me show you. See, now it has given me 2 answer only. Okay, 2 retrieve output. If you give 3, it will give you 3 answer. So this is called k parameter. Okay, see, 3, but by default they said 4. Okay, it will give you 4. If you give 1, it will give you only 1. Okay, so what we have learned? First of all, we have learned that a text is splitter. That means we have learned about the splitter, how to create the chunks. If you are having bigger document, how to convert into the smaller chunks. After that, we have learned how to do the embeddings. That means we'll be using some embedding model. Okay, with the help of that, we'll be generating the vector embedding. After that, we learn how we can store these are the vector embedding to the vector database. Okay, I showed you some example of the vector database. Then we have learned how to perform the similarity search operation here. Okay, then I told you we'll be using something called retriever, because retriever is more powerful because retriever gives me the sources. Okay, sources as an output as well. Okay, So this thing actually we have learned. Now with the help of these are the components, we'll be creating one RAG system in the next class. This is the agenda. So guys, now we'll be implementing one basic RAG. So here we'll be using LangChain expression language to implement this RAG application. No need to worry, I will discuss more about this LangChain expression language. This is just an introduction. I will show you how we can implement the RAG application. Okay. So on top of this LangChain expression language, I'll be taking the dedicated actually session. So there I'll try to discuss each and everything. Okay. As of now, I'll give you the high level overview. If I want to implement any kinds of RAG application, so how we can use LCEL. Okay. And whatever things we have learned so far, whatever RAG component we have learned so far, we'll be integrating all of them all together. Then we'll be implementing this particular RAG application. So inside RAG component, you are having these are the component. So first of all, you have to split the data. Then you have to generate the embeddings with the help of embedding model. Then you'll be storing that embedding to the vector store, that is vector database. Then we'll be creating the retriever. And if you want, you can also set the top k parameter. Then what you can do, you can perform the retrieve operation. Either you can perform similarity search operation. But whenever actually I was performing the retriever operation, similarity search operation, so it was only returning the similar kinds of response. Okay, like the best results, actually it was returning around 4 to 5 response it was returning. But that is the answer I'm not looking for. I'm looking for one accurate response. So if I want to get the accurate response case, what I have to do, I have to connect my large language model. Okay, after connecting the large language model, we'll be able to get the correct response from the let's say custom documents, whatever I'm asking. So this thing I'm going to show you how we can connect our large language model with our custom data. Okay, so first of all, I will draw the architecture, what we are going to perform. Then I will start with the coding. So here we'll be implementing one basic RAG. Okay, and whenever I'm talking about RAG, that means I'm talking about my custom data. So it can be any kinds of document. So let's say here I can consider custom. Okay, custom data. So it can be any kinds of data format. It can be PDF, it can be TXT, it can be Excel, XML, JSON, anything you can consider. Okay, so I'm just calling as a custom data as of now. So first of all, what I have to do, guys, this custom data, anyone remember? If I want to perform the RAG operation, so I can't directly pass this data to my LLM. Okay, so for this, first of all, what I have to do, I have to perform the splitting operation. So we'll be performing the splitting operation. Okay, splitting, or you can also call it a chunking. Chunking. So after getting these chunks, what I will do, we'll be using one embedding model. Okay, embedding model. So in case you can use OpenAI embedding model, you can also use some open source embedding model, you can use Grok API, it's up to you. Then after that, we'll be creating vector embedding. Okay, we'll be generating the vector embeddings. Then we'll be storing this vector embedding to the vector database. Vector store, or you can also call it as vector database. So this will become my knowledge base. This will become my knowledge base. Okay. Then what will happen? User will, let's say this is the user. User will ask some query. And your vector is stored. That means you will be creating a retriever here. Retriever. Okay, retriever here. So it will give you some rank results. Rank result. Okay, based on the k parameter. So here I can write top k. Okay, based on the top k parameter. So let's say it has given you 3 response. Okay, 3 response. Let's say k is equal to 3. It will give you 3 response. Now I don't need the 3 response. I need accurate response. Okay, let's say here I'm asking let's say here I'm asking, let's say, what I can ask, let's say, but what is the capital of India? So as a return, guys, what should I get? Okay, as a return, what should I get? Definitely Delhi, right? So it should give me the Delhi, but here it is giving me some rank results. So let's say it is giving some content related Delhi, and apart from which is, let's say, relevant to the Delhi, it is also giving me that one, but I don't need. I need the accurate response. So for this, what I will do, I will use my large language model. So here we'll be using large language model, LLM. Okay, so in case actually we'll be using like ChatGPT model, but you can use also any other model. You can use Grok API, it's up to you. So here what we'll be doing, so the rank results actually you are getting, so we'll be passing this rank results to my LLM. Okay, we'll be passing this rank results to my LLM, and whatever question user is asking, okay, the question also I'll be passing to the large language model. And now what will happen, large language model got the context, so this is called context. This is called context, okay, and this is called query. This is called query. I think you remember. I showed you one example. So here, let me show you. So here, I think data loader RAG demo, Wikipedia loader. I think whenever I was talking about Wikipedia. So here, can you see here what I was doing? I was searching about Tesla, and whatever data actually I was getting, I was passing as a context, okay, to my large language model. Then I was also giving the question, like, tell me about the Tesla, the same thing. But now what we are doing, we are doing some more step because my data size is huge. So first of all, I have to split the data. Then we have to create the embeddings. That embeddings will be storing to the vector database. Then what we'll be doing, user will give some query, and this query actually will go to the knowledge base. Knowledge base will return some rank results, and this rank results I'll pass to my large language model as a context, as well as the query. Now LLM will process, okay, LLM will process, and it will generate a accurate response. Okay, accurate response for you. So to the user. Okay, to the user, it will give me the response. Okay, so this is the entire RAG architecture. Okay, I hope it is clear. So as of now, we have created till retriever. Okay, we haven't connected our large language model. Now we'll be learning how we can connect the large language model. Okay, so now let's try to implement this architecture through our code. So let me open up my VS Code, and here I'm going to create a file. So let me name it as 05 RAG, basic RAG, implemented. So the first thing what we usually do, guys, first of all, we'll be loading the OpenAI API key from my environment, because here I'm going to use the ChatGPT model. You can also use Grok model. Okay, Grok. You can also use Grok API to load the model. Now the next thing, RAG component, and there I showed you the retriever, how to create the retriever. So first of all, we load the data, then we perform the like chunking operation, that means splitting operation. Then we use embedding model. We create a vector store with the help of vector database. Then we create the retriever. And whenever you are asking something into the retriever, it will retrieve some relevant information, okay, with the help of metadata as well. Okay, so till here we have done. Now we'll be learning how we can connect the large language model. That means the information I'm getting from my retriever, I'll pass to the LLM, as well as I'll also pass the query. Okay, whatever query user is asking, based on that, LLM will try to process and it will give you the accurate response. So for this, you can see this code is already familiar with you. So I'm importing the FIAS. FIAS is a vector database. Then OpenAI embedding, because I need an embedding model to generate the vector embedding. Then character text splitter I need for creating the chunking. Okay, so let me import all of them. So first of all, I will load the data. So let me load one data. But before loading the data, I need to import this library as well. So text loader. So I'll be loading one txt documents. So this txt document will be loading a state of union txt. So let me load it. So this is my data. Now you can also see this is the entire data we have loaded. Okay, now the next thing will be creating the chunking. We'll be doing the splitting operation. So this is the code snippet. So here you can see I'm given chunk size is equal to 1000, chunk overlap 0. And whatever document I have loaded, I'm passing to the split document. Now it will give me the chunk. So you can see the complete chunk. See, that many of chunk it has given me. If you want to see the length, you can also check the length. So 42 chunks it has given me. Okay. Then what we'll be doing, guys, will be loading the embedding model, and we'll be creating the vector embedding. And we'll be storing in the FIAS vector database. Okay. So let me do it. So it has created one vector database and it is storing in your disk. Okay. Local disk. And now we'll be creating the retriever. So this is my retriever, guys. Okay. And by default, how many retrieve parameter actually it will have? I think you know by default it will have 4 retrieve parameter. Okay. 4 retrieve parameter. You can also test. So let me show you. So I'll be asking one question. So retriever.invoke, what did he say about Ketanji Brown Jackson? So if you open this documents, so you will see the information related Ketan G Brown Jackson. Now if I ask it, so it will give me some response. See, it has given me 4 relevant response. Okay. Now you can also play with this parameter. So I think you know there is a top K parameter. You can set search KW is equal to K is equal to 1. That means it will give you only 1 information. Okay. So let's say I want to take 3. Okay, 3 information. Now if you ask the question again. Now see, guys, your response would be 3. Okay. You can see you got 3 information. Okay. Now you can play with this parameter. It's up to you. Fine. Now we'll be creating the RAG. That means we'll be connecting our large language model right now. And here we'll be using LangChain expression language. Simple use with LangChain expression language. Okay. And today I'm not going to discuss like this LangChain expression language. For this, I'll be keeping one dedicated session. Okay. So now let's create the chain. So before that, first of all, I need to import some library. So here is the library, guys. So first of all, I'm importing chat OpenAI. Why? Because we'll be using chat GPT model. That is GPT 3.5 turbo model. And I'll be using chat completion model, not the completion model. And chat prompt template. Why chat prompt template? I think you know, whenever I want to give any, let's say, input to my large language model, that means if it is a chat like a completion model, that time I also need to pass the system prompt. Okay, system prompt as well as the user prompt. So for this, we'll be using the chat prompt template. We'll be creating the prompt template. Okay, then we'll be passing the prompt. Then this is the new thing, guys. LangChain has proposed. It is available in the second generation LangChain, which is called LangChain expression language. And to perform it, you need these are the library: str output parser and runnable pass through. Okay, there are some more, let's say, functionality they have created. I will discuss each and everything. As of now, just try to get it as a high level. So if you want to use this LangChain expression language, you need these are the functionality from the LangChain. Okay, LangChain code, output parser, str output parser, and runnable is equal to runnable pass through. Okay, now let me import all of them. Now, first of all, I'll be creating the template. So this is my prompt template. So first of all, I'll be creating the prompt, then I'll be creating the prompt template. So this is the prompt. Answer the question based on only the following context. That means user will give the context. Context means the retriever. Okay, the vector database. Okay, this context as well as the question. Okay, so here I've already written the diagram. So it will first of all give the context to the LLM as well as the question, whatever question user is asking. Okay, now if I want to create the prompt template, I'll be using this chat prompt template function. So see, guys, chat prompt template, and here I have to give the template, and this will give me the prompt. Okay, now I'll be initializing my OpenAI model. So here we'll be using chat OpenAI. That means we'll be using GPT 3.5 turbo model. Okay, great. So let me execute. Now here I'll be creating one function. I'll tell you why we are creating the function as of now. Just try to remember this function will format the output. Okay, so now this is the chain, and you can see the syntax is written with the help of LCEL, that means LangChain expression language. See, chain is equal to, I have given a bracket, again I have given a bracket. Now here I'm writing the context is equal to retriever, because you remember what is context. Context is nothing but my rank results, okay, the retriever. So this thing I have to pass to the LLM. So you can see this is the retriever I'm passing. And format documents, this function object I'm giving, okay, format documents, and question is equal to runnable pass through. Okay, now you will have some doubt. I know that initially if you're starting with this LangChain expression language, this would be confusable for you. No need to worry. In the next session, I'll try to discuss each and everything about this LangChain expression language. As of now, just try to remember whatever input user will provide. Okay, this input will come here as it is, and it will save inside the question. Okay, question actually a parameter. Then the prompt we have prepared. See, this is the prompt we have prepared. Then the model, then the output parser. That means what is happening, let me show you. So I'll open up my annotator pen. Let me select the color. See, first of all, you are see, you have given the bracket. So this bracket is called parallel. Okay, parallel runnable. I'll tell you what is parallel runnable. It will run everything as parallelly. You can see I have given too many statements. So this is the first statement, retriever. This is the second statement, that means the function object, and this is the third statement, which is nothing but the input. Now you can see here is a pipe symbol. And what is pipe symbol? This is the LCL symbol, LCEL, LangChain expression language. Okay, so with the help of this pipe symbol, we create this actually chain. Okay, now I'm giving the prompt model as an str output parser. So what will happen? First of all, you are executing this one actually. Okay, that means your context and input will come. So let's say user has given what is Tesla. Okay, what is Tesla? This is the question. So this question, where it will go to the prompt template, and it will create the prompt template. I think you remember. So how to create the prompt template? That's how it will create the prompt template. So answer the question based on the following context. So context, that means retriever. Retriever will come in the context, and question, whatever question, let's say what is Tesla? Tesla will come inside that question. Okay. Now this question, where we have to pass to the model. You can see we have to pass to the model. That means this question will go to the model. That means my large language model, and model will give me what? It will give me response, yes or no. Okay. And I think you know, whenever we are getting the response from the LLM, so what format it will return? It will return as a AI message format. Okay, but I only need the content of it. And if you only need the content, you have to use this str output parser. I think we have already learned output parser. Remember, inside I think data loader, not data loader. I think inside this one, talk with LLM part 2, we have learned about output parser. So with the help of output parser, we can format our output. That means if I want to get a JSON output, if I want to get a TXT output, everything you can customize here. So this output parser will by default will return as a string output, str. Okay, str. Okay, so this is what actually we are using. That means first of all, we are giving the context, then we are taking the input from the user, we are saving into the question variable. Okay, then format documents. What format documents will do? Whatever response actually it will give you. Let's say, see what happens actually whenever we perform the retrieve operation. Let me show you. So here is the retrieve operation. See, whenever we perform the retrieve operations, what happens? It will give you, these are the retrieve output. Okay, these are the retrieve output. But here what I need, I only need the paste content. I don't need the metadata information. It's not required. I only need the paste content. So what will happen? This function will automatically filter out only paste content. Okay, I don't need the metadata. I only need the paste content. So this will extract the paste content and it will return. Okay, here. Okay, and this input will go to the model. Okay, first of all, it will create the prompt, then it will go to the model and it will give you the output. Now let me show you. So here I'll be asking one question. So the same question will be asking chain.invoke, what did he say about Ketanji Brown Jackson? Okay, now let me execute and let me show you the response. See guys, this is the response, and if you see the type, it will be string. Okay, it says str because of that output parser. Okay, so this is what our basic LCEL, that means LangChain expression language. Okay, but previously I think you remember, those who have already worked with this one older version of the LangChain, we used to use chain functionality. I think remember chain functionality. We used to import I think chain. Okay, instead of using the like default chain from the LangChain, we have created the LangChain expression language. And see, always try to remember, it's not like that this inbuilt chain has been deprecated. No, still LangChain suggests to use that chain as well, chain functionality as well, because still chains is under development. Okay, still the chains under development. That's why LangChain is also suggesting you have to use the older technique if you want to create any kinds of project. I'm getting the correct response right now, okay, from my application. Previously it was only giving me the related information. Now I connected my LLM. Okay, now if you ask any kinds of query, it will give you the accurate response. The architecture we have drawn, see, accurate response it will give you. So guys, now I'm going to discuss about the memory inside LangChain. So I think you saw nowadays actually whatever applications are coming actually inside generative AI, all the application have this memory functionality. So let's say if I'm talking about ChatGPT, so when you are asking something to the ChatGPT, so this will remember that particular context. Let's say I have asked, hi, my name is Bappy, how are you doing? Okay, now next time if you're asking what is my name, so you'll see that ChatGPT will reply, your name is Bappy. That means your conversation, whatever conversation you are doing, whatever, let's say, prompt you are giving, it is trying to remember that particular context. It is trying to remember that particular, let's say, data. Okay, so how it is doing? It is using something called memory. Okay, memory. We have two kinds of memory. One is like temporary memory. One is like permanent memory. So both of them I will discuss. No need to worry. And this is called actually memory management. So make sure whenever you are implementing any kinds of application, okay, generative AI application, so you should include this particular memory management, okay, in that application. Otherwise, what will happen? It won't be able to remember the user input. So this is super important, guys, this memory. So let's try to discuss this memory, okay, how we can use it with the help of LangChain. If you open up the ChatGPT, and inside ChatGPT, if you ask any kinds of question, let's say if I ask, let's say, hi, my name is Bappy, I love coding. Okay, so let's say this is the question I have given to my ChatGPT. Now ChatGPT has given me one response. Okay, now if I ask, let's say, what is my name? Okay, now see, it is telling your name is Bappy. That means it is remembering my previous conversation, okay, previous context. So whatever, let's say, prompt you are giving, whatever response actually you are getting, it is trying to remember that thing. So this is called actually memory. So these kinds of memory we are having inside the LLM powered application. So whenever you are creating your custom application, you also need to implement these kinds of functionality inside your application, okay, so that user experience would be better. So let's say if I'm asking something, so I don't need to again repeat that question again. Okay, so this is super important whenever you are creating this application. So this thing we can handle with the help of LangChain memory. So today I'll show you the LangChain memory. Okay, so two kinds of memory we'll be learning, the permanent memory and we'll be learning about the temporary memory. Even going forward, whenever we'll be creating some application, that time I will also show you how we can save those conversation, okay, in a file. Okay, so it is also possible. So we can also save the memory in a file. Got it? Great. So let me write down the agenda, whatever things we're gonna cover in this session. So here, agenda, we'll be learning about memory. Okay, memory in LangChain. Okay, memory in LangChain. But before starting with memory in LangChain, I just need to discuss some of the very important concept. Just a minute, guys. Let me discuss. Okay, so I already created documentation for you. So these are the things you have to remember if you are working with memory inside LangChain. Okay, so I was going through the documentation and I got to know these are the information. So that's why I thought let's save it so that I can also show you. See, memory is what? Save your conversation with the LLM. That means whatever conversation you are doing with your large language model, you can save those conversation. Okay, so this is called actually memory. Now if you see ability to share the information about the past interaction, that means whatever let's interaction you are doing, previous interaction you are doing, so memory helps us to save those information. Okay, that means if I'm asking something related that, it will be able to remember. Now you will have some control. Let's say how many conversation you want to save. You want to save the entire conversation, or you want to save some specific conversation, some number of conversation. So these kinds of parameter we are also having. So I'll be discussing, no need to worry. Then you can see most of the memory related functionality in LangChain is marked as a beta. Okay, this is for two reasons. Most functionality are not production ready. Most functionality work with the legacy chains. Okay, not in the newer LCEL syntax. That means inside LangChain expression language, you can't use this particular memory functionality. Okay, if you're using memory functionality, you have to use the legacy LangChain. You can see here. Sorry, let me change the correct. See, you have to use the legacy LangChain. So see, LangChain also like suggesting if you're working with the memory inside LangChain, just go with the legacy LangChain. Okay, because still it is under development. They are trying to integrate this thing with the LangChain expression language as well. Maybe soon actually they will also integrate and they will also make it as production ready. But as of now, if you want to create any application, if you want to add the memory functionality, you can go with this legacy LangChain. Okay, because see, legacy LangChain is still, it is not deprecated, so still you can use it. So because LangChain is also suggesting you to use, so no need to worry about. And you can see it is still marked as a beta. That means it's not a production ready. The memory, let's say they have created. Okay, it's not a production ready. But again, this is some important actually component inside LangChain you'll be getting, because memory functionality at the end we have to add inside our let's say application. So that's why you can use it. Still it will be work in the production. Okay, don't need to worry. Apart from that, we are also having some alternative. Let's say instead of using this memory, you can also create your custom memory. It is also possible. You can also use some in-memory database. Let's say Redis is there. Okay, with the help of Redis also you can create your own memory. It is also possible. Okay, so for this you should have some additional knowledge, okay, on top of some additional tool. But as of now, still LangChain is suggesting to use whatever, let's say, functionality they're having inside memory with the help of legacy LangChain. So going forward, whatever example I'm going to show you, I'm going to use the legacy LangChain, okay, not the LangChain expression language syntax. Now the main exceptions to this chat message functionality is the functionality is largely production ready and does integrate with the LCEL. Okay, that means see, there is another actually functionality will be getting called chat message story. Okay, this functionality is largely production ready and does integrate with the LCEL. That means you can also integrate with the LCEL, but this one is like a little bit different. I'll tell you. So as of now, I'm not going to show you the clear-cut example of it, but I'm going to at least show you some demo how we can use the chat memory story. But going forward, whenever we'll be creating the project, okay, that time I'll tell you, okay, how we can use it like properly. But if you're a beginner, if you want to start with your application development, I will suggest go with this one actually. The things we'll be learning today, that means with the help of legacy LangChain, because you will already have some predefined function for the memory. We are having the buffer memory, okay, buffer memory, and we are having the chat message story memory. So both will be exploring one by one. Okay, now if you want to see some documentation of this memory, so let me open some documentation, guys. You can see still they are telling it's a beta, okay, beta version of the memory. See, in the documentation they are mentioning. So it's a good practice, just go with the documentation as well if you're working with something, because see, if you're not understanding the entire documentation, what you can do, at least you can search here. See, LangChain is also having the search option, so simply you can search here. Let's say I want to use the memory, okay, memory inside LangChain. So simply search here, you will see memory will be getting different memory will be getting. Okay, now simply you can open up an example, you can try to learn the memory. Okay, so chat models LLM model memory. So here you can go to the meta memory, beta memory, this one. Okay, so that's how we can read, and you can see they're using legacy LangChain, okay, the older version of the LangChain. See, so we are having some functionality of the memory, and if you want to use them, you have to use the legacy LangChain. See, they are using the chain predefined function, and this is called legacy LangChain. I think I showed you some example previously, right? So inside that you can see they're using this buffer memory and all. Okay, so there is no example of this latest like second generation of LangChain like LCEL, LangChain expression language. And if you want to see the example of chat message history with LCL, so this is the documentation. So here guys, you can see template, message placeholder, history, human input, add message history to the memory. See here, I think chat memory history. So for this you have to create a custom function. Okay, then you can use that one. You can save as a like memory. Okay, memory kinds of thing. So this one will be learning whenever we'll be doing the project, that time we'll be learning. Okay, today I'll show you a basic example, then we'll be learning later on. So first of all, let's try to export this one, our most used actually memory inside LangChain called buffer memory. Okay, like what is buffer memory and how we can use the buffer memory. This thing will be exporting. For this I'm going to open up my code editor, and here let me create a file. I'm going to name it as 09 memory LangChain .apynb. So the same thing I'm going to do. First of all, I'm going to connect my kernel. Then I'm going to load my OpenAI API key. You can also use your Grok model. It's up to you. Then after that, I'm going to load one LLM. That means I'm going to use the chat completion model. Okay, the same model like GPT 3.5 turbo model we'll be using. Now the first thing we'll be exploring about the buffer memory. So this is the buffer memory. Okay, buffer memory example you can see. So buffer memory is nothing but it's a it keeps a list of the chat message in a buffer, okay, and passes those into the prompt template. So let me show you one example. For this, first of all, let me import some library. So guys, I think you are already familiar with these are the library, like we're importing chat prompt template, message placeholder, system message prompt template, human message prompt template. Why? Because as I told you, we'll be using legacy LangChain. Okay, legacy LangChain, and I already showed you legacy LangChain example. Let's say if I want to create the system prompt, because we are using the chat model, right? We have to give the system prompt as well as the user prompt. So system prompt wise, we'll be writing inside system message prompt template, and human message prompt wise, we'll be writing human message prompt template. Okay, this is the idea. Now here we are importing this particular LLM chain, because here we are not going to use the second generation of LangChain. We are not going to use the pipe symbol. We'll be using the custom made chain, okay, chain functionality inside LangChain. And this is the conversation buffer memory. That means this is the functionality we'll be using. Okay, with the help of that, we can save the conversation. Now let me show you one example. So here, first of all, we'll be creating the prompt. So this is my entire prompt. You can see chat prompt template, inside that message, and this is the system prompt. So first thing, we have to create the system prompt. And you remember, you had a nice chatbot having a conversation with a human. So this is the prompt I'm giving as a system. And message placeholder. Okay, what is message placeholder? Because if you go to the documentation of LangChain, if you go to this buffer memory, so they're suggesting you have to use this particular syntax. That means the chat history. That means whatever conversation you'll be doing, this is called chat history. Okay, so this chat history, it will try to remember. So that's why you have to specify this name. So make sure guys, you are giving the same name, otherwise you will be getting issue. And this is the human message prompt template. That means whatever question user will asking, okay, it will come here. Got it? Now we'll be creating the chain. We'll be creating the memory. So this is the memory, conversation buffer memory. We are using this function. Inside that, we are giving the memory key. That means I'm telling I want to only save the chat history. Okay, and return message is equal to true. That means you can also see the conversation. Okay, like you can also see the execution log. So that's why we are given return message is equal to true. Okay, now let me show you how it will work. So for this, let me create a chain. So this is my final chain, guys. You can see this is my final chain. I'm using LLM chain. Inside that, I'm passing my large language model. The large language model we have imported, and I'm giving the prompt. The prompt we have prepared. Then I'm giving verbose is equal to true. That means I want to see the execution log, and this is the memory. Okay, the memory we have created. Now let me create this chain, and see you are getting the warning because you are using the legacy LangChain. Okay, deprecation warning you will be getting. Now let me ask one question. So this is the question I'll be asking. Let's say first question I'll be asking hi. Now you can see that it has executed my LangChain. So question was hi, and chat history I got. Yeah, inside chat history, that means the keyword we have given, chat history. So inside chat history, you can see hi has been set. Okay, hi has been set, and my model has replied hello. You can see hello, how are you today? So this is the response I got. Now let me give you another. Let me give another, let's say, question. So this is the question. Here I'm giving my name is Bappy and I have moved 33 times. Okay. Now this is another question. Now you can see this is my question. My name is Bappy. I have moved 33 times. Inside chat history, the previous conversation, it is already saved. You can see hi. That means the previous conversation we asked hi. Now this was the response. Now again, human is asking, my name is Bappy. I have moved 33 times. That means the question you are asking, and this is the response I got. Okay. That means it is remembering my previous context. The question actually we asked. Okay, in the chat history. Now let me ask another question. So this is the another question. If my average moving distance was like 100 miles, how many miles took all my moves? So this is my question. Now we'll see that it will remember this particular conversation as well. Like my name is Bappy and I have moved 33 times. You can see inside. So you can see this is my current question, and this was my chat history. Hi. This was the response. Again, this question I asked. Then this was the response. Okay. Now this is the current question I'm asking. Okay. And this is the current response I'm getting. Now see what is happening here. What is happening? See, it is using the entire actually prompt. That means the previous conversation also it is passing as an input to the model. That means whenever you are asking something, let's say whenever I'm asking something, let's say this is my LLM. This is my LLM. So the first thing I have asked about hi. Okay. Hi. So it has given me how are you? Okay. How are you? Then again, whenever I'm asking the second prompt, let's say my name is Bappy. Okay. I'm asking my name is Bappy. So first of all, it is going like that. Let's say hi. How are you? Okay. How are you? Then my name is Bappy. My name is Bappy. So this is going to be the input prompt right now, and it will give me another response. Okay. Then whatever response you are getting, again, it will add the response with this particular prompt. That means every time, whenever you are asking the question, every time, whenever it is saving the conversation, it will pass this conversation as an input to the LLM. That means if you are doing, let's say, multiple conversation, like the conversation, let's say you are continuing, at that time, your input prompt is also increasing. And whenever input prompt is also increasing, I think you know how ChatGPT, OpenAI charges based on the input limit token, right? So based on that, actually, it will charge you more. Okay, that means here you don't have any control. So as much as conversation you can perform here, and it will remember all of the chat history. So it's not an efficient way, because I need some certain actually question. I need some certain conversation. Let's say around 5 to 6 conversation. I want my model to be remembered. Okay, because whenever you are creating any kinds of real world application, let's say ChatGPT, so user will ask, let's say 3 to 4 times. Okay, the conversation they are doing, they are not, let's say yesterday whatever things they did, they won't be asking that one. Okay, they will be creating a new chat. I think you are getting my point, right? So that's why we always need to specify like how many conversation my application should remember. Okay, so these kinds of functionality you don't have here. The method we are using, this buffer memory you are using here, we don't have this particular method. Okay, for this we'll be using another technique, I'll tell you. But before that, so let me show you whether it is able to remember my name or not. So here I'm asking, and you remember I have given my name here. So here my name is Bappy and I have moved 33 times. Now here I'm asking, do you remember my name? So it will tell me, yes, it remembers my name. My name is Bappy. How it is remembering? Because it has the entire chat history, entire conversation, okay, with it. That's how actually it is remembering. I hope it is clear, guys. Now, how we can use the memory. Now you can see the buffer. Like buffer means the buffer means it is saving everything in the RAM. Okay, your whatever RAM you are having, your memory, it is saving. See, you can see this is the question we have given. So see all the conversation it has saved. Okay, but this is a temporary memory. Let's say if you let's say if you close your application, again this memory would be disappeared. That means everything would be deleted, everything would be clean. But how we can save it as a permanent, that thing I will show you. Whenever we'll be creating one application, that time I'll show you how we can save this information in a file. Okay, you can save in a JSON file, you can save in a YAML file. Everything is possible. Okay, so to prevent this issue, we can use another function from the LangChain called conversation buffer memory, buffer window memory. Okay, so here you can mention the window limit, like how many conversation you want to save. You can see similar to the previous one, but you can limit the number of conversation actions stored in the memory. For example, you set it to the set it so it only remembers the last 3 questions and answered of the conversation. Okay, so let me show you one example. So first of all, let me import. You can see I'm importing this conversation buffer window memory and the chat conversation chain. Now first of all, let me create the memory. Now we'll be creating the window memory, and k is equal to 3. That means it will only remember my 3 conversation. Okay, past 3 conversation, not more than that. Now let me create the chain. So this is my chain. You can see inside that I'm passing the LLM memory purpose is equal to 2 because I want to see the execution log. Now let me show you. So here I'll be giving one input. Let's say this is the input. Hi, my name is Bappy. Okay, now this is the response. Hello Bappy, nice to meet you. How I can assist you? Now let me give another question. So here I'm asking, my favorite color is blue. So you can see this is the question I have asked, and this is the history. Hi, my name is Bappy. Hello Bappy. You can see that this is the history. That means the previous history it has remembered, and this is the current response. Now let me ask another question. So my favorite animals are dogs. So my favorite animals are dogs, and you can see my favorite animals dogs. That means it will only remember 3. Okay, 3 conversation, not more than that. Let me ask another question. I would like to drive a Vespa scooter in the city. Now here I'll give another input. So my favorite city in San Francisco. Okay, now here I can ask something. Let's say, what is my favorite color? I think you remember I've given one question. My favorite color is blue. Okay, here. Now if I'm asking what is my favorite color, so now tell me, will it remember? No, it won't be remembering. You can see, I'm sorry, I don't have the enough information. Would you like to share your favorite color with me? Because it has only saved the top 3 information. Okay, the top 3 conversations. So here you can see it has saved this conversation. My name is Bappy. My favorite color is blue. No, I think last 3 conversation. I'm sorry guys. Last 3 conversation. What was the last 3 conversation? My favorite color. No, not this one. Here. My favorite city is San Francisco. I would like to drive a Vespa in a city. And my favorite animals are dog. Now here you can see, you can simply ask, let's say, the last question you have asked, my favorite city. So here you can copy this one. And here you can ask, what is my favorite city? See, it will be able to give me the response. What is my favorite city? See, your favorite city is San Francisco. Okay, so that's how you can control this window. Okay, with the help of this this one, buffer window memory. Very simple concept, but again very important. Okay, very important guys, try to remember. So if you're creating any projects, definitely this functionality you have to add at the end. And I've showed you both of them, like how we can remember the entire conversation, how we can specify some certain conversation. You can do anything. And this is called actually temporary memory guys. Okay, temporary memory, because if you close the application, it will clean all the information. Okay, but we have to build some permanent solution. Let's say if I'm closing my application also, let's say in some cases my application is crashing. It's not like that it will forget everything. No, it will remember. And how it will remember? For this you have to create a permanent solution. And again, with the help of this buffer memory, we can also create a permanent solution. We can save these are the information in a file. I'll tell you. Okay, going forward, we'll be creating the project. That time I tell you. Now there is another one. We call it as a permanent memory. So we'll be using with the help of LCL most of the time. That time actually we'll be understanding. But let me give you some high level overview. Okay, which is called actually chat history. Okay, save the list of the chat messages and then fetch them all. So this is the idea of this one. Now let me show you an example. So let me define my LLM. Then here is one example I can show you. So you can see I'm importing this chat message story. Then we are creating an object and we are adding some message. Let's say hi and WhatsApp. Okay. Now if I execute and if you see the story message, okay, see it is saving the information. Okay, so here you have asked hi and AI message WhatsApp. So here you can see user, add user hi and add AI message WhatsApp. Okay, you have specified the format, but see, as of now I told you we'll be showing you the high level demo, but whenever we'll be creating the application, so that time we'll be using like that. So let me show you in the beta mode. So here is one example, guys. So here is the example. So we have to create a function. Okay, session function. So with the help of that, we'll be using this particular, let's say, statement. Okay, so this thing we'll be learning later on whenever we'll be creating some project. I think that will give you like more sense. Okay, how we can use the this memory actually. Okay, but if you want to make it this memory as a permanent, the buffer memory you have learned. So we have an amazing actually idea we can follow. Okay, usually. Great. So yeah, so this is all about our memory. Okay, memory inside LangChain. So apart from that, I think you don't have anything. You can still see the documentation. So they've included so many things, but I don't feel like it is required. So memory, so chat message. So I have showed you this example and beta memory. That means this buffer memory also I also told you. So memory in LangChain. So we have already discussed the buffer memory. Okay, as well as the window buffer memory. Yeah. So guys, now we'll be starting with our second generation of LangChain called LCEL or LangChain Expression Language. So nowadays, actually, this is super important concept. If you want to use LangChain, so you have to know about LangChain Expression Language. So LangChain has created the second generation of LangChain. So previously, the LangChain we used to use, this is called legacy LangChain. Okay. So I'll give you the introduction of this entire LangChain expression language. We'll be also learning about what is runnable chains. Okay, so here each and everything we'll try to master. So let's start with our LCL concept. First, I'll be discussing about the runnables. Second, we'll be discussing about LCL chain, like how we can create a chain with the help of LCL. So it is nothing but sequence of runnable. Sequence of runnables. Then third, I'm going to discuss runnable execution order. Then runnable execution alternative. Okay, alternatives. So some of the topic we'll be discussing in the next session. Okay, so let me write down what are the things we're gonna cover inside this LangChain expression language. Okay, and apart from that, there is nothing. So 5 we'll be discussing about some built-in runnable and function. Then we'll be discussing about basic LCL chain operation. Okay, chain operation. So these are the agenda, okay, through our entire this LangChain expression language series. Now let me tell you where we'll be using this LangChain expression language. I think we saw the like high level architecture of any kinds of Gen AI application. Let's say, first of all, what we do, we give the data input. Yes or no? Data input. Okay. So after giving the data input, what happens, guys? Some action has happened. Action happens. Actions. So inside actions, I think you know that what we create the prompt. Okay. Then we create the chain. Okay. Then what we do? We use so many runnable. Okay. Then after that, what happens? We pass this data to the LLMs. And LLM will give me output. So this is the high level architecture of generative AI. First of all, you have to give the data. Then some action will be happening. Let's say it will create the prompt chain and all. After that, this data would be passed to the LLM. Okay. Then it will give me the output. So here we'll be using the LCEL in this section. LCEL. Okay. So here we'll be applying this LangChain expression language. Okay. So the same thing, whatever things you have learned so far, everything will remain common. Only whenever you will be doing the action, that means you'll be creating the prompt, you'll be creating the chain. Okay. So there actually you have to use this LangChain expression language. That means second generation of LangChain. Only the syntax would be different. Okay. So the previously we used to use some, let's say, a predefined function, chain function. Okay. But now what you will be doing, you will be using this LCEL technique. Okay. This is the idea. I'll also show you the documentation, like what is the change they have done. I think then this part would be more clear. Okay. So let me open the documentation, LangChain expression language documentation from the LangChain. See what they usually do, instead of using the predefined chain, they use the pipe symbol to create the chain. Okay. Now if I show you the older one, see this is the older chain approach. So here we are having different kinds of chain, you can see. Okay, different kinds of chain functions. So let me show you some of the chain. So let's say this is one of the chain, retrieval QA, this is one of the chain. Then you are having Kuzu QA chain. Then see LLM math chain, LLM checker chain. Okay, so these are actually chain. Okay, these are actually chain function inside LangChain. And that was the legacy LangChain. Okay, this is the legacy LangChain technique. So let me show you one of the code example. Let's say I want to use this retriever QA. So this is the example of the retriever QA. So you have to import this retriever QA chain from the chain itself. So this is the legacy LangChain, guys. Okay, that means this is the older LangChain, first generation LangChain. Then what you have to do, you have to initialize your LLM, create the prompt. After that, this prompt and whatever LLM you have defined, you have to pass inside the chain. You can see, first of all, I'm giving the LLM, then I'm giving the prompt. Then you can perform the actually invoke operation. Okay, after creating the chain, you can perform the invoke operation. That means you are using some predefined function. Okay, predefined function from the LangChain itself. And this is the legacy example. Okay, now what is the newest one, the newest version of the LangChain? So this is the newest one, guys. Okay, this is the LangChain expression language. So they created another version of the LangChain, which is called second generation LangChain, and they're suggesting try to use this particular approach right now, okay, to create the chains. But see, it's not like that always you have to use this new approach. Okay, still they are recommending you have to use the legacy LangChain. In some of the application you have to still use the legacy LangChain. Okay, so now you will have one question like, what is chain exactly? Okay, so let me show you some of the demo. Some of the example I have already written. Let me just show you on my board. See, so what is chain, guys? Chain is nothing but it performs several action in a particular order. Okay, yes or no? So here I think you know that we created a chain and it is following one order. First of all, we are defining the prompt, then the model, then output parser. I have given one basic RAG example with the help of LCEL, and there I use this syntax, I think, guys, remember. So you can see here I'm performing some step of what? Step of execution. That means perform several action in a particular order. So these are nothing but action. We are performing some action. So prompt is one of the action, model is one of the action, output person is one of the action, and these called actually runnables. Okay, these called actually runnables. Why this is called runnable? Because it's a executable. Okay, it's executable. You can see prompt is an object, then model is an object, output person is also an object. That means you can execute them. Okay, then you can perform the invoke operation. So whenever you are performing the invoke operations, what is happening? First of all, it is invoking the prompt. First of all, it will prepare the prompt, then it will invoke the model. That means this prompt will pass to the model. Okay, then it will invoke the str output parser. That means it will give you the output. That means what is happening? First of all, you are executing the prompt. Okay, the output of the prompt would be input of the model. Okay, then the output of the model would be input of the output parser. That means it's following one sequence. And what is the sequence it is following? It is following left to right sequence. Okay, left to right sequence. Always try to remember whenever you are creating this chain, okay, inside LangChain, the execution would be left to right, not right to left. Okay, left to right it would be. And if I show you the legacy LangChain, legacy chains, you will see that instead of using that symbol, actually pipe symbol, what we are doing, we are using the function create retrieval chain from the chain, and here we are passing it, and there order doesn't matter. Okay, here order doesn't matter. You can either pass LLM, either you can pass prompt. Okay, so that's why there are some people actually who prefers this legacy LangChain format. For them actually this one actually a little bit confusing, but there are some people they actually prefer this particular new syntax because it's easy to write. Okay, it's easy to write because here you don't need to import it and you don't need to pass it here, because see, you can see after importing it, I need to pass this prompt LLM and all, then again I have to give the retriever and all. But here you only just need to use the pipe symbol and you have to mention the executable, sorry, runnable one by one. Okay, that is the idea. So now I think you got some idea about the this one, your chain. Okay, what exactly this chain, and what is the LCEL, that means LangChain expression language, because it's a second generation LangChain. Let me show you the introduction of it. Like chains are sequence of actions with input or output data. Then since the emergence of the LCEL, LangChain is favoring LCEL chains over the traditional legacy built-in chains, but these are still maintained, okay, and frequently used. That means see what they are telling. Although actually we are having this LCEL, that means LangChain expression language, but still in some cases actually you have to use the legacy LangChain, okay, because still it is under maintain. Okay, so they are maintaining it. So in some cases actually you have to use the legacy LangChain. Okay, it's not like that always you have to use the second generation of the LangChain. Okay, so because see, LCEL is still it is still under development. Okay, they're also adding new things here. Okay, so that's why they are suggesting to use the legacy LangChain in some cases. Fine. So now let's create one basic this one basic chain with the help of our second generation technique. So here I'll be creating a notebook 06 LCEL. So guys, I think you already know, first of all, I have to load my OpenAI API key because I'm going to use my OpenAI model. You can also use any other model, like you can use the Grok API. You can also load any open source model. Okay, it's up to you. Then after that, I'm loading the chat model. I already told you we'll be using chat model going forward because chat model is the most used model nowadays. Then here is the basic syntax of the LCEL. I think previously I also showed you. Okay, then I told you we'll be discussing about that, okay, in detail. Now see, I have written the same syntax. So here I have imported the output parser, chat prompt template. Okay, inside chat prompt template, I have given my prompt template. So tell me a curious fact about. You can give elements of politician name, sports name. Okay, it's up to you. Then here I've created the chains. Okay, so the first component will come the prompt. Then the second component will come the chat model, and the third component will come the output parser. Why? I already told you, it's a step of execution. Okay, first of all, prompt will be executed, then chat model, then output parser. So if you do the invoke operation, let's say politician is equal to, I have given a JF key, that means Kennedy. So what will happen? First of all, it will create the prompt, the entire prompt. So inside politician, JF key will come, then it will create an entire prompt, then it will pass to the LLM. Okay, LLM will give the response, and this response will take the output parser. And what LLM gives the output, guys, I think you know, it will give you the AI message output. Okay, so I have to take the string output. For this, I'll be using str output parser. Now see, this is the actually output I got. Because what happens actually, see, whenever you are using LLM, so by default, what will the output it will give you, guys? So I think you remember, it will give you the output in a AI message format. Let me show you. See, AI message format. Okay, AI message format. But I don't need the AI message format. What I need this string output. Okay, so to get the string output, I'll be using the output parser. So output parser will automatically extract the content. Okay, extract the content from the response, and it will give me. Okay, now I think you are clear. Okay, why? Actually, we are following the sequence. See, always try to remember, whenever you are using LCEL technique, you have to follow the sequence. If you are let's say not giving the proper sequence, it won't be working. So first of all, prompt, then chat model, then output parser. That means left to right, you have to create it. Okay, so now let me show you some LCL introduction, like what is the main goal to use the LCL and all. So here is the example. See, LCL has become the backbone of the newest version of the LangChain, because LangChain is updating their let's say code base frequently in today's world. Now traditional chains are still supported, but treated as legacy and has less functionality than the new LCL chains. That means whatever legacy LangChain we are having, okay, you can also use them, but it is having some less functionality than your new LangChain, okay, new LCL, that means second generation LangChain. That means nowadays whatever, let's say, new functionality they are adding, let's say they are adding, I think you know, they are adding what, LangSmith, okay, LangSmith, then LangGraph, okay, then LangServe. So all the LLM ops tool actually uses this LCEL, okay, LCEL. That means this second generation of LangChain, okay, it supports. Now let's see, you are working with the legacy LangChain. That time what will happen, you won't be able to use, these are the new functionality, whatever new let's say tools and technology they are proposing in their framework, you won't be able to use them, okay, if you're using the legacy LangChain. But if you're using the latest, that means the second generation of the LangChain, that means if you are using the LangChain expression language, that time you can use these are the tools and technology very easily, because it already supports them, okay. So that's why here I have written many a main goal of the LCL, make it easy to build chains in a compact way and supports advanced LangChain functionality. That means whatever advanced LangChain functionality people have created, all the LangChain all the, let's say, advanced functionality can supports that particular LCL technique, okay. I hope it is clear. But there are some drawbacks. Many students struggle with the LCL because the let's say syntax we usually write, it would be a little bit confusing at the very first time, okay, because if you are already, let's say, familiar with the legacy LangChain, whenever you are coming to the LCL, some of the syntax would be a little bit confusing for you. That's why many students struggle with the LCL technique. But no need to worry, I will explain in a simple manner. This concept would be more clear, okay. Now let me show you one legacy LangChain example, okay. So for this, what I will do, let me just comment here. Legacy chain example, let me show you. So this is one legacy chain example. So here I can use my chat model. See how we are creating the chain. First of all, we are importing one LLM chain, and this LLM chain is available inside legacy. Okay, legacy chain, if you just find here, you'll see that this LLM chain is available, okay. Now let me open it up and you can see the example. First of all, you have to import it, okay. See LLM chain, first of all you have to import it, then inside that you will be passing your prompt as well as the LLMs, okay. So same thing actually we are doing. So first of all, we are importing LLM chain, we are creating the prompt template, then inside the chain we are passing the chat model as well as the prompt, okay. Now see, first of all we are giving the chat model, then we are giving the prompt. That means order doesn't matter here. If you're using legacy chain, that means order doesn't matter, you can pass anything. But whenever I were using LangChain expression language, LCL, that time order is matter. First of all, you have to give the prompt, then chat model, then output parser, okay. Now here you are doing the predict operation, but here you are performing the invoke operation, okay. Now see, if I execute this code, it will still work, but it will give you some deprecation warning. See, it will give you this nasty warning, okay. It will tell you this is LLM chain was deprecated in LangChain 0.1.17 and it will be removed in 1.0. Okay, so use runnable sequence instead that. Okay, runnable sequence means the latest LangChain. That means they're telling just try to use the pipe symbol. That means LangChain expression language. See, they're also suggesting in the warning. Okay, so that is what actually I'm telling you. See, it is still people are using, but going forward actually they may remove this particular, let's say, functionality from the LangChain itself. So you have to work with the latest version of the LangChain, but still they're suggesting try to use the legacy LangChain as well in some other use case. Let's say you are having some advanced use cases, that time you can also use that one, okay, because inside LCEL, so many functionality as of now they haven't integrated. Okay, still it is under development. That is the idea. And if I want to do it with the help of our LCEL, so this is the syntax, guys. First of all, prompt, then model, model, then output parser. Okay, output parser. See, and there is no warning. Let me show you another example. Let's say this is another example. Here I'm creating a prompt template. So this is the prompt template, guys. You can see, tell me a curious fact about soccer player. So here you can give any kinds of soccer player as an input. Then I'm initializing the output parser. You can also store inside a variable, and you can also pass. Okay, it is also possible. Now prompt, chat model, output parser, and here I'm doing the invoke operation, and input I'm giving Ronaldo. Okay, now if I execute, first of all it will create the prompt, then it will go to the chat model, then it will give you the output. Okay, this is the output. Now let me show you the runnable order. Okay, what is the runnable order? It is following. So for this I'm going to use one image. So this is the image, guys. You can see this is the runnable execution order in LangChain expression language. Okay, and what is runnable? I already told you. Okay, these are nothing but our runnable. So see, the action you are running now, this is called runnable. Prompt is a runnable, chat model is a runnable, output parser is a runnable. Okay, because you can execute them. That's why we call it as a runnable. Apart from that, we are also having some built-in runnable. I'll tell you, I'll be discussing those built-in runnable as well. Okay, so first of all, let me show you the execution flow. See, first of all, what is happening? I think you remember here we have passed this particular, we created this prompt. Tell me about the curious fact about soccer player, and this soccer player we're taking as an input from the user. Okay, now whenever you did the invoke operation, that means first of all it will invoke the prompt. Okay, and it will create the complete prompt. You can see it is creating the complete prompt. So that means user is giving the like prompt, that means the input soccer player Ronaldo, and whenever it is going to the prompt, here, okay, it is creating the entire prompt. Tell me a curious fact about Ronaldo. See, tell me a curious fact about Ronaldo. Then this particular output will go as an input to the LLM model. LLM model will accept. You can see the next runnable is my chat model. That means my LLM, and LLM will take it and it will give you one response. Okay, the response actually we got. You can see the response we got. AI message. Okay, it will, how it will give you the response? It will give you as an AI message, because by default LangChain labels the output as an AI message. Okay, and inside that I'm having the content. Now what I will do, I'll pass this output to the output parser. Okay, output parser will only give the content. You can see I'm passing to the output parser, and output parser is only giving the content. Okay, see, it is only giving the content, and this is my final output. So this is the runnable execution order inside LCEL. Okay, that means left to right execution. Okay, I hope it is clear, all of you. That means we have discussed, these are the thing. We saw the runnable, sequence of runnable execution order. Now let's see some runnable execution alternatives. Okay, instead of invoke, what are the method we can apply on top of runnable? Okay, let me show you. So instead of invoke, you can also apply a stream as well as the batches. Let me show you some example. So let's say this is my chain I have created. Now instead of giving the invoke, you can also use the chain, stream. And what is stream, guys? What is stream? I think you know that. If I go to the chat GPT, if I open the chat GPT and if I ask something, it will give you as a stream output. Okay, let's say here I can give, tell me about Ronaldo. See, it will be a stream output. See, after one word, another word is coming. Okay, it's a stream output. But whenever I used to perform the invoke operation, it will give you the output in just one shot. But if I want to get the stream output, that time we'll be using the stream. See, chain.stream, and here instead of politician, I'll give the soccer player. So soccer player, I'll give Ronaldo. Okay, now see, you have to write inside a for loop. Now if I execute, see, it would be a stream output. Okay, so it is telling it doesn't have any content. Let me check. Okay, so if I want to get the stream output, that time content I don't need. If I execute it, now see, so only you just need to print this, because output parser will automatically give you the content, so you don't need to get the content. Now whenever I execute it, you will see that it would be a stream output. See, it is streaming output. After one word, another word is coming. Okay, Then let's say you are having some batches input. Let's say instead of Ronaldo, you are also want to give the Messi. Okay, and you want to get the response for both of the input. So that time you can use the batches. See, this is one of the example. So instead of in stream at the time you have to use the batch. So here you can give soccer player. I'll give Ronaldo as well as the Messi. Okay. Now here I'm passing inside a list. Okay. You can see I'm passing inside a list. First of all, it will take the Ronaldo, it will generate, then it will take the Messi and it will generate. Let me show you. See, this is the Ronaldo and this is the Messi. Okay. So this is called actually runnable execution alternative. That means instead of invoke, okay, instead of invoke, you can also use other function. Let's say you can use stream as well as the batches. Okay, I hope it is clear. Now, one thing actually this second generation LangChain will give you, and this is like very powerful, which is called LCEL chain or runnable can be also used asynchronously. Okay, asynchronously. That means you can execute simultaneously. Let's say you are having two runnable. You are having, let's say, prompt, then you are having chat model. So these two operations you can run simultaneously. That means it can perform the invoke operation at the same time. Okay, I think you have learned about the parallel, okay, parallel computing and all, I think multi-threading and all, right? So this is the similar kinds of concept. Sometimes what happens whenever you are implementing any big application, right? Any big application, there you will be creating very complex chain, yes or no? So there would be so many chains. Let's say C1, pipe C2, pipe C3, pipe C4. Okay, that's how it would be a long chain. Okay, that time if you are following the sequence of order execution, okay, that means this particular simple chain, so it's following sequence. First of all, prompt template will execute, then chat model, then output parser. But whenever you are getting complex application, if you're following the sequence, it will take lots of time to give you the input. So that time what happens actually, it runs actually asynchronously. That means parallelly it will run. Okay, for this we'll be learning some built-in runnable inside LangChain. In the next class we'll be learning some built-in runnable inside LangChain. This is the agenda. So guys, as I already given you the introduction of this LangChain expression language, and I already told you why it is important and how this works. Now we'll be discussing about some built-in runnables, okay, inside LCEL, that means LangChain expression language. So this is super important concept if you're learning LCEL. So you have to know about this built-in runnables. So let's try to see some practical demo of this. So inside built-in runnables, you are having some runnables. Let me just write one by one. So first of all, you are having something called runnable pass-through. Okay, runnable pass-through. Then you are having a runnable lambda. Runnable lambda. Then you are having runnable parallel. Okay, parallel. So inside runnable parallel, you are having one very important thing called item getter. Okay, yes, so these are the very frequent used runnable, okay, inside LCEL, that means LangChain expression language. So if you see any kinds of implementation, so people are using, these are the runnables. Okay, so here I'll show you each of example of the runnables actually I have listed down here. Okay, first of all we'll try to understand the runnable pass through, runnable lambda, then runnable parallel. Okay, everything we'll try to explore. Now I think you remember guys, in my previous session I was talking about the runnables. So what exactly the runnables? I think you remember guys. Remember what exactly the runnables? Let's say, I think you remember we created a chain. So here maybe I can show you the code example, that would be fine. So this is my LCEL notebook. So here you can see I created a chain, and to create a chain guys, what I did, I used some of the runnables. Okay, runnables is nothing but it's a executable. Okay, that means it's a sequence of executable. That means you are performing sequence of action here. So prompt is one of the action, chat model is one of the action, and output parser is one of the action. That means first of all, prompt will be creating, this prompt will pass to the chat model. That means whatever output you will be getting from the prompt, that would be an input to the chat model. Then chat model will return the output. It will be taking this str output parser and it will give you the output. Okay, that means this is my runnables. Okay, these are my runnables, these are my executable, and with the help of this runnable, with the help of this pipe symbol, what we are getting, we're getting the chain. Okay, it's the step of execution. Now inside LangChain, inside second generation of LangChain, they created some actually built-in runnables. Okay, these built-in runnables will help you to build this chain in a more, let's say, advanced way, in a more, let's say, powerful way. Now let me tell you how we can use them all one by one. So let me create a notebook here first of all. So I'm going to name it as 07 LCEL. Okay, LCL. Built-in runnables. So let me select my kernel. So the first thing, I'll be loading my OpenAI API key. You can also load your Grok model. It's completely fine. Then we'll be initializing our LLM. So here we'll be using chat model. That means GPT 3.5 turbo model we'll be using. Okay. So the first thing I'll be discussing about runnable pass-through. Okay, runnable pass-through. I think you remember I have written here runnable pass-through, and this is a built-in runnable. Okay, now let's try to understand what is runnable pass-through. See, it does not do anything to the input data. Let's see it in a very simple example. A chain with a just runnable pass-through will output the original input without any modification. So let me show you one example. Let's say this is the example of runnable pass-through. So it is available inside LangChain code. Okay, you can see it is having one function called runnables. Inside that, we are having different kinds of runnables, like runnable pass-through is there, then runnable lambda is there, runnable parallel is there. Okay, different runnables are available. That's why we call it as a built-in runnable. Okay, built-in runnables, because it is already built in inside LangChain. Now here we are creating an object of the runnables. Okay, and we are naming this object as chain. So let's say I'm creating a simple chain. This chain only perform runnable pass-through operation. Okay, why runnable pass-through operation? Because I want to show you the runnable pass-through example, like what it will do exactly. So here I've already written it does not do anything to the input data. That means whatever input you will be giving, the same input it will give you as an output without doing any kinds of modification. Okay, let me show you one example. So I think you remember we can execute the invoke method on top of any kinds of runnable, any kinds of executable, yes or no. So we can do it. Let's say here I will call chain.invoke. Okay, chain.invoke. Inside that, let's say I will give my name, Bappy. Okay, let's say here I've given my name. Now see, if I execute this line, so what will happen? It will give me Bappy as an output. Okay, why? Because here I told you it does not do anything, okay, to the input data. That means whatever input data you will be giving, it will return as an output. That's it. So this is the example of runnable pass-through. That means it will only pass through your input. Okay, pass through your input and it will give you the same output. Got it? Now you can ask me, what is the use of this runnable pass-through then? Definitely there is a use of, because whenever you will be creating the chain, so the first thing what user will do, guys. So let's say whenever I'm creating any kinds of, let's say a LangChain project, or let's say LLM powered project. So the first thing, user will give the input, right? Okay, user will give the input, and this particular input I have to take as it is. So whatever format they are giving, I have to take as it is. Okay, so we'll be handling with the help of runnable. Okay, runnable pass-through. Okay, so that is the idea. That means whatever input data user is providing, you will be handling through this runnable pass-through. This is the idea. Now second, let's try to understand the runnable lambda. Then we'll be combining all of them together. Okay, so we can combine all of the runnable all together. It is also possible. Let me show you. So let's say this is the runnable lambda example. You can see, to use a custom function inside LCEL chain, we need to wrap this up with a runnable lambda. Let's define a very simple function to create a Russian last names. Okay, so what I'll show you guys, I'll show you one example. Let's say here I created one function called Russian last name. If you see any kinds of Russian last name, you will see this particular word called ovis. Okay, ovis. Any kinds of name. Let's say you can give let's say Abram, you can give Bappy, you can give let's say any name. You will see that this would be the spelling at the last of that particular let's say name. Okay, that's why here we have created a function called Russian last name. This will take one input called name, and name should be integer, string, and it will also return as a string output. And here I'm returning, guys. Here I'm writing a f string. Inside that, whatever input user is giving, that is whatever name user is giving, I'm just adding with this obvious. Okay, that's it. So now let me execute. Now let me show you one example how this will work. So let's say this is my function. Inside that, if I give let's say Bappy, you'll see that with Bappy actually it will add this particular part called obvious. Got it? Now let me delete it. It's not required. Now, in order to use this function inside my chain, okay, we'll be using runnable lambda. Now let me show you one example. So here is the example, guys. So you can see I'm importing this runnable lambda from the Runnables, from the LangChain code. So the first runnable will be adding the runnable pass through. Why runnable pass through? Because I think you know this sequence of execution. Remember, guys, sequence of execution. Whenever we are creating any chain, C1, C2, okay, C3. So I have to go left to right, right? Left to right. So the first of all, what user will give? User will give the input data, yes or no. User will give the input data. This input data I have to receive. And how we can receive? With the help of runnable pass through. I think you saw one example here. So with the help of runnable pass through, we can take this input, and this input will give me the same output as it is. Okay, so that means whatever input user is giving, it will come here, then it will return. Okay, it will return to the runnable lambda. That means this will go there. That means left to right. Input will come here, it will return as it is. Okay, the output of the runnable pass through will be input of the runnable lambda. And what runnable lambda is doing? It is taking one function. Okay, it is taking one function called Russian last name. Okay, now I think you remember, guys, lambda function. Do you remember the lambda function inside Python? So inside lambda function, I think we used to also do the same thing, yes or no? Or maybe you have learned about higher order function inside Python. Okay, this is the similar kinds of concept. That means a function is taking another function as an input. Okay, this is called higher order function. Now this function is doing, it is just adding this particular obis at the last of the name. Okay, now let's say if I execute this chain and if I show you the output, so what will happen? So let's say I'll execute. Now if I just write, let's say chain dot invoke, and if I now let's say give Bappy here. Okay, if I give Bappy here, so I'll give my name, just a minute, Bappy. Now see what will happen. Now see, if I execute, it will give me Bappy obis. Why? Because first of all, Bappy will go inside runnable pass through. Runnable pass through will return this Bappy as it is. Okay, as it is, and then it will come to the runnable lambda. Runnable lambda will take the Bappy and it will execute this particular function, the function you are giving as an input. So this will add this obis with my name. Okay, so this is what actually we are doing. Now you can see with the help of multiple runnables, we can create a chain. So this is the idea, guys, inside LangChain. LangChain is nothing but you are creating the chains. You are creating the sequence of execution, sequence of action. Okay, the action you want to perform with your data, with your large language model. Got it? So this is what actually chain. Now this is the simple chain we have created. Going forward, we'll be also creating complex chain. We'll be using retriever. Then we'll be using vector database and all. Okay, with the help of that, we'll be creating the complete chain. That means the RAG chain and all. Everything will be creating. Got it? Now the next one we'll be learning about runnable parallel. So this is, guys, one of the very important runnable inside LCEL. That means without that, you won't be able to create any kinds of big application. Let's say whenever you want to create any kinds of bigger application, let's say you want to create a complete chat GPT kinds of, let's say, chatbot. It's a bigger application. So lots of people will come, they will give the different prompts. They may pass is short prompt, bigger prompt. Okay, anything they can pass. So now if I want to handle this kinds of, let's say, execution, that means whenever I'm talking about big application, that means your chain would be also big. So whenever you are creating the chain, let's say C1, C2, and C3 and so on, right? Your chain should be also big. So let's say if I'm following the simpler approach, that means the sequence approach, that means left to right. First of all, this chain will execute, then this chain will execute, then this chain will execute, and so on, right? Now you can see it is taking time now. First of all, this will complete, then this will start. This will complete, then this will start. So it is time taking. So it will be taking time as per the user input, as per the chain, okay, chain size in the application. So what we can do, guys, we can utilize the multi-threading approach here. That means we'll be running everything in the parallel. Okay, let's see if I'm having a very big chain. and and with the help of that you are getting the big application. That time we can execute in parallel. So I think you know multi-threading, parallel computing, yes or no, right? So at the same time we can execute multiple operation. This is called actually parallel. Okay, so in LangChain also it is provide actually runnable parallel. That means we'll be using runnable parallel for running task in parallel, and this is probably the most important and most useful runnable from LangChain you will be using going forward. Go ahead. Now there are some way actually we can write this runnable parallel. First of all, I'll show you the easy one. Okay, easy one. So this is the example, guys. So this is one runnable parallel example. You can see I'm importing runnable parallel from the runnables inside LangChain code. Now here I'm defining one object called runnable parallel. Inside that I'm giving two tasks. You can see the operation A. Operation A actually I'm taking the runnable pass through. And what is runnable pass through will do? I do remember here. Runnable pass through, it will only return the same input the input actually will be giving. So we are already familiar with the runnable pass through. And the second operation we are performing runnable lambda. That means the same thing. And what runnable lambda will do, it will take another function and it will perform the job. Okay, that means higher order function. You can see. Okay, now you can see the both operation I'm passing inside runnable parallel. Okay, that means this two operation will execute at the same time. It's not like that. First of all, it will complete, then it will start. No. It will start at the same time it will also start. Okay, that means you can let's say execute this particular application in a very short period of time with the help of parallel computing, with the help of parallel runnable parallel. Okay, this is the idea. Now let me execute and let me show you. So let's say here I will run this chain. Let's say chain.invoke. I'll give Bappy. Now see if I execute. So here you can see operation A Bappy is coming, operation B Bappy OVC is coming, because here you can see it is also executing this particular function. Okay, so this is called runnable parallel, and this is the most used runnable you will be using inside LCEL. You can add as many as, let's say, runnable you can. It's not like that you are having some restriction. No, you can create your chain as complex as you can. Okay, it's up to you. Now let me show you another example. Let's say, so we'll be adding some more, let's say, runnable with our chain. So for this I'm going to use my LLM. So first of all, I will import these two library, str output parser and chat prompt template. What is output parser? I think you already know. So here I already showed you the example in my previous session. Okay, output parser, it will give you the output as a raw text. That means the string. Okay, and chat prompt template. Why? Because I am using the chat model. If I want to create the prompt template, I have to use the chat prompt template. That's it. Now here I'll initialize my prompt template as well as the output parser. You can see I'm initializing both. So this is my chat prompt template, and this is my template I created. Tell me a curious fact about this. Is the input user will give me. Okay, soccer player, and this is the output parser object. Now here I'm going to create another higher order function. That means the same Rashi and last name from dictionary. Okay, that means whatever name user is giving, it will add the OVC here, and it will add from the dictionary right now. Okay, we'll be giving the dictionary as an input. From the dictionary itself, it will take the name. This is the idea. Now we'll be building the runnables. See, that's how we can build the multiple runnables. You can see runnable parallel. Now inside operation A, it will do the runnable pass through. That means whatever input you will be giving, the same input it will give you as an output. Now the second thing, soccer player, that means runnable lambda you are executing. That means the input you are giving. Let's say we have given Messi. Okay, so what it will return, guys? It will return Messi only, because you can see runnable pass through you are executing, and runnable pass through will return as it is. Then the second execution we are doing runnable lambda, and inside that we are executing this function, and this function will add the OVC here, right? That means if I'm giving Messi, so it will happen, it will return as a Messi OVC. Okay, Messi OVC. And the second last operation we are performing the runnable pass through again. That means whatever Messi OVC it is returning, same it will take the input and it will give you the output, because again you are running the runnable pass through. Okay, in case you can also take any other runnable, it's up to you. Now here, after creating this runnable parallel, we are passing this output to the prompt. Prompt will give to the model, and model will give to the output parser, and output parser will give me the answer. Okay, so this is called actually multiple chain. Okay, multi-chain we have created. Now inside that, let me give some example. Let's say this is the execution I'll be doing. Name one is equal to Jordan, and name is equal to Abram. Now you can see this particular function takes the name. Okay, name key only, but here I have given name one. So whenever this will go here, it will take only this particular name, because it is matching with this particular key. That means Abram will be taking. Okay, now let me show you. If I execute, So see, one curious about Roman Abramovic. See, it is giving the Abramovic because it is taking this name, not this name, because this key is not messing here. Okay, I hope it is clear. You can also delete this part, but I've given as a dictionary input. That's why I've kept actually multiple key value here. Okay, just to show you. Now you can see whatever, let's say name you are giving, it is returning here. This name is coming here and it is giving the Ovic. That means Abramovic. And this Abramovic is again coming here. Runnable pass through. It is again returning the same thing. Now it is coming to the prompt. Okay, now what would be the prompt? Tell me about a curious fact about Abramovic. Okay. Then this particular prompt you are passing to the LLM. LLM is taking the entire prompt and it is giving you the output, and you are applying the output parser on top of it. And output parser will give you the raw text. Okay, that means the string output. This is the idea of the runnable. That means our parallel runnable. Now let's see some advanced use of parallel runnable. So now we'll be using the vector DB technique. That means we'll be creating one RAG. Okay, with the help of RAG, actually we'll be learning this runnable parallel. So initially, I think you remembered we already created some RAG, right? And there I already used LCEL technique, and there I used the basic technique actually. Okay, I was not using any kinds of runnable pass through and all. So here you are already familiar with what is FIAS, what is str output parser, what is chat promptlet, and what is runnable pass through and runnable parallel. And from OpenAI we are importing chat model and OpenAI embedding. Okay. As of now, let's try to consider this is my data. Okay, I'm not opening any kinds of data, txt file, pdf file. I'm not opening. I'm directly passing the data, and this data is, you can see, DSwithBappy focuses on content on data science, artificial intelligence, ML, DL, CV, NLP, Python programming, and so on. Okay. Now this text I want to convert to the numerical representation. For this, what we'll be using, guys? We'll be using embedding model. You can see I'm using OpenAI embedding model, and whatever embedding I'm generating, I'm storing in the FIAS vector database, and I'm creating the vector retriever. I think you know what is retriever. Okay, I already explained. And this is my prompt template. So I answered the following. I answered the question based on the only following context. That means whatever retriever you are created, this is your context, and this context actually it will take, and whatever question user is asking, it will take and it will give you the answer. So here I'm creating the prompt template, initializing the chat model, and now this is my chain. Okay, this is my chain. Now you can see I'm using runnable parallel, and inside runnable parallel, first of all, I'm mentioning the context. That means the retriever. Then the second, I'm mentioning the question. That means whatever question user will give. That means first of all, it will initialize the retriever and then the question. Now you can see this execution will be happening. Now whenever you will be executing the code, it will be happening parallelly. That means at the same time, okay, at the same time, these two operation will run. Okay, and whenever at the same time two operation is running, that means you are getting quick response from your application, yes or no. Otherwise, what will happen? First of all, this will run, then this will run. Okay, and it is time taking. But if you are utilizing your parallel, okay, parallel, let's say computing and all, that time you will see quick response you will be getting. Okay, so that is why we'll be using runnable parallel. And to define runnable parallel, you can use this approach. Either you can use any other approach. I'll tell you what are the approaches are available. Okay. Now after that, we'll be giving the prompt. That means whatever output we'll be getting. Let's say my input is what is DSwithBappy. So first of all, it will give the retriever to the context. Okay, you can see this is the context. That means the entire retriever will go to the context. And question, what is the question? This is the question user is giving. What is DSwithBappy? So this question will come here. You can see runnable with the help of runnable pass through, it will store here. And your prompt is also taking the question. After that, it will create the entire prompt. Entire prompt means answer the question based on only the following context you have given, as well as the question you have also given. Okay. Now this will give you the entire prompt. Now this prompt you will be passing to the LLM, that means model. Okay. Now model will apply this prompt and it will give you the response. And this response you are passing to the str output parser because it will give you the string as an output. Okay. Now this is my question, guys. What is DSwithBappy? And you can see this is a simple RAG we are implementing. Now see if I execute it, so it will be able to give me the answer about DSwithBappy because here I have given the information of my data. Now you can see DSwithBappy is a platform that focuses on providing content like data science, AI, ML, CV, NLP, Python programming, etc. in the English language. Okay. Now see, amazingly it is running. And the execution you saw, okay, the execution you saw, it's like quite amazing because it is running in the parallel. Okay, it's a simple example, but going forward, we'll be creating very complex application. There we'll see that inside parallel, okay, inside runnable parallel, you can add so many runnables, you can add so many executables, so many actions. Okay, it's up to you. Just to give you the understanding, I'm giving you, let's say 3 to 4 examples, but whenever we'll be building the project, that time you'll see the complexity. Got it? Now I think I told you there is another things inside runnable parallel called IMGetter. Okay, now let me show you one example of IMGetter. Okay, so this is the example I already prepared. So you can see I'm importing this IMGetter from operator. Okay, operator is a library inside Python. So here I'm importing it. Then I'm importing fires, output, parser, and complete, runnable, pass through, okay, OpenAI, and so on. That means whatever things we imported previously, the same thing we're importing. So creating the model, creating the vector store retriever template, and see inside template, the modification I did here, insert the following answer in the following language. So here user can also specify the language, like in which language you need the output. So here you can see this is the prompt, answer the question based on only the following context, and this is the question user is asking, and here user is specifying I need the answer in the following language. Now you can give any kinds of language, you can give Spanish, you can give pirates, okay, you can give any kinds of language. Okay, now see I'm creating the prompt template, and this is going to be my chain. Now see, now I'm executing this particular this one, your runnable parallel. Now you can ask me, sir, what is runnable parallel? Because previous example you showed me, this is the runnable parallel. I was using a function. Okay, I was using the function from the LangChain. Okay, yes or no? Runnable parallel, you can see we imported. But here we are not using this runnable function. Let's say, runnable parallel. Okay, we are not using runnable parallel, but you are telling this is a runnable parallel execution. Okay, why? Because inside LangChain, they will give you actually different kinds of way actually you can define this runnable. So let me show you. So here I have taken one screenshot. So this is the screenshot. Let me open up my Blackboard and let me show you here. See, there are some several way you can define this runnable parallel. So the first way you can define like that, we have already learned, right? Runnable parallel, inside that you can define the context retriever, question, pass through. Then the second way you can define that, you can, instead of taking the string, you can directly give as a variable name. Okay, inside that you can pass. And this is the third way. Okay, now see here I'm not using this runnable parallel function. Okay, I'm not using it. Instead of that, I'm using this particular bracket. You can see I'm using this curly bracket. Okay, and whenever you can see this curly bracket, that means it is using the runnable parallel runnable parallel executor. Yes, that means whenever you can see this particular bracket, that means this curly bracket, you have to remember they are executing something called runnable parallel. So by default, LangChain actually created this thing. So they are telling just instead of calling the function again, we can use this bracket. So for the fresher, it would be a little bit confusing initially. But if you practice, if you just, let's say, implement the product regularly, definitely you will make a habit on this. Okay, so this is how actually you have to use this runnable parallel. Okay, so I showed you 3 different syntax, guys. Now you can use any of them, but this is the most used one. If you open up any kinds of documentation, if you open up any kinds of example of the LCEL, you'll see that people are using this particular approach. Okay, instead of using the functionality they are giving. Okay, now you can see inside that I'm having the IMGetter. Okay, now the example I showed you here, inside example, what is the changes I have done? The changes I have done, the answer actually I also want to specify the language. That means this particular application takes 3 input. The first input is the context, second input is the question, and the third input is the language. Okay, now you can see I'm taking the input one by one from the user. Okay, so the first thing will be taking the context. Okay, that means the retriever with the help of IMGetter. Then the second thing will be getting the context question. Okay, from the question, and the third one will be taking the language. Okay, with the help of IMGetter, you can see the language. Now after getting it, this is my parallel. Okay, this is my parallel actually runnable. That means all the 3 operation you have written, it will execute at the same time. Then it will pass it to the prompt. Prompt will create the entire prompt. Then it will pass to the LLM, and LLM will give me the response. And this response actually I'm converting to the string output. Okay, and here is the input operation we are doing. So this is my question, and this is my language. That means I want this particular response to be in a pirate English format. Okay, now see if I execute the program, you'll see that it will give me the answer in a pirate English format. See, Harem Eti DSwithBappy is a scaling, but blah blah. You can read it out. Okay, so this is called actually pirate is English. So now you can give anything, Spanish, Hindi, anything you can give. It will give you the same output. Okay, now let's see, whenever you are having the multiple input, that time you can use this IM getter, okay, inside runnable parallel. Okay, so these kinds of functionality LangChain also will give you. First thing I'm going to discuss, built-in functions in Runnable. Okay, built-in functions inside Runnable. Then second, I'll be discussing about how we can combine. Okay, combining chains. Okay, like we'll be creating chains inside a chains. Okay, multiple chains actually we'll be using. Then at the last, I'll show you one basic RAG demo. Okay, RAG demo. I think you already created the RAG. Okay, RAG, let's say example with the help of LCEL. I think remember whenever we started with the RAG, that time I showed you, right? Now I think again I will show you this demo and it would be clear now. Okay, the syntax actually I was using that time. Now it would be clear. Okay, how we can create the RAG with the help of LCEL. That means LangChain expression language. Okay, so this is the complete agenda. So what I can do, I can close it and let's create another notebook here. So here I can name it as 08 LCEL. Okay, LCEL little more. I can just write like that. IPYNB. So I'll select my kernel. Now the first thing, I'll be loading my OpenAI API key. So let me load. You can also use your Grok model. Now let's initialize my chat model. Okay. Now, if I want to create a basic chain, guys, with the help of LCEL, guys, how to create? I think you remember. So first of all, let's import str output parser, then chat prompt template. Then let's create the prompt template as well as the output parser. Okay. So this is the prompt template we have created. You can see, tell me a curious fact about soccer player. So you can pass any kinds of soccer player name. Okay. Now let's do the invoke operation. So here I will pass. So first of all, I will create the chain. So you can see chain is equal to prompt, model, and output parser. Okay, sequence, left to right sequence. Then I'm doing the invoke operation, soccer player. I'm giving Ronaldo. Now, so if I execute, it will give me one curious fact about Ronaldo. See, Ronaldo's full name is Cristiano Ronaldo dos Santos Aveiro. Now, if I again execute, it will give me another response. See, okay, because it's a generative model. So every time it will generate new response for you. Got it? Now there is a inbuilt function inside Runnable. Okay, we'll get. So one inbuilt function actually we are having called dot blind. Okay, dot bind. I think sorry, dot bind. BIND dot bind. Okay, so this is the inbuilt function. So what is the use of dot bind? See, I have seen like very less use cases of this dot bind, but sometimes if you need it, you can use them. Okay, now let me show you one example. So here, let me just write. Let me comment so that you can revise later on. You can see, use dot bind to add arguments to a runnable inside LCEL chain. For example, we can add an argument to stop the model response when it reaches to the word of Ronaldo. Let's say whenever Ronaldo is coming, that time your execution will stop. That means your response will stop automatically. Okay, so if I want to, let's say, have this kinds of condition, that time I can use this dot bind function. Okay, how? So let me show you one example. So here, what I will do. So the chain, see, I'm going to create like that. Similar chain I have created, guys. You can see prompt, model, okay, then output parser. Now one thing I have added, one inbuilt function, because see, everything is everything is a executable. That means everything is a runnable here. Okay, this is a runnable, this is a runnable, this is a runnable, this is executable, this is executable, this is executable. That means we are performing some certain action. Okay, now inside every runnable you can use this particular actually inbuilt function. So the inbuilt function name is bind. So here I'm applying on top of the model because I want to stop the model whenever it is reaching the condition to the Ronaldo. That means whenever Ronaldo is coming, it will stop the execution. It will stop giving you the response. Okay, So here I'm calling model.bind and stop is equal to Ronaldo. That means whenever Ronaldo is coming, just try to stop the response. Okay, this is what actually I'm telling. Now see if I execute. So first of all, let me do the invoke operation. Now see if I execute. So whenever it will generate the response, whenever Ronaldo will come, it will stop the execution. See, again, let me execute. See, one curious fact about Cristiano. Now whenever Ronaldo was coming, it will stop the execution. Okay, so that's how we can use this .bind function. It's a inbuilt function inside Runnable. Got it? So very simple use case, but I have seen like very less used in the application building. But sometimes if you want, let's say if you want something like that, you can use this particular .bind function. Even LangChain team is also telling there is like very less use of this particular function, but if you need it, you can use them. Okay, we have created for you. This is the idea. So the next thing we'll be learning about combining chain. That means the next topic, this one is done, combining chain. That means how we can create a multiple chain inside the chain. Okay, so we call it as a combined chain inside LCEL. So let me comment here. Okay, combined chain inside LCEL. Now first of all, you can define the chat model. Now first of all, let me create a simple chain. So here you can see I've created a simple chain, the same example. Tell me a sentence about the politician. So here I'm giving the example of the politician. You can give any kinds of example. This is my model. So model I already defined. I can remove here. Yeah. And this is my chain, guys. Prompt, model, and output parser. Okay. Now let me execute. Now see if I do the invoke operation. So let's say I'm giving one politician name. So this is one. So he's the politician. Okay. Politician, you can say British politician. Okay. And Prime Minister of the United Kingdom. So here I'm giving this particular, let's say, input. So now if I execute, it will give me one response of this politician. See, this is the response actually I'm getting. Okay. Now, let's say what I will do, I'll create another prompt. Now I'll be creating the combined prompt. Combined chain. Okay, combined chain. That means we'll be using the previous chain as well as the new chain. So how to do it? So this is the code example. See, output parser we already imported, so I don't need to import. I can remove it. See, so chat prompt template, we are getting another template. You can see was politician positive for the humanity. That means the politician you have asked. Let's say this politician Chamberlain. Okay, Chamberlain. So whatever response actually you are getting, you will be giving it here. You can see the chain actually I have created. Previous chain. So here I'm giving as an input to the politician. That means whatever response I'm giving, I'm getting from my previous chain, I'm giving as an input to my next chain. Okay. And here I'm telling was the politician. That means the response actually I was getting of the politician, it was positive for the humanity or not. Okay. Now the second chain, it will identify, say, first of all, we are giving the first chain, then the historian prompt. That means this prompt, the new prompt I have created. Then again, I'm giving the model. Okay. The model actually I have defined. You can see the model actually I have defined. Okay. Then I'm giving the output parser. Okay, now see if I execute, see what will happen. So here I will give, now I'll give another, let's say, politician name called Lincoln. Okay, Lincoln. Now see if I execute, what will happen? See, yes, Abraham Lincoln is considered positive for the humanity because of his leadership during critical time in American history. Okay, now see how it is working. First of all, it is whenever you are giving the invoke operation, politician is equal to Lincoln. First of all, it will execute this particular chain. Okay. And in this chain, you are creating another chain of the previous chain. You can see the previous chain you have defined. Now it will go to the previous chain. That means the politician. Okay. Politician. You can see. So it will go to the politician. And what is the politician name? What is the politician name? Politician name is Lincoln. So what it will do, it will tell me a sentence about Lincoln. Okay. And it will give you one sentence about the Lincoln. And that sentence actually will be giving to the next prompt. Okay, that means historian prompt. Now it will tell was this Lincoln, okay, positive for the humanity or not. Then this will go to the model. Model will identify was Lincoln is the positive for the humanity or not. And then it will give you the response, and that response actually you are able to see. Okay, that means you are creating chain inside a chain. This is called actually combined chain. Now let me show you another example. So this example will give you the clear-cut idea. See, this is the example I have prepared. See what is happening. First of all, I'm importing some necessary library. I think you already know. Then I'm creating the prompt one. So this is my first prompt template. So what is the country politician is from? That means you will be giving the politician name and it will tell you the country. Okay, country the politician was from. Then the second prompt I'm creating, what is the continent of continent is the country. Okay, the country, that means the country you are getting from the first prompt, you will be giving the input to the second prompt. Okay, in and respond in the language. That means it will, you can also give the language as an input. That means it will give you the response in that specific language. Okay, now this is my chat model we are defining, and then we are creating the first chain. First of all, you can see the prompt one, then the model and the output parser. Okay, then we are creating the second chain. So inside second chain we are defining the first chain. You can see the chain actually we have created, this one, chain one. So here we are giving, okay, then the language, so user will also give the language, then the prompt 2. Okay, the prompt 2 actually you have created, then the output parser. Now whenever you are doing the chain 2 dot invoke operation, so you are giving the politician meter and the language French. Okay, now what will happen? First of all, it will come here, okay, and it will see that it has to execute the previous chain. And what is the previous chain input? So it will take the politician. Okay, it will take the politician. So this politician will go here. So it will return the country that politician actually was from, and it will return. Then the second chain will execute, and inside second chain what you are doing, you are giving the country name. Okay, the country name you are getting, you are giving the country name, and you are asking for the continent in which language, your specific language, which is nothing but French. Okay, now see if I execute this chain, you will see the output. See, this is the output actually we are getting in French. Okay, so that's how we can combine multiple chain, guys. It's not like that we have created 2 chains. You can create 3, 4, 5 and so on. Okay, that's how we can increase the chain complexity if it is required. Now the last example I'm going to show you, this RAG demo. So let's create one basic RAG demo. So here what I will show, I'll first of all write one comment. So LCEL chain at the work in a typical RAG app. So I think I already showed you the RAG app, right? So let me again show you how we can get the RAG. So first of all, let me define my chat model. Okay, now here is the entire demo of my RAG. See, instead of loading any kinds of PDF documents or let's say TXT document, what I'm doing, I'm loading the data from the URL. So you can see, and I already taught you how to load the data from the URL. So LangChain is having different kinds of data loaded. So this is the URL, guys. So from this URL, we are extracting the information. You can see, so this is the topic related LLM powered autonomous agents. Okay, you can see this is the one blog actually they have written. So what I will do, we'll just try to extract all of the information, and on top of that we'll be building one RAG based application. I can see I'm using web based loader. With the help of web based loader, you can extract any kinds of information from the website. So with the help of this web browser based loader, you can load any kinds of URL. Okay, and from that URL you can extract any kinds of information. Now here you can also specify the class. Let's say you only need to extract the page content, post content, okay, and post title and post header. If you see any kinds of, let's say, website, and if you, let's say, open it with the help of this one, view page sources, okay, now inside that you will see different kinds of class. You can see they have written the class. So let me show you. If you understand the HTML actually syntax, you will be able to understand what I'm trying to say. So class is there, I think somewhere. See, class is there. Okay, class is there. Now see, class is header is there, page content is there, sorry, post content is there. Okay, that's why we are having different kinds of class. You can see. So here I'm telling I need the post content, post title, as well as the post header. So these are the information it will extract from the HTML page itself. You can see inside HTML page we are having the content. Okay, we are having the content. And if you're using LangChain, you don't need to worry about it. It will automatically find and it will extract everything for you. Okay, this is the advantage you will be getting. So after loading the documents, we are you can see we are loading. Then we are performing that chunking operation. Why chunking operation? Because of the input. Okay, input limit of our LLM. So here is the chunk size and here is the chunk overlap. Then we are getting the you can see chunk. Then we are using Chroma DB vector database and we are storing the vector. We are converting all the text into the vector and we are storing inside Chroma DB. Then we are getting the retriever. Okay, and I need a prompt. Okay, either you can write a manual prompt. The way actually we have created the prompt here, I think, remember, that's how we can create a prompt. Either you can download any kinds of prompt from the hub. Okay, prompt hub. So here you can see LangChain is also having the hub. Let me show you. So you can copy this syntax and you can simply search here. So see LangChain, example LangChain. So guys, you can see this is the prompt. Okay, this is the prompt, and if you want to get this prompt, so you have to use this syntax. So LangChain import hub and hub.pull LM rag prompt. Okay, and if you execute it, it will give you this particular prompt. Okay, this prompt it will give you. So this is what actually we are doing. Instead of manually writing, we are downloading from the hub itself. So inside hub, you are having different kinds of prompt. Okay, this is another way you can define the prompt. Then I think you already know what is the function about. That means whatever response you will be getting, you'll be only extracting the page content. You can see we are passing this particular function here, and this is my rag chain we are getting. So curly bracket is nothing but it's a parallel. Okay, parallel runnable. I think you remember. So we already taught you na. So runnable parallel. So instead of using the function, we are using the curly bracket, and inside that we are like passing the context. That means the retriever, format documents. Okay, then question, the runnable pass through. That means whatever question user will give, and these are the three runnable will execute at the same time, because we are executing inside the parallel runnable. Okay, this is the idea. Okay, then the prompt, then model, and the output parser. And this is the very common syntax, guys. Okay, this is the very common syntax if you are implementing any kinds of application with the help of second generation of the LangChain. Everywhere you will see this syntax. Now I think you will be able to understand. Okay, if you see any kinds of project, okay, of the LangChain second generation, you will see this particular syntax. Now you won't be having any kinds of doubt. Now simply I can give one prompt here. So what is the task decomposition? You will see that inside the content actually we have loaded. So there they have also mentioned task decomposition. Okay, inside this block actually. This block. Okay, task decomposition. So this is what actually we are asking, and this is the response I got. So guys, now we'll be starting with the LangChain ecosystem. So I already told you LangChain created its own ecosystem. That so LangChain is having three ecosystem framework. One is the like LangSmith, LangGraph, and this LangServe. Okay, so all of them will be exploring. I'll show you the demo. Okay, how we can use these are the framework, and with the help of these are the framework. Okay, what we can implement and all, each and everything I'll try to discuss about. First of all, let's try to see what is ecosystem exactly. Okay, inside LangChain, I'll give you the overview of it. Then we'll start with the practical demo. So see guys, as of now we have learned about the LangChain. I think you know that the complete LangChain. Okay, LangChain. So inside LangChain, I think we had so many functionality, yes or no? Like we can load our custom data, we can create a chains, we can let's say customize the output from the LLM, we can connect with different kinds of LLM, we can add the memory, right? So many things we can perform. Now in the second generation of LangChain, okay, second generation, that means the latest one. Okay, so what they did actually, they introduced something called LangChain ecosystem. Okay, what is this ecosystem? So inside ecosystem, they introduced something called LangSmith, then LangServe, and there is another one called LangGraph. Okay, now you can ask me what is this exactly? What is LangSmith, what is LangServe, and what is LangGraph? So LangSmith is nothing but it's a LLM ops tool. Okay, LLM ops tool. So this LangSmith is built on top of this LangChain only. That means they're using LangChain language only, but they have created one separate package. Okay, this is developed by LangChain team only. So they use the core LangChain concept and they introduce something called LangSmith, and this is one of the LLM ops tool. And now you can ask me what we can perform with the help of LangSmith. So usually we perform monitoring operation. Okay, monitoring. Let's say if you have created any application and if you want to monitor that, it can be also use evaluation monitoring as well. Okay, evaluation of your LangChain LLM app. Okay, so in this case actually you can use this LangSmith. So not to worry, I'll show you some demo how we can monitor, how we can evaluate. Okay, so this thing we'll be also discussing about, but as of now try to remember the ecosystem they have introduced, LangSmith. So this is a LLM ops tool, and with the help of that we can monitor our LLM application. Okay, so it's not like that we have built our application and we are running in the production. So sometimes you also need to monitor that whether it's working fine or not, whether let's say whatever response it is giving, it is relevant or not, whether there is any hallucination problem or not. Okay, so these are the thing we can easily get that with the help of LangSmith. Then the second thing you can see, which is nothing but LangServe. So LangServe will be using for the deployment. Okay, deployment for LLM application. That means with the help of LangServe you can actually propose an API. Okay, you can create an API of your application. That means it uses actually something called fast API in the backend. So have you heard about fast API, guys? Fast API. So fast API is a Python framework. With the help of that you can create an API. You can create a web application, okay, without writing any kinds of HTML CSS code. You can use the fast API. So fast API is a production ready actually one of the framework if you want to create, let's say, API endpoints. So that time actually we can use it. So see, previously we used to use the fast API. We used to write the manual code for this, but currently LangChain, what they did, they created another package on top of this LangChain only. Then named it as LangServe. Okay, so with the help of LangChain we can create this kinds of API, okay, so that we can deploy our application easily, okay, and a user can test. Let's say you have created a POC and you want to deploy this application. You want to create an endpoint and you want to share with your manager, or let's say some of the certain person, so that they can test your application. That time you can use this particular LangServe. So this is again another LLM ops tool they created. Okay, now there is another one called LangGraph. LangGraph is for the agents, okay, agents and multi-agents. So very interesting application nowadays, agents and multi-agents. Have you heard of this name, guys? Agents and multi-agents. So with the help of LangGraph, what we can create a agents. Okay, we can create agents. And what is agents, I'll be discussing about. I'll give you one real-time demo. There will be creating an agents. Okay, so inside agents actually we try to create connect third-party tools. So we'll be connecting different third-party tools. See, previously maybe if you have used ChatGPT, so if you're, let's say, asking anything related actually very latest question which is not available in the let's say GPT model, the data actually they didn't use during training. So that time this application will tell you, I'm not familiar with this particular, let's say, question because I trained with let's say till this year, but what the question you are asking, this is the latest question. But nowadays if you see the ChatGPT, if you're asking anything in today's, let's say, latest news also, it will be able to give you the answer. Let me show you how it is fetching the information. Let's say I will ask one question. Tell me about current Olympic, okay, 2024. See, I'm asking actually one very latest question. Okay, latest question. See, latest question I'm giving. Now see, if I send this question to my ChatGPT, now here you will see that see, it is searching to the web. Okay, now after searching, this is the response it got. That means it is real time searching for that particular question, the question I have asked in different platform. You can see it is referring Wikipedia. Okay, so this is referring Wikipedia as well as, see, some sources they have also given. So man of the many, so this is another website. Olympics also it is referring. Olympics also is another website, you can see. Okay, so this is the website. Then they are also referring something called Sky News, then AI, Jazeera, NBC, Olympic, BBC. Okay, see, these are the different website they are referring. Okay, different website information they are referring in real time. So this is called actually agents. Okay, agents and tool. That means you are connecting some third-party tools. Okay, you are connecting some third-party tools so that if you're asking anything which is not available inside your model, it will be able to fetch real time, okay, from different sources. So this is called actually agents. Got it? Now how to build this particular agent? Say previously when we didn't have this kinds of, let's say, framework, LangGraph and all, so we used to manually create these are the things, okay, with the help of LangChain. For this we used to write so many codes, but nowadays they created one amazing framework called LangGraph. So with the help of that you can easily create these kinds of agents. Okay, agents and multi-agents. Multi-agents means you will be creating multiple agents and it can interact with each other. Okay, so we'll be also learning this one. So apart from that, there is another tool you will be getting in the market called Crew AI. Okay, Crew AI. So Crew AI is one of the amazing tool you can use for creating the agents and multi-agents. Okay, So this is like more easy to understand, okay, more easy to implement, because this is a high level framework on top of the LangChain, okay, right? So I think you know about the TensorFlow and Keras, right? So if you're using code TensorFlow, it would be a little bit difficult for you to write the code because TensorFlow is a little bit low level language. But if you use the Keras would be easy for you because Keras is using TensorFlow only, but on top of that, they have created one high level framework, okay? They have created a wrapper. So similar things. So you have the LangGraph, that means it is based on the LangChain. Then what they did, they used the LangChain only, but they created one high level framework, okay, on top of it. This is called Crew AI. So it is like more easy to use. So these are some ecosystem, okay, these are some ecosystem LangChain has created. If you can also search here LangChain ecosystem. So integration with LangServe. So there is a code demo of the LangServe. No need to worry, I'll also show you the demo how we can use this particular LangServe. Apart from that, they have also LangSmith, okay, see, this is the LangSmith as well. So you can go to the documentation, simply you can search here. Let's say you want to find this LangGraph, so simply search here LangGraph with LangChain. See, LangGraph is also there. You can see different, let's say you can do it with the help of Python code, TypeScript, okay, so all the language it is supported. So see, there are some examples. See, you can use some third-party API to connect. Okay, I'll tell you whenever we'll be showing you the demo. That time I'll tell you. So you can use some API provider, and with the help of that, you can connect with different sources, and you can fetch the real-time information. It is also possible. So this is called actually the LangChain ecosystem. So this was not available in our legacy LangChain. Okay. So guys, now we'll see the LangServe demo, like how LangServe works, and with the help of LangServe actually what we can perform. So this is one amazing ecosystem actually LangChain has developed. So let's see the practical demo of LangServe. I think then it would be clear. So first of all, you have to understand what is LangServe. Okay, what is LangServe exactly and why it is required. See, LangServe is nothing but it's a LangChain. It's a LangChain ecosystem. Okay, ecosystem. You can also call it as like LLM ops. Okay, LLM ops framework or tool. Okay, so with the help of this, what we perform, guys, we build simple LLM apps. Okay, apps. You can also call it as web app. You can also call it as API. Okay, application programming interface, so that user can test my application. Let's say you have created one application. So let's say you have used one large language model, LLM. With that, what you have done, you have created one RAG application. I think you know what is RAG application, right? You created a RAG application. Now this application you have created in your local machine. That means it is running on your local machine. Okay, only you can access this particular, let's say like application. You can test this application. But let's say you want to share with some specific person. Let's say you want to share with your manager, or let's say your stakeholder, or let's say your client. That time, let's say your client want to see how this particular application is working, whether everything is fine or not. He just want to test it. Like he's telling, I want to test that application. If everything is working fine, if I'm liking this particular, let's say, project, then we'll be pushing this project to the production. Okay, so before pushing it to the production, first of all, you have to test. And for testing, you have to share this application with some of the person. So how to do it? Okay, for this you will be using something called this LangServe. Okay, LangServe. So when we didn't have the LangServe, guys, what we used to use, I think you remember, we used to use a Flask to create the API or web interface. We used to use something called Streamlit. Okay, then we used to use something called Fast API. Okay, Fast API. So that's how actually we are having different kinds of web framework. Okay, with the help of that, you can easily create a API. Okay, or web app. Okay, easily you can create a web app or API, and this web app you can simply deploy and you can share with your, let's say, client or stakeholder, or let's say to your manager, and they can test your application. Okay, it's working fine or not. But if I'm using these are the tools, then I should have knowledge on these are the tools. Let's say if you want to use Flask, so definitely you should have knowledge on the Flask. That means you have to learn the basics of Flask, like how to create the API, how to create the web app and all, right? And again, if you're using Flask, you have to also learn how to write the HTML code. Okay, HTML code, how to write the CSS code. With the help of that, you'll be creating the template. If I'm talking about Streamlit, again, it's a Python package. Here you don't need the HTML and CSS code, but again, you have to learn some basic syntax. Okay. If I'm talking about Fast API is the production ready actually web framework, or let's say API framework. So with the help of that, you can create a production grade API, production grade actually application. But again, you have to learn the Fast API, because if you see the Fast API, okay, if I open this Fast API documentation, you'll see that it's a like huge package actually. It's a production grade package actually developed, and inside that we are having so many concepts. But again, see, I don't recommend you have to learn all of them, because you as a generative AI developer, your task is to create the application. Okay, your task is to create use the model. You have to create the application. And when it comes to create the web interface, that means user interface, let's say if I'm talking about ChatGPT, it's a full stack development, yes or no, because they're using let's say React, they're using Node.js. Okay, with the help of that, they are creating the beautiful web interface. They're creating interactive web interface. But as a generative AI developer, this is not my task. There would be other team, they will be creating this particular web application. But in the backend, okay, in the backend, the mechanism actually, let's say it is using, that means the core generative AI concept it is using, this is your responsibility to create. Okay, but initially, whenever you are creating your application, now you have to create some basics API, so that at least you can test this particular application, or your manager or your client, let's say, test this particular application. Okay, for this we can use these are the framework like Flask, Streamlit, Fast API. But again, I should have knowledge on this one. But let's say you don't have the knowledge, then that time what you have to do, again, you have to take the help from the web developer, or let's say a front-end developer, yes or no. So that's why LangChain, what they did is they introduced something called LangServe. LangChain, they introduced LangServe, and this is an ecosystem. Okay, LangServe. And what is LangServe? You can go to the simply LangChain documentation. LangServe docs. You can see the LangServe documentation. So LangServe helps developer deploy LLM, LangChain, Runnables, and chains as a REST API. That means with the help of that, you can create a API, or you can create an application, and this application you can deploy. Okay, you can easily deploy, okay, as a REST API. I think you know what is REST API. That means you will be getting one API interface. With the help of that, you can send the request. Okay, not only that, you will be also getting some web interface, because they have integrated web interface as also. Let's say you will be getting the input box and all. That is also possible here. So you can see this, the entire documentation, like how we can use this and all. So in which port and which route you have to go, everything they have given. Okay, but again, I told you LangChain documentation is a little bit hard to understand. So what I will do, I will first of all show you like how we can use this particular, let's say, LangServe in our project. Then you can go through the documentation. Each and everything would be clear, because you can see they have given so many examples. Okay, and I know that initially it would be a little bit hard for you to understand, okay, what they are writing and all. But first of all, let me show you my implementation. Okay, then you can go through the entire documentation, and I will recommend, guys, please try to go through the documentation. Unless and until you are not going through the documentation, so you won't be able to get the in-depth idea. Okay, I'll show the demo how we can use this LangServe. But if you want to learn more about the LangServe, you can go to the documentation. Okay, that should be my suggestion, all of you. So now let me show you the demo how we can actually use this LangServe in our implementation, and how we can create the REST API. Okay, so I'll show you. And one more thing I want to tell you, see, this LangServe they have created, in the backend they're using Fast API only. Okay, they're using Fast API only. So it is the high level of the Fast API. Okay, if you go through the Fast API documentation, you'll see that to use the Fast API, you have to write so many code, right? So many configuration you have to do. But if you're using LangServe, you don't need to do it. Based on the Fast API, actually, they created this LangServe. Okay, LangServe, this tool. Now, let me show you how we can use this one. So for this, I'm going to open up my VS Code. So here I'm going to if you're using actually LangServe, instead of running from your Jupyter notebook, you can create a Python file. That would be better, because Jupyter notebook we won't be using whenever we are developing the application. Okay, so whenever we are experimenting the things, that time we'll be using, but whenever we are creating any application, that time we'll be using the Python file. So let's me create a Python file here. So I'll name it as 10. I can name it as, let's say, LangServe. Okay, LangServe underscore demo dot py. So the first thing, you have to install the LangServe. Okay, in the requirements, you have to mention the LangServe. So let me mention it. So here is the LangServe package, because LangChain actually created this framework separately. So you have to install it separately. Okay, so you can see I'm installing this LangServe 0.2.2. Okay, you can also use any other version, but I'm using this version because this is the stable version I'm using. Now I have to set up it. So to set up it, guys, what you have to do, just open up your terminal in your directory. So let's say this is my directory. I'll open up my terminal, and I think you remember we created a virtual environment. So inside this readme, I shared the command. So this is my environment I created. You can activate, and simply you can run this requirement.txt command. Okay, so it will install this LangServe in your actually environment. So for me, I already installed, so that's why I'm not going to install it again. Okay, now here simply I'm going to create a simple app. Okay, simple actually translator app. So let me just write here. I'm going to implement what? Simple translator app. Okay, translator app. Okay, so what this app will do, it will take actually two input. One is the, let's say, language you want to translate. Okay, other one is the text you want to translate. Okay, so these two input this application will be taking. So let me just come here. So for this, I think you know how to actually initialize the large language model and all, because I already taught you in my previous session. So first of all, let me import all of the necessary package I need. So I think you are already familiar with these are the package, guys. Okay, so chat prompt template, str output parser, chat OpenAI. Okay, then python.env, because I have to load my OpenAI API key. So let me select my environment. So this is my environment, LLM app. Okay, this one. Apart from that, I also need something called operating system. Then I'm going to load my OpenAI API key. So let me load. So this will load your OpenAI API key. Okay, then I'm going to initialize the OpenAI model. You can also use Grok API. If you don't have the OpenAI account, that time you can use Grok API. So this is my LLM wrapper. Then I'm going to also create the output parser, and I think you know what is output parser. Okay, we can reformat the output. Then I'm going to create a prompt. So first of all, I'm going to create a system prompt template. So this is the system prompt template, and here I'm giving the system prompt, translate the following into this specific language. The language actually user will give. Let's say user want to translate in the Hindi, Bengali, Spanish. Okay, that time user will give the input and it will come here. It will create the complete prompt. Okay, now I have to create the prompt template. I think you know how to create the prompt template. So this is the syntax. So chat prompt template from message. Inside that, give the system prompt, and whatever user input will provide, okay, will pass in the text variable. This is the idea. Now we'll be creating the chain. So here we are using LangChain expression language to create the chain. You can see prompt template, then LLM, then output parser, sequence of execution. And to create the actually REST API with the help of LangServe, you have to import first of all fast API. Okay, you have to first of all import fast API, and you have to import another library from the LangServe called add routes. Okay, these two things you have to import, guys. Try to remember these two things you have to remember. And inside fast API object, you have to mention these are the syntax. See, so we have already imported fast API. Inside that, I'm passing the title. Title is simple translator. You can give anything. You can also give any kinds of version. I have given 1.0. And this is the description I have given. A simple API server using LangChain's runnable interfaces. Okay, now we have imported another library called add routes. Okay, inside that we have to pass this object. See, so app routes, I'm passing my app, then whatever chain actually I have created, and the path. Okay, path should be the chain /chain. Why /chain? I'll tell you. Whenever I'll execute the application, you'll see that I have to go to the /chain. Okay, /chain actually route, and this route actually it will execute. And I also need to initialize the application. For this I need this package actually called uvcon, and with the help of uvcon we'll be starting the application. See, that's it. So uvcon run, give the app, give the localhost port number, anything you can give. I've given 8000 port number. This is this is what you have to write. Okay, now see, if you go to the fast API documentation, you have to write so many code, but here we haven't written so many code. We are only using LangServe. Okay, with the help of that, easily we are creating the REST API. Now how to execute, guys? So for this, just open up your terminal. Okay, open up your terminal. Just a minute. And you have to execute this file. Okay, so you have to execute this demo file you have created. So let me execute Python 10 LangServe demo.py. Now see, if I execute, so it will see automatically it will install initialize LangServe. You can see LangServe would be there. Now this application is running on your localhost port number 8000. Now see, if I open this localhost port number 8000, you will see there is nothing. Okay, so for this you have to go to chain route. So chain, okay, chain /playground. This is the route, guys. Chain /playground. Okay, if you go to this route, you will see the application interface, and this is the REST API, guys, we have created. Now let me zoom. See, this is the interface, and by default LangServe has created this interface. Okay, so you don't need to write HTML and CSS code for this. Now you can see we are having two input. One is the language, another is the text. The input actually have written here, I think, remember. So I need two input. One is the text, another is the language. Okay, these two input automatically it is coming. Okay, now here you can test this application. Let's say I will give language, let's say I want to translate in Hindi. Okay, and text, let's say I will give my name is Bappy. Okay, or anything you can give. Now simply you can start the translation. Now see, mera naam Bappy hai. Okay, now again you can give the prompt. Another prompt you can give, let's say here I can give tell me about Python. See, so amazing response actually we are getting. See, okay, amazing response we are getting. Now if you want to, let's say, hit this particular REST API, so for this you can also execute this code. So here Python SDK code I'll copy, and I'm going to create another file called test.py. Okay, inside that I'm going to paste it. See, this is the code. Okay, this is the code. Now here simply you have to give the message. Let's say you want to perform the invoke operation. So here you can write this thing. So inside this invoke you can give the input text. Let's say this is my input text. Language is Spanish, and text is equal to generative AI is the bigger opportunity than internet. So this thing I want to send the request. So I can execute. First of all, I'll be taking another terminal here. Just a minute. So my previous terminal is running, and now I'm taking a new terminal here. So first of all, let me activate my environment. Okay, then I will execute this test.py. So Python test.py. Okay, I'm not getting any output because okay, chain.invoke we are doing. So we have to first of all save inside a variable, and this variable we have to print. Now let me try. See the response we are getting. Now let's say this is your server. Okay, this is your development server. That means the demo server, POC server. You are running your application, and your manager, or let's say your client, are testing your application. Okay, how it is working. Either they can test with the help of web interface. Okay, either they can test with the help of web interface. Either they can use this particular code. Okay, the syntax I shared with you, Python SDK. Okay, with the help of API request also they can test your application. So this is called actually LangServe. Okay, so during development environment, you'll be using this particular tool. Okay, just to test your application whether it's working fine or not. Now let's say everything is working fine. It is ready for the production. That time your front-end developer will come and they will create one beautiful interface and they will connect your application, and this application would be available in the production server like the ChatGPT. Okay, I hope it is clear. So this is the simple demo of the LangServe. Now simply you can go to the documentation. Okay, the entire LangServe documentation. Now you'll be able to understand, okay, whatever things I showed you. So simply go to the documentation, guys, and please try to practice at least, okay, whatever they have given. And if you face any issue, you can let me know in the comment. I'll happy to help you. Guys, we'll be learning about this LangGraph right now. Like LangChain has developed this LangGraph, and this is another ecosystem. So with the help of LangGraph, actually we can create actually agents and multi-agents. So in this example, I will show you how we can develop actually basic agents, okay, with the help of LangGraph. In future also we'll be learning the advanced like multi-agents implementation as well. So let's see the demo of this LangGraph, how it can be used. So LangGraph is nothing but it's a actually framework created by LangChain, and we can use this LangGraph actually to build agents inside Generative AI. Okay, so there are some actually, let's say, application type inside Generative AI. So from them actually one of the application you will be hearing a lot called agents. Okay, agents. So see, agents is not a separate application. So agents is just a kinds of actually tools. So whenever you are building any kinds of GenAI application, let's say you are implementing one chatbot, and this chatbot, let's say to implement the chatbot, you will be using one large language model, yes or no. So with the help of LLM, you'll be creating the chatbot. So here user will give the query and user will get the response. Okay, so this is the query and this is the response I'm getting. But I think you already know, I already discussed. Okay, so see, the model actually you are using, this is actually pre-trained model, yes or no. This is pre-trained model. Okay, what is pre-trained model? Pre-trained model means this model has been trained with some specific data. So if I'm talking about ChatGPT, okay, ChatGPT, so I think you know in the backend of ChatGPT they're using GPT model. Okay, GPT model, GPT 3, 4. Okay, these are the model actually they're using. Now if you search over the Google, and if you just find it like till which year actually GPT got trained, so you'll see that I think till 2023. Okay, till 2023 October, I think, if I'm not wrong, October or November, I'm not sure. So they took the data and they trained this particular GPT model. Now if I'm asking something, after 2023 October, so let's say I'm asking tell me about 2024 Olympic. Okay, Olympic. So now tell me, will it able to give me the answer? If I'm using the model only, let's say I'm using the GPT model, okay, from the OpenAI API, definitely it won't be able to give me the answer. Okay, it will tell actually I don't know, I don't have the enough information. But if I'm going to the ChatGPT, so let me show you. So if I'm going to the ChatGPT, and now let's say if I am asking something which is actually related latest news, ChatGPT will give me that response. Okay, how? I'll tell you. So let's say here I'm asking, tell me about 2024 Olympic. So let's say this is the question I'm asking. Now see, I want to show you one thing actually. Just a minute. Let me take a new chat. Latest news of 2024 Olympics. Okay. Now see, it is searching. Okay, it is searching over the internet. Can you see? It is searching. Okay, see, search 3 sites. If I can open it, see, I can show you. So these 3 websites actually it has searched. Okay, real time it has searched and it has extract the information. Okay, so this is called actually agents. So they have integrated the agents functionality with the chat GPT. But previously, if you are using the chat GPT from like, let's say very older days, I think you already know. In our previous chat GPT, if we are asking anything which is relevant to the latest news, so chat GPT used to reply like that, I don't have the sufficient information about that. Okay, so please try to ask me till this year. But nowadays, if you see, chat GPT got updated. Okay, so they have actually made this application very powerful. So if you're asking something which is not available in the knowledge base of the model, it will able to take the latest information from different website. Okay, and this is called actually agents. Okay, agents. Now we can create 2 kinds of agents. We can use the simple agents. We can also create the multi agents. Okay, going forward, we'll be also discussing about multi agents, how we can create the multi agents and all, like how one agents can interact with any other agents. We'll be discussing about. But as of now, we'll be learning how we can create a simple agents with the help of LangGraph. Now, previously, when people used to create the agents, right? When people used to create the agents, actually they used to use LangChain only. Okay, LangChain, the legacy LangChain they used to use. But for this, actually, they had to write like too much line of code, and they had to also integrate with different actually third-party framework. But nowadays, you don't need to do like that. LangChain has created one amazing framework called LangGraph. Okay, LangGraph. So LangChain team has developed this LangGraph, and they are telling if you want to create a agents, okay, if you want to create a agents, okay, or if you want to create a multi agents, we don't have any issue. Okay, you can use our framework. Okay, now whatever tools and technology you need to create the agents and multi agents, everything's are available inside this LangGraph framework. Okay, now there is another alternative in the market right now, which is called CrewAI. Okay, CrewAI. So CrewAI has been also built on top of the LangChain only. Okay, in the backend they're using LangChain only, but they have created one high level framework. Okay, I think you know about TensorFlow and let's say Keras. So Keras, so TensorFlow is a low level actually framework, and Keras is the high level framework. Okay, Keras is more easy to understand than TensorFlow. Then what TensorFlow did, they integrated this Keras, okay, in their framework only. So similar wise, if you're using LangGraph, so it would be actually a little bit actually complex based on the coding. So whenever you are doing the coding and all, you'll feel like it is a little bit complex. And whenever you are using CrewAI, it would be very easy for you because it is a high level framework they have created. Let's say you are implementing one agents application. So with the help of LangGraph, you are implementing. So let's say you are writing 100 line of code with the help of LangGraph. But if I'm talking about CrewAI, so here you can implement this project with the help of 30 line of code. Okay, so that much actually easy it is. So first of all, we'll be exploring the LangGraph. Then in future also, I'll also show you how we can also use CrewAI to implement agents kinds of application. Okay. Okay, so now let me show you some of the point actually you have to remember whenever you are implementing agents. See, agents is nothing but how actually agent works. So let me show you some of the point. See, these are the point actually you can remember. I think. So the first point you can see uses the language model as a brain. That means whenever you're implementing agents, okay, so to implement the agents, you need to use some tool. Okay, tool. What is tool? You can use some SARS tool. Okay, SARS API. So see, I think I showed you one example, this chat GPT example. Whenever I was searching this, let's say news, latest news of 2024 Olympics. So it was searching, okay, it was searching in a different website, and it got actually 3. Actually you can see website. Okay, from this 3 website it is giving me the answer. So to perform the search operation, they're using some SARS API. Okay, Google Search API. There are actually so many API nowadays. I will tell you one of them. So with the help of that, you can actually search over the Google and you can extract the latest information. So this is called actually tool. So whenever we are implementing agents application, we'll be using tool. Okay, so with the help of tool, we'll be creating the agents. So here in case you can use the SARS API, even you can also use different kinds of tool. Okay, going forward, we'll be also learning actually more advanced tools and technology. But as of now, we'll be using the SARS API only. Got it? So that means it is using the our base LLM only as a brain. That means large language model it will try to utilize. But whenever your user is asking any kinds of question, let's say user is asking latest news of 2024 Olympics. Now your LLM will decide whether it has to use the tools or whether it has to refer the knowledge base. So first of all, whenever you are asking this question, latest news of 2024 Olympics, definitely this latest news, it is not available in the knowledge base of the chat GPT, yes or no. In the GPT model, that time your LLM will automatically decide I have to use the actually agents, I have to use the tool, and I have to search it from the different APIs. Okay, and the information I'll be getting, I'll extract and I'll try to provide to the I'll summarize it and I'll try to provide to the user. Okay, so this is what actually agents work. Okay, that's how actually agent work. That means it will be using the LLM as a brain only. On top of that, it will decide, okay, based on the user prompt, it will decide whether it has to follow the knowledge base or it has to reply, okay, with the help of this tool. Okay, tools. I think it is clear. Now taking action after deciding, the agents then goes ahead and docs those actions. Okay, now learning and adjusting. Once the actions are done, the results can be given back to the language model, and this helps model the checking everything is complete if needs to do something else. That means the response actually you are getting from the different website, it will try to summarize, okay, and if something is required on top of it, it will try to add, okay, it will try to add some more flavor, and this response your user will able to see that. Okay, so this is how your agents work. Okay, I hope it is clear how agents works. And for this we'll be using the LangGraph. Okay, with the help of LangGraph we'll be creating the agents. So in this video I'll show you how we can create a simple agents, okay, with the help of LangGraph. This is our main agenda. Fine. So I think you remember, guys, I started writing coding. So this is my notebook. So I'll open up my VS Code and here I'll create a notebook. So let me create a notebook here. So here I can name it as let's say langgraph.ip mynb. Fine. So let me take some cell and I'll select my cardinal. Fine. So the first thing, guys, what I have to do, I think remember, I have to load my OpenAI API key, because here I'm going to use the OpenAI model. In case you can also use any other model like Grok API, okay, you can use it. It's up to you. So let me open up, load my OpenAI API key. Now the next thing, I'll be loading my LLM. Okay, that means my chat completion model. So in case I'll be using GPT 3 Turbo model. So let me load it. Okay, so model I have also loaded. Now see, the tool actually will be using one Stars API tool. So the name of the tool is Tabili. Okay, so you can see Tabili. So Tabili, one of the actually tool, and it is one of the actually amazing website. It provides a API. With the help of that API you can search over the Google. That means it is kinds of actually Google search engine. So whatever, let's say, search we usually perform in the Google, let's say if I'm searching anything, let's say I will ask the same question. So let's say this is what I'm searching here. Okay, tell me the latest news of Olympic. Okay, now see, Google is searching from the different sources and it is giving me the response. Okay, so that's how Tabili is also a search engine provider. Okay, so here you can ask anything. It will search over the, let's say, internet, and it will give you response. Okay, it is a small kinds of Google search engine you can talk about. Now to use the Tabili, first of all you have to sign up with the account. Okay, how to sign up? So there is a sign up button. Just try to click here and try to create one account. With the help of your Gmail you can create an account. For me, I already have the account, so what I will do, I'll just try to simply log in here. Okay, after login you will see this kinds of window. Okay, this kinds of window you will see. Now Tabili, initially it is a free. Actually in a month, actually I think you can do thousands requests. So here they have written you can perform 1000 requests. Okay, API limit. But if you're building actually massive application, if your let's say application is having lots of traffic and you are doing the frequent search, you can also take the enterprise level subscription. Okay, but as of now we are showing the actually demo. That's why I can use my personal plan. Okay, you can also use the premium subscription of it, but I think 1000 requests I can send. Okay, I can use this particular free account. Okay, it's completely fine. Now here, if you don't have an API key, just try to create an API key, but by default it will provide an API key. So you can copy this API key and you can set it inside your environment variable. Let me show you. I can copy my key and left hand side, you can see I have the env file. Okay, now let me open it up. So guys, here you can add this particular API key. So let me add it. So tably API key is equal to, so here I will copy my API key. So after this actually video, I'll try to delete it. So try to create your own API key, guys. Okay, don't use my API key. So here I'll paste my API key. Got it. Now save it. And yeah, I think everything is fine. Now again, I will re-execute this particular code because it will automatically load the env file and it will load all the environment variable. Okay, now let me load my model as well. Now I think you got it, like how to create the tably actually account and how we can get the API key of the tably. Okay, now the next thing we'll see how we can use this particular tably, okay, to perform these kinds of real-time search operation. Okay, and on top of that we'll be building our agents. So for this, first of all, you have to install some of the library. I think most of the library you already installed. Here you can see everything we have installed. One thing I need to install, which is nothing but LangGraph. Okay, so LangGraph is not available inside LangChain, so separately you have to install this particular LangGraph. Okay, you can see LangGraph I'm installing with this specific version. Okay, so LangChain has created separate framework for the LangGraph. Okay, fine. Now after that, this is the code snippet. You can test the tably search results. Okay, so inside LangChain we already have this tably search, okay, functionality. So it is available inside LangChain community. So we already installed LangChain community. Let me show you. The LangChain community is already there. Okay, so here I'm importing this tably search results from the tools and tably search. Okay, now similar wise, not only tably search, you have different kinds of let's say tool. Okay, you can search over the Google. You will see different kinds of tools are available. Okay, you can also use SARP API. SARP API is one of the, let's say, API provider. With the help of SARP API also you can perform the search operation. Let me show you SARP API. Okay, I think it's a SARP API. Okay, see, this is the SARP API website. Okay, so here also you can create an account and you can also perform the Google search operation and all. Okay, everything you can perform it here. Now here what I will do, see, here I'm creating a search object. So you can see tably search results, and here you have a parameter called maximum results, like how many response you want to get whenever it is searching over the Google or let's say over the search engine, how many response you want to see. Here I have given max result is equal to, that means it will only show 2 results. But whenever I'm talking about ChatGPT, you can see ChatGPT is referring 3 results. Okay, it is referring 3 results. In case you can also give the 3, let's say I want to see three relevant response. So here I can give the 3. Okay, now this is my search. Who are the top starts on the 2024 Eurocup? Okay, let's say this is the latest information I'm asking. Now see, if I'm executing this line of code, so it is searching over the, let's say, Google, and it is extracting the information. Now see, it has referred. These are the website. You can see, I can open the website. See, these are the website it has referred, okay, to give me the response. This is one of the website. This is another website. And this is another website. And why 3? Okay, why 3? Because here I have given, I need a 3 response. Okay, now you can see, this is the URL and this is the content it has extracted. This is the URL, this is the content it has extracted. This is the URL and this content it has extracted. Now you can also see the website. Okay, see, these are the Eurocup 2024 website. Okay, so from there it is extracting the information right now. You can see from there it is extracting the information right now. Okay, but I don't want to create the application like that. I want to create agents actually. So my agents will automatically decide the search, let's say the prompt I'm giving, whether it has to follow the knowledge base or it has to follow the tools. That means it has to use the tools and search over the internet real time. Okay, so for this we'll be implementing the agents. Okay, now to implement the agents, first of all, the tool actually I'm using, this is called actually tably search results. Okay, now you can use also multiple tool. I already told you, you can also create a multi agents. So here we are creating the single agents. That's why inside tool will be only keeping the one tool, okay, called search, the search object we have created. In case you can also use any different tool. Okay, it is also possible. Going, in future I will also show you, okay, how we can create a multi-tool application. Now, if you see the tool, you'll see that it's an object of tably search. Okay. Now, what you can do? Just a minute. Now to create the agents, okay, now we'll be creating the agents. To create the agents, you can use this syntax. So inside LangGraph, okay, inside LangGraph, we have one function called create react agents. Okay, but before that, you have to execute one line of code. I think this is not required because this is the latest version of that syntax. I was going through the documentation, and this is the latest version you can see. So from LangGraph, inside that you are having a pre-built, and you have to import this particular create react agents. Okay, now inside create react agents, you have to pass the LLM. The LLM we have defined our ChatGPT, and the tool actually we are using called search tool. Okay, Tabili search tool. Now this would be my main executor. Okay, this would be my main executor, and see, we are using the LangGraph. Okay, we are using the LangGraph, and inside this function, all the code has been written, like how it will do the search operation. Okay, everything has been written. So this is what actually LangGraph does. Okay, that's how actually LangGraph gives you more flexibility to build these kinds of AI agents. But if you are working with the legacy LangChain, I think you already know. Previously, whenever we used to create these kinds of agents application, we have to write so many line of code. Yes or no, guys? Okay, if you are already used the like older LangChain, I think you already know how hard was actually it is to create a agents application. Okay, we have to use different kinds of framework, different kinds of tools. Okay, with the help of that, we used to create the agents. But now we have these kinds of framework. Okay, it is already inbuilt. That means all the functionality, it is already available. So simply you can use them and you can create a agents application. Okay, now let me create this object. Okay, agents executor object. Now we'll test it whether it is working or not. For this is what actually I have prepared. You can see. So LangChain code message, human message, because human will pass the prompt, and I think you know how to label the human message. With the help of human message, we can label the human message. So this is what actually I'm giving. Where is the soccer Euro Cup 2024 played? Okay, now this is again a latest information, and the response actually I am getting from my, let's say the model. Here I'm extracting the message only. Okay, now let me show you. See, it is searching over the internet and it is extracting the information. Now you can see this is the URL. Okay, this URL it has referred, and this is the actually response I got. Okay, so this is the response I got. That's how your agents work. Okay, now your model is deciding, your large language model is deciding whether I had to use this tool or I have to use my own knowledge base. Okay, now let me show you another example. Let's say here I can ask, what is Python? Okay, let's say this is my question. Can you see there is no real-time URL? Okay, real-time URL, there is no real-time URL. Okay, it is referring the knowledge base only. Okay, it is referring the knowledge base only. That means Python is already available in the knowledge base. You can see the URL it is giving, but this is not actually live URL. That means when they actually train this particular, let's say, model, that time this URL also available in that model. Okay, but this one is the live URL. That means whenever it was doing the execution operation, I think you saw it was taking some time, like your ChatGPT. So when I asked this question in the ChatGPT was also taking some time. Okay, that means it was performing the real search operation, real-time search operation. Okay, similar wise, when I executed this line of code, it was also performing the real-time search operation from this URL. Then it has extracted the I think news, and it is giving me the response. Okay, but in case it is using the knowledge base. Okay, that's how my application will decide whether I have to use my knowledge base or I have to search over the internet. Okay, so that's how we create the agents. Now this is what actually we got the one-shot output. If you want to get the stream output, at that time you can also apply this stream functionality here. So you can see executor stream, because at the end it's an executor only. I think we already learned inside LangChain expression language what is executor, what is executable, okay, what is runnable. So this is actually runnable. Okay, so here we can also perform the stream operation, stream, batch, inbox, everything you can perform here. Again, I'm asking the same question. You can see when and where will be the 2024 Euro Cup final match. Now you can see it is searching real time, and based on that it will give me the answer. Now see, this is the live URL, and it is referring the Wikipedia. Okay, Wikipedia it is referring, and this is what actually I'm getting. Got it? Now if you want to add the memory, let's say I want to add the memory channel so that I can perform the conversation. Okay, so you can also add the memory. So for add the memory, of what I can do, So here I can add it. See, adding memory is very easy. So the previous actually memory functionality we have learned, like buffer memory and all, you can also use them, but there is another memory you can use. It is available in the LangGraph. See, called memory saver. Okay, so you can create an object of memory saver. Now this object you can pass to the executable. Okay, let me show you. So this is what one example. So create React agents, LLM tools, and checkpointer is equal to memory you have to give. Okay. Now here I have given additional actually information. You can see config is equal to config configurable trade ID 001. Okay. Why I'm giving this one? Because see, whenever I'm coming to the chat GPT and whenever I'm creating my user, okay, that means Bappy use the user. So whatever, let's say conversation Bappy is doing, okay, so Bappy is having the history, but let's say there is another user is coming, he is creating the account. So he is not able to actually see my like chat history. So he will be getting a completely new window there. That means inside ChatGPT application, different users are coming and they're creating different kinds of, let's say chat, window. Okay, based on that, they're doing the conversation. So these kinds of functionality you can also add here. So here you can see trade ID I have given 001. That means this is the user one, let's say. Okay, user one. So let me show you one example. I think that would be clear. Now let's say this is one I'm asking. So who won the 2024 soccer Euro Cup? And here is the config I'm passing. Okay. Now let me show you. So this is what actually I got the response. And this is the URL. Okay, tiktok.com. It was referring. Now, here I can ask another question. Who were the top stars of the winner team? Okay, it is telling the SARS doesn't provide specific information. So again, let me execute this line. Okay, now I got, you can see the winner of the 2024 Soccer Euro Cup was Spain. Now I can ask this question. Who were the top stars of the winner team? The SARS result did not provide specific information. This meant Euro Cup team. Let me again execute. Now see, I got some actually winner team name. You can see William. Okay, so different name actually I'm getting. That means it is referring my previous context. Okay, how? Based on the memory. Okay, now let's say there is a user 2. Okay, user 2. Let's say this is my user 2 trade ID 002. Okay, now see this user and this user is completely different. Okay, now see if I'm asking any question about what soccer team we are talking. Okay, now see what is the response actually I'm getting. We are discussing about FC Barcelona, Spain, how I can assist you. I think this is not the relevant. Let me show you. The winner of the soccer team of Spain, Victoria, England, and final. But the response actually I'm getting, this is a completely different. That means you can see this user and this user conversation is completely different. Okay, that means it is not able to refer this particular chat history. But if I'm giving this one 001 trade ID, now I think it can give me the right response. Okay, we are discussing the Spain national soccer team and their victory in 2024 Soccer Euro Cup. Okay, I hope it is clear. That's how if you want to add the memory, okay, you can add like that. Okay, it is also possible. So this is what our LangGraph. Okay, that's how our LangGraph works. And this is the simple agents we have developed. Okay, now we can also implement multi-agents and we can also add actually different kinds of tools. Okay, everything is possible here. So going forward, we'll be also learning about that. Okay, no need to worry. I think now you got it. Okay, how this LangGraph works exactly. Okay, and this is what actually LangChain has created and they are calling it as a ecosystem. Okay, I hope it is clear now. So guys, now we'll start with the LangSmith demo. So this is another ecosystem from the LangChain. So they have created this amazing LLM ops platform. This is called actually LangSmith. So here I'm going to show you how we can build, monitor, and trace our LLM powered application. Okay, with the help of this LangSmith platform. So let's see the practical demo of this LangSmith. So what is LangSmith? So LangSmith is a it's an ecosystem. Okay, it's an ecosystem of LangChain. So LangChain has different ecosystem. I already told you. So LangChain has different ecosystem, like LangServe is there, LangGraph is there. So LangSmith is one of them. Okay, LangSmith. And this is a LLM ops platform. Okay, LLM ops platform they have developed. So with the help of this LangSmith, what we can perform, guys, we can do the monitoring. Okay, we can do the debug. We can do the like tracing. Okay, even you can also perform the evaluation. Okay, evaluation of your application. So this is a little bit advanced one. We'll also try to discuss, okay, how we can perform the evaluation of our application. So in this actually session, I'll be showing you how we can monitor, debug, and tracing our application. Let's say if you are creating any kinds of application, at the end, you also need to integrate these kinds of LLM ops tools so that you can get to know, okay, so what is going on inside your application. You can get the entire experiment there. Okay, let's say many people will ask like how we can trace our cost, like how much it is charging, okay, based on the request I'm sending to the model. So each and everything you can monitor. Okay, so this kinds of functionality LangSmith usually provides. Okay, so LangChain has created one amazing platform called LangSmith. So with the help of that, you can monitor, debug, trace, and evaluation your LLM powered application. Okay, so for this, we'll be using this particular LangSmith platform, and this is called LLM Ops platform. Okay, LangChain has created. Fine. So now what I will show you guys, I think practical demo would be better, because what I believe in practical, unless and until I'm not showing you the practical, things would be more difficult. So first of all, we'll see the practical demo. So I already prepared the code and everything. Okay, I'll just execute and I will show you, okay, how we can configure with the LangSmith and all, and how we can monitor, debug, and trace our application. Okay, so for this, we'll be first of all opening the LangChain website. Okay, so let me just open the LangChain website. So I'll open the LangChain website. So the first thing, you have to create one account in the LangChain website, guys. Okay, so everyone, if you don't have the account, first of all, try to create one account in the LangChain website. So for me, I already have the account. If you don't have the account, guys, just try to sign up with your email address and you will be getting one account. So for me, I already have the account. I'll just try to do the sign up here. See, for me, it will automatically log in. See, okay. So initially, we'll see these kinds of interface, but for me, see, I already created actually one project here. I was tracking one project. That's why you can see this particular project name. But if you're opening for the first time, you'll see that it would be completely empty dashboard. Okay. Now, the first thing what you have to do, guys. So you can see this is the LangSmith platform. Now you can also open up the documentation. I think so. They have also given the documentation link somewhere. So let me open the documentation. See, this is the documentation. So this is the LangSmith documentation. So here they have already written, with the help of LangSmith, it's a platform for building production grade LLM application. It allows you to closely monitor, evaluate your application, so you can ship quickly with the confidence. Use of LangChain is not necessary. LangSmith works on its own. That means you don't need to configure so many things here. Only you just need to set some environment variable and all, and everything will be tracing automatically. Okay. Even they have also given some example like how we can install it. Okay, so if you're using LangChain, so you don't need to install LangSmith separately. Okay, it will be working fine. Now you have to create the API key of the LangSmith. Then after that, you have to set it as an environment variable. And if you're using any other operating system, you can also export it. Okay, and they have also given some of the demo. But again, I told you LangChain documentation is a little bit complex for the beginner. So first of all, see my code example. Okay, whatever application I'm showing you, first of all, try to see, then try to go through the documentation. Okay, even they have already given the tutorial related evaluation, prompt engineering. Okay, even they have also integrated LangGraph like cloud. If you want to, let's say, integrate the LangServe and all, you can also do it. Okay, but as of now, it's not required. We'll be using the LangSmith for the monitoring our application. Okay, this is our main objective. So for these guys, first of all, let's create one API key. And how to create the API key? So for this, open up your dashboard. And left hand side, you will see there is a setting option. Okay, now click on the setting option. Now here you can create the API key. Okay, see, there is an option, create an API key. So if you don't have the API key, guys, just try to create an API key. For me, I already created. Okay, see, you can see for me I already created. So let me, what I can do, I can delete this API key. The API key actually I created, I can delete it. Now I'll be creating a new one. So create API key, you can give the name. Let's say I'll give my key and create it as a personal access token and create the API key. And make sure you copy it and paste it inside your env file. Okay, now see, this is my env file, and here you have to write this particular key name, LangChain API key. Okay, inside that you have to paste this particular key. So let me paste my key. Okay, don't use my key, guys. I'll try to remove it after this session. Okay, just try to create your own API key and try to mention here. Then you have to give another key, which is nothing but LangChain project. That means the experiment actually it will be tracking, right? So it will save as a project. So you have to give the project name. So by default, whatever name actually you'll be providing here, it will use that particular name. So here I will give, let's say, my LLM app. The previous I already created one app called my LLM app. Now what I can do, I can, let's say, change it. So I'll give test. Okay, test app. So I've given this name. You can give any name. Okay, it's up to you. Now let me save, and it's done. Now let's create out. Now what you can do, you can create a Jupyter notebook. So for me, I already created a Jupyter notebook, guys. You can see, and I have already written the code example. Okay, how we can use this particular LangSmith. So again, these are the code snippet. I think you already familiar with. I already explained everything inside LangChain. Okay. So here I'm importing operating system library, then chat OpenAI, because we'll be using the chat completion model. Then chat prompt template, HTR, output parser, okay, then load env. So I think you already familiar with these are the packages. Okay, now let me import them. Now the next thing, you have to load the like secret credential. Okay, you have to load the OpenAI API key, you have to load the LangChain API key. Okay, and you can, in case you can also use any other model, you can use Grok model. Okay, any other model you can use. So here I'm using the OpenAI model. And so if you're using LangSmith, one I mean, things you have to assign, which is nothing but LangChain tracing v2 is equal to true. So if you go to the documentation of LangServe, let me show you. So if I go to the documentation, so they're telling, see here. So this one, LangChain tracking v2 is equal to true. You have to provide this particular statement. Okay. If you're not providing, your execution won't be logged inside LangSmith. Okay. That means it won't be tracing. But if you're giving it as true, it will automatically start tracing your experiment. Okay, so this is super important, guys, and this is what you have to remember in LangSmith. Okay, nothing else. Everything will take care by LangChain only. Got it? Now see here I have mentioned LangChain underscore trace tracking underscore v2 is equal to true. And why v2? Because we are using second generation of LangChain. Okay, second generation of LangChain. That's why we have given the v2 version 2. Got it? Now let me load the environment. Now here I'm creating the chat prompt template. I think you know what is chat prompt template. If I want to give some prompt to my LLM, first of all I have to create the prompt template. So here I'm creating my prompt template, and here I'm using the chat completion model. That's why I have to give the system prompt as well as the user prompt. So this is my system prompt. You are a helpful assistant. Please respond to the user request only based on the given context. Now this is the user. So user, in case actually what user will pass the question, and they can also pass the context. Okay, so context wise they can also pass. So this is my entire prompt template I have created. Now I'm initializing the model. I'm using the GPT 3.5 turbo model and as well as the output parser. Okay, now this is a basic simple chain I'm creating with the help of LCEL, that means LangChain expression language. And I already told you this kinds of ecosystem supports latest LangChain. Okay, the second generation of LangChain. Okay, if you're using the legacy LangChain, in case actually it won't be working. Okay, that's why I already told you have to learn the second generation of LangChain. Now this is my simple chain prompt model and output parser. So first of all, prompt will be created, then it will pass to the model. Model will give me the response, and it will pass to the output parser, and output parser will return the string output. Okay, this is the idea. Now let me create the chain. Now here is my question. So here I'm giving one question: can you summarize this story? And story wise, I've given this particular story. You can see inside the context. So I have copy pasted this story from Google. So if you can search like English story, we'll be getting different story. So here you can paste anything, or if you have any other documents, you can also pass it here. Okay, now this is my question: can you summarize this story or not? Okay, so this is my question. Now here I'm passing it to my actually chain. So chain.invoke question is equal to question I'm giving, and the context is equal to context I'm giving. Okay, now see if I execute it. So here I will get the summary. Okay, this is the entire summary actually I got. Now if you go to the LangSmith, okay, if you go to the LangSmith, And if I go to the, let's say, tracking project, okay, in this section, now you'll see that the latest actually track it would be visible. So this is my previous one. Okay, this is my previous one. You can see the timing. Okay, in this timing, at this time actually I was experimenting this application. Now this is the new one, test app. The name actually I have given inside my environment variable. It is utilizing the same name. Okay, now you can see the created date and everything. It would be visible. Now you can also see some of the like messages like error rate. So are you getting any error or not? Then latency. Okay, like how much actually time it took to execute the application. Okay, so different actually log you can see. Now total token, total cost. See, now you can track you can monitor your cost, like how much it is charging. So here we are using OpenAI model. So the request actually I send. Okay, so based on the request, what is the charge? So see, it is charging $0.0000181. Okay, and this is the date. Now I can also open it up and I can see detailedly, okay, what it's trying to say. Now see, entire log you can see here. Okay, like the run count, like only one time I executed, the total cost. Okay, then token and latency. Okay, everything you can see here. Okay, everything, all the metadata you can visualize here. Okay, in this LangSmith platform. So this is one amazing platform they have created. Now if you want to see in detail, so what you can do, simply you can click here. See, it is logging as a runnable sequence. Okay, now I think you can answer me why runnable sequence, because I already told you whenever we create a change, that means we are executing runnable, yes or no, sequence of runnable. Okay, that's why it is logging as a runnable sequence. Okay, now inside runnable sequence, what we have, guys, we have different kinds of runnable. Okay, like we have our model, we have our prompt. Okay, then we have the output parser, and you can see this is the input. Okay, this is my input and this is the context. Based on that, it has given me this particular answer, output. Okay, if you want to see as a JSON, you can also see. If you want to say as a YAML file, you can also see. Okay, now status is success, that means there was no error. Now you can see the feedback. So if any feedback is required, it will automatically give you the feedback. It will also show you the metadata, like what is the version and everything you are using. Okay, so everything it will show you. Everything it will show you. That means each and everything you can monitor here of your application. Okay, so this is one of the amazing product actually LangChain team has developed. Even personally, I prefer a lot. So it will give you the entire clear-cut idea about your application, like the cost, everything. Okay, everything. Even you can also evaluate your application. Okay, so I think future will also show that how we can evaluate our application. Now see, apart from that, I think some more functionality are there. So let me open it up. So what I can do, I can show you the monitor section. So inside monitor section, it will show you the graph based on the, let's say, hour and day basis. So I just executed my project as of now, that's why there is nothing. But after 1 year or after 9 days, okay, or 1 day, you will see it will show you the different graph, like volume, latency, tokens, cost. Okay, streaming, everything it will show you. Now setup wise, if you want to set up it, so they are also giving the tutorial, but I don't need it. I already set up this project. Now I'll go to the run section. I'll click on the all runs. And inside all runs, you'll see whatever runnables you had, everything it will show you. Let's say, so I had different runnables, get, remember. So prompt was there, model was there, output parser was there. Okay, so you can see output parser, our model. Okay, then our prompt. Okay, now this is the sequence runnable, that means the entire runnable. Now you can also open them individually. Let's say I want to see the output parser only. In case, I can open it up and I can see, okay, what output parser is doing. It is giving me the string as an output. Okay, that's how we can see the model size, model as well. So what is the model you are using? Okay, the model input, model output, everything it is visible. Okay, and the token, the cost, okay, everything it will show you. So with the help of this LangSmith, we can do some more advanced stuff. Maybe in future I will also show you, but as of now, that's how you can monitor your entire application. Okay, in MLOps, if you have used something called ML flow, anyone, so I think you can relate, okay, ML flow with this LangSmith, because in ML flow also we can track our experiment. Okay, so inside this LangSmith also we can track our experiment. Let's say you are executing for the next time, second time. So what I can do, let's say I can change this question. So here I can write, can you summarize this story? Instead of that, I can just write, what is this story all about? Okay, all about. Now if I again execute, Okay, now see, if I go to the LangSmith again, and if I just click here, test tab, now see the second execution, okay, the second log, just 1.92 seconds ago. Okay, sorry, it's a latency, but you can see the time as well. So I can show you the time. I think time, you see, you can see the time. Okay, got it. So you can see this is the next experiment. Now if I open it up, so you can see this is the question, and this was my actually context, and this is my response. Okay, so that's how we can track a different experiment, okay, with different actually, let's say, runnables, different actually input output. Okay, everything you can trace. So this is why important. I think whenever you are creating production grade application, so you should also integrate this kinds of functionality. And to integrate it, so you only just need to add this particular syntax. Okay, that's it, and everything would be automated in the platform itself. I hope now you are clear with this LangSmith. Okay, how LangSmith works. So guys, to implement this project, I need some requirements. Okay, I need some requirements. So here we'll be using LangChain to implement the entire, let's say, project. And why LangChain, I think you know, because LangChain having all the functionality, right? Let's say you want to integrate vector database, you want to integrate large language model. Okay, everything is available here. So that's why we'll be using the complete LangChain here. And large language model wise, we'll be using OpenAI model. OpenAI will be using GPT 3.5. Okay, this model actually will be using. Going forward, we'll be also learning how we can use open source large language model. With the help of that, I will also show you how we can create the application. Now, third, I need vector database, vector DB. So here we'll be using FIAS. Okay, so FIAS is another actually vector database. I think I haven't covered in my vector database series. So that's why I thought let's also show you this FIAS in this video, so that you will be also learning about FIAS. So FIAS has implemented by Facebook AI, and this is one of the vector database. This is the local vector database, actually local vector database. So you have to set up everything in local machine. Going forward, we'll be also using Pinecone Web 8. Okay, no need to worry. Then to implement the entire, let's say, front-end part of our application, that means we'll be creating the user interface with the help of Fast API. Fast API. I think you know what is Fast API. Fast API is a Python framework. With the help of Fast API, we can create a user interface web application. Apart from Fast API, we're having, let's say, Streamlit, Flask, Django, okay, Falcon. So these are the things you can also use. We'll be exploring one by one all of them. I think we saw the Flask previously. I think remember Flask. I think I showed you. We created some of the application with the help of OpenAI. We'll be also using Streamlit. Streamlit is very easy. If you are using Streamlit, you don't need to write any kinds of HTML and CSS code. So guys, yes, as of now, these are the requirements are needed. If I need it later on, I'll tell you. Okay, now let me show you the project diagram. Okay, the project, let's say, structure. That means the high level architecture. So here, first of all, user will, let me just draw it here. First of all, user will upload one PDF documents. Okay, let's say this is the PDF documents. So what I have to do, I have to extract the data. Extract docs. So why I have written docs? Because I think you already know, if I am using LangChain and if I'm, let's say, extracting any kinds of data from any kinds of PDF or any kinds of, let's say, file format, it would be considered as a documents. I think I already covered multiple times, like LangChain data loader. Even I also showed you inside vector database session. So guys, vector database session is very much required here, because inside vector database session I have explained each and everything you need to know to implement any kinds of project. Okay, how to connect LLM, what is documents, what is chunk overlap, everything I have discussed there. So please go ahead and try to watch that let's say session first of all, then you'll be able to understand, okay, what is happening here. Because here I'm not going to explain in detail everything. We are implementing the project only, and we're using our previous concept. Okay, this is the idea. So make sure you complete that vector database series first of all. Fine. So we'll be extracting the documents from the PDF. Then we have to create a chunks. And what is chunks? I think I already told you why chunking is required, because LLM is having one kinds of input limit. Okay, but, so that's why actually we have to create a chunks. Okay, chunks. Then what we'll be doing, we'll be using one embedding model. What is embedding model? I think you already know. I already explained inside my vector database session. Embedding model will help you to generate the vector embedding. Okay, because I have to convert these chunks to the vector embedding. So this will give me something called vector embedding. Okay, vector embedding. Okay, embedding. And with this vector embedding, we'll be creating one semantic search. I already explained what is semantic search. Semantic search, because I think you know the power of vector DB. It will give you one semantic search kinds of functionality. Now what I have to do, I have to store this vector to a vector database. Vector database, because if I want to perform the semantic search operation, I have to use the vector database. Okay, I think you already know. Now guys, you can see my knowledge base has been created. So this is called actually knowledge base right now. Okay, knowledge base, because it is having the entire information about my data. Now I'll be connecting my large language model here. So let's say this is my large language model, LLM, that means that GPT 3.5. Okay, so this large language model I'll be connecting here with my vector database. Okay, and here I will set a prompt. I'll just set a prompt here. So inside this prompt, actually I'll be writing what kinds of, let's say, tasks it has to perform. So here I'll be writing, you are a expert interview question creator. So what you have to do, whatever, let's say, data user will give you, you have to create a interview questions. Okay, or let's say 10 questions, 20 questions, you have to create it. Okay, this is the idea. So this kinds of prompt actually I'll pass to the large language model. So I think you already know prompt is everything. If I'm using any kinds of LLM, right? So with the help of prompt, we can achieve our task. This is the main idea. So this LLM will go to the vector database that time, and because vector database is having all the information about the PDF, and it will create, okay, it will create what? It will create you interview questions. So it will return interview questions. Interview questions. Okay, fine. Now what I told you, I'm not going to take only the interview question. I will also going to take the interview question answer as well from the large language model. So again, what I will do, whatever questions actually I'm getting, again I'll pass. Okay, again I'll pass to my large language model. Again I'll pass to my large language model, and I will tell my large language model also provide the answer, the questions you have generated. So it will give me the answer that time. So it will give me questions answer, okay, as well. So this is going to be my complete project architecture. Okay, so based on this architecture, we'll be developing the entire projects. Fine. So first of all, let's do everything in my Jupyter notebook. Then once Jupyter notebook is working fine, then I'll show you the let's say modular coding implementation as well. So for this guys, what I will do, I will open up my local folder, and here I already created one folder here, empty folder, and inside that I'm going to open up my terminal. Okay, so in case if you're using Anaconda, Git Bash, whatever terminal you are using, you can open it up. Now here I'm also going to open up my Visual Code Studio. So let me open up my Visual Code Studio. Now here the first thing what I have to do, I have to create one virtual environment. I think I already told you. You just need to create a virtual environment every time whenever you are creating different projects. So to create the virtual environment, you have to execute some of the commands. So let me share the command with you as well. So here I'm going to create a file called readme.md. So this is the markdown file. Inside that I can mention all the command, and this file will help you to render actually this kinds of masses in the GitHub. So let's say whenever you will be uploading this code to the GitHub, that time you will see that in the GitHub description, that means your project description, all the details has been written. Okay, let me show you one example. So guys, this is my GitHub profile. You can follow me here also, because here I have created lots of repository that might help you a lot. So let me show you my repository, guys. One of the project actually I implemented previously. So let's say this project, okay, MLOps production ready machine learning project. So this is the project actually I created. Now if you open this project and if you go to the readme section, you will see that the complete details about my project. Okay, see the complete details about my projects, like how we can set up, what is the workflow, what are the command you have to execute. Okay, everything I have set here. So how it is rendering? It is rendering because of this readme file. You can see a readme.md file. Okay, so that's why we are getting this readme file here, because whatever things you will be writing here, it will render in the GitHub later on. Fine, this is the idea. So here some of the common command you have to execute every time. Let me show you all the command. So see guys, these are the command you have to execute. First of all, you have to create the environment. After that, you have to activate it. After that, you have to install the requirements. To install the requirements, you have to execute this command. Okay, pip install -r requirement.txt. So let's create a file here. I'll name it as requirement.txt. I'll copy and let me create the file as well. Okay, now first of all, create the environment. So copy this command and open up your terminal and execute it here. Okay, execute it here. For me, I already created the environment. What I'll do, I'll just try to activate it. But for you, you just need to create the environment. So for me, let me activate. So this is the environment I created already. Interview, you can see. Fine. Now inside interview, I have to install some of the required package. The package actually I need, I think I showed you the LangChain, OpenAI, then vector database, fast API. Okay, everything I have to install here. So I already listed down all the required package you need. So these are the packages, guys, you need. Okay, you need to install. So you can see LangChain community, LangChain code. So these are the actually dependency packages if you want to use LangChain. So you have to install it. And again, we are doing local setup, guys. That's why some additional package you can see. Otherwise, what will happen? Actually, you might get installation issue. That's why I've added everything. Now, OpenAI, PyPDF because user will upload PDF documents here. As of now, we are considering PDF documents. Fine. And TikTok is the dependency of OpenAI. Then you can see AI files, fast API, UV So these are the dependency of fast API. I'll tell you whenever we'll be using these at the package, that time I'll explain. Okay, as of now, just consider these are the packages actually I need to implement the entire projects. Okay, now you can see we'll be using Fires, and to install the Fires, you have to execute this command Fires CPU, then python.env because I have to manage my secret credential. Okay, now let me save everything and you have to install it. To install it, this is the command, guys, I already shared. So copy the command and let's execute it here. For me, I already installed all the package. That's why it's telling requirement is already satisfied. But for you, it will take some time. Okay, now let me clear. All right, now first thing, I'm going to create a folder here called research. Inside research, I'm going to create a notebook. I'm going to as experiment. I'm going to name it as experiment.ipynb because this is the Jupyter notebook file I want to create. Okay, that's why it's ipynb file. Now let me select the kernel. So the environment I created, this in interview. Okay, I'll select it up. Now here, first of all, let's import some library. I need the operating system. Then I also need .env. So from .env import load env. Now let me execute. See, it's working fine. So I think remember I have to create a .env file here. Inside that I have to mention my OpenAI API key. So let me do it. So guys, as you can see, I have created this .env file. Inside that I mentioned my OpenAI API key. Okay, so for you have to do the same thing. Now let's load this OpenAI API key. So to load it, I'll call this load env. After that, simply I'll call the key OpenAI API key. And I'm going to use os.getEnv. Inside that, I'm going to pass my key. Okay, so this will give you OpenAI API key. Let me show you. See, okay, it is printing the OpenAI API keys. Now let me comment. As of now, I don't need to print it. Fine. And now what I have to do, I have to set this OpenAI API key as an environment variable. So for this, you have to execute this line of code. So it will set this OpenAI API key as an environment variable so that OpenAI package will load, okay, from the environment itself. I think I already explained previously this part, okay, how to do it and all. Now the first thing what I have to do, guys, I have to load the data, but I don't have any data here. So let me show you some of the PDF actually I'm having. So guys, as you can see in the data folder, I'm having actually two PDF. One is like HGD PDF, one is like stats PDF. Let me show you. Let me open the PDF and let me show you. So if I go to the data folder, so this is the PDF, guys, I downloaded from the internet. So the PDF name is Sustainable Development Goals. Okay, so about this topic, actually, they have written this PDF. You can see what is sustainable, let's say, development and all. They have written this particular, let's say, PDF. So this is one PDF actually we'll be using to generate the interview questions. Let's say you want to generate interview question based on this topic. Okay, so you can use this PDF. Not only this PDF, guys, you can use any kinds of PDF, whether it's a Python book, any kinds of physics, chemistry, English, or anything you can use here. It's up to you. So this is the PDF, guys, actually I'm having. Now the next PDF, let me show you. So this is the statistics PDF. So this is the topic of importance and the use of correlation in statistics. And again, you can see correlation topic has been written. So we'll be also generating some interview questions based on the statistics. Okay, that means the correlation. So these two PDFs actually I just downloaded from the internet. Okay, now let's load the data here. So I'm going to open up my notebook. So to load the data, you have to, I think remember, you have to import one, let's say, function from the LangChain. So let's import it from LangChain dot documents loader. Okay, documents loader, import import py pdf loader. I think, yeah, this one, py-pdf loader, because it's a PDF document, right? Now let me import it. Now one thing I want to show you. So let's say if I show you my project working directory right now, so let's say pwd, this is the command to check my project working directory. Now you can see that I'm inside my resource folder. Okay, you can see I'm inside my resource folder. So because this experiment.ipynb is available inside my resource folder. But where is my data located? Data located outside of the resource folder? Yes or no? Because outside of the resource folder data is available. Okay. Now if I want to go back, to my root project directory, that means LangChain project, what I have to do? I have to execute one command. This command is cd dot dot. Okay, cd dot dot is the command. So this will actually go back one folder back. Let me show you. So now see if I execute the command. Now if I again check the project working directory, now you can see that I'm inside my root directory. That means this directory. Okay, LangChain project. Now I can easily access my data right now. Okay, this is the idea. So make sure you always check the path, project working directory. Okay, if you're working with, let's say, Jupyter Notebook in a specific folder. Okay, this is the requirement. Now let me define the file path. File underscore path is equal to, so my file is present inside my data folder. Okay, data. And let's say as of now I want to load this hgd.pdf. So it should be SDG. Okay, sustainable development goal. This PDF I want to load. PDF. Okay, and to load it I'll be using py-pdf loader. Inside that I'm going to pass my file path. Okay, and it will give you loader object. Now I'm going to load the data. So I'll just write data is equal to loader dot load. That's it. Now see if I execute, it should load the data. Now if I show you the data, see, so the complete documents, so guys, you can see it has extracted all the data from the PDF itself, and it is having around 24 pages. You can see it has started from 0 till 23. That means 24 pages actually it is having this PDF. If I open this PDF, you'll see that 24 pages it is having, and all the page content it has extracted. And some of the places you can see page content is equal to empty, because in this page actually there is no content, that's why it's empty. And whatever actually documents I'm having, it has extracted. Okay, one by one everything. Now if I want to show you the length, you can see 24 pages are available, okay, in the PDF. Now what I have to do, see, it's a separate page content now I'm having. Now I want to, let's say, store all the data in just one variable. So for this, what I will do, I'll just take a variable here. So let's say variable name is question underscore gen. You can give any variable name, it's up to you. It should be initially empty string. Now I'll just write a for loop. So for page in, let's say, data, let's say the complete data I'm having. So it will give me all the page one by one, and I just need to extract the content. So question gen plus and equal. I'll be just adding, okay, in this variable. Okay, this is the idea. I'll just write page dot page underscore content. Okay, so it will give me all the content one by one, and it will save inside this question gen variable. Now let me show you. Now if I print my question gen, now see, all the data I have extracted. Okay, see, now it is in one place only. This is the idea. Now see, this part actually I have completed. That means whatever PDF I uploaded, I extracted the entire documents. Okay, now what I have to do, I have to do the chunking operation. That means I have to create a chunks. for my large language model, because if I want to, let's say, generate the embeddings, before that I have to do the chunking operation. I already explained this part, I think you remember. So to perform the chunking, we'll be using one package. So it is available inside LangChain. So for LangChain.TextSplitter, so we'll be using one text splitter here called token text splitter. Okay, so previously I think we used something called character text splitter, then recursive text splitter. I think you remember we use character, okay, character text splitter, okay, splitter. So with the help of that we can perform the chunking operation, I think you remember. Then we also have something called recursive okay, text splitter. So again, this is another method to perform the chunking operation. And now we'll be using something called token text splitter. Token text splitter. Now what is the difference between token text splitter and character and recursive? See, let's say this is my entire documents. So I think remember we used to perform something called chunk size. Okay, chunk size. Let's say 500. And there is another parameter called chunk underscore overlap. Let's say it's 100. Okay, now how it will create the chunks, I think remember, first of all it will start from the first and it will count 500 words. Let's say 500 words ends here. So this is our first chunks. Okay, and to start the second chunk, first of all it will apply the chunk overlap. Let's say 100 word back actually it will go. So it will count 100 word. Let's say this is the 100 word start from here. So it will start the second chunks from here. And again it will count till 500 word. Let's say 500 word ends here. Okay, so this is my second chunk. Okay, so that's actually it will perform the chunking operation. Now you can see there is a chunk overlap you got. So this is called actually overlap. Okay, this is called overlap. And with this overlap actually my model will understand after this first chunks, this chunks is coming, because you can see it is getting overlap now. This is the actually manual approach actually we can consider. This is the manual approach we can consider to get the context of my first chunks and second chunks. Okay, and so on, like whatever chunks actually we are defining here. But this is actually what we do in the character text splitter or recursive text splitter. But what about token text splitter? See, token text splitter, what it will do, instead of using actually this manual approach, it will use one large language model. In case actually we'll be using something called GPT 3.5. okay, so this GPT 3.5 will decide, okay, how to create the chunk, how to perform the overlapping, and it will automatically remember, let's say after this first chunks, this second chunks is coming, after second chunks this third chunks is coming, after third chunks this fourth chunks is coming. Okay, your large language model will try to remember this part. Okay, and this is like more powerful method than your previous one, whatever, let's say, method you used previously, because now LLM is like remembering everything, the context. Okay, that's the idea here. So let's try to export this this token text splitter. So for this I'm going to open up my notebook. So I already imported. Now let me execute. Now see, this is the syntax to use the token text splitter. So I think you remember previously we didn't use any kinds of model name whenever we used to perform the, let's say, chunking operation. Now you can see I'm using the model name. I'm using GPT 3.5 Turbo. That means my model will try to decide, okay, how to remember the context. Now you can see this is the chunk size. Chunk size I'm expecting 10,000. Okay, 10,000 actually what would be considered as one chunks, and chunks overlap should be 200. Okay, as of now, let's say this is the things I'm just showing you, just to show you, okay, how it will work. It's just an experiment. Okay, I'm just showing you how it will try to create the chunk. Now let's define the splitter. Okay, this is my splitter. Now inside that I'm going to pass my entire documents. So you can see the entire questions and documents actually I'm passing to my splitter. Okay, splitter objects. You can see split text. Now it will give me chunk questions, and that means the chunking. Okay, it will give you the chunking result. Let me show you. So here is the chunk I got. See, this is the chunk I got. Now how many chunk it has written? For this you can use length function. You can check. See, it has only given me one chunk. Because why? The PDF, you can see this PDF is DG. So if you count all the words, it won't be actually 10,000 words. Okay, it won't be 10,000 words. It is less than 10,000 words. That's why here I've given chunk size is equal to 10,000. It is only considering one chunk, the entire documents, because I told you if you count all the let's say word, okay, in this let's say PDF, it won't be 10,000. Okay, because it's a like huge size I have given here, just to show you, okay, how chunking will happen. Now let's perform our actual chunking. For this, what I have to do, I have to first of all convert this actually data to the document format, because you can see now it's a list format. Okay, if I show you the type, okay, if I show you the type of this one chunk question, it's a list. Inside that, if I just extract the first element, it would be a string. See, it's a string, but I have to convert to the document representation. So for this, what I will do, I'll import one class from LangChain called docstore documents import documents. Okay, with the help of documents, we can easily convert any kinds of string to document representation. Okay, now let me show you. See, now whatever, let's say data you got, that means your this one chunk question gen. So I'm applying on for loop. That means it will give me all the, let's say, data one by one, and I'm converting to the documents, you can see. Okay, and I'm storing in this particular variable. Now if I execute, now see, I got the documents and it is format of documents right now. Okay, now if I show you the type of document question gen, it should be a LangChain code document base documents. Okay, it's a now document format, because if I want to apply the splitter, so first of all you have to convert everything to a document. This is the recommended way. Okay, if you're also giving the, let's say, string directly, it's completely fine, but this is the recommended way. First of all, convert everything to the document format, then try to use the splitter, that means the chunking operation. Now I'll do the chunking again. See, again token text splitter. Again, I'm using GPT 3.5 turbo model. Now I've given the chunk size is equal to 1000. That means 1000 word I want to consider as one chunks, and chunks overlap is equal to 100. Okay, now let me execute. Now let me give my documents. Now you can see document question gen. Okay, I'm passing it to my splitter. Okay, splitter object right now. Now it will give me the chunk. Now let me show you. Now see, I'll get multiple chunk here. So I got here 4 chunks. Okay, 4 chunks actually I got from the entire PDF. Now if I show you the length, see, 4 chunks I got. Fine, I think it is clear now. So guys, as you can see, we successfully created the chunks. Now the next thing what I have to do, first of all, I will generate the questions. Like whatever, let's say, chunk I have created, I will pass to my large language model and I will generate the questions. Okay, interview questions based on the prompt actually I'll be providing. I think remember, we'll be passing one prompt to the large language model. Okay, so with the help of this prompt, actually, I'll tell my large language model, I need a interview questions. Okay, let's say the documents I have given, based on that, it should provide me some interview questions. That's what actually I need to perform. So for this, I don't need to convert these documents to the embedding representation, because as of now, we are only passing the, let's say, documents to my large language model. Large language model will give me the questions, but later on, whenever, let's say, I'll be doing the answer generation, okay, the complete answer generation, that time actually I need to pass the entire documents. Okay, and it will create the vector embeddings and it will store to the vector database. Okay, and vector database, I'll connect my large language model, and large language model will refer this entire information to give me the answer as well. Okay, this is the idea. So let's define my large language model right now. So here I already told you I'm going to use something called OpenAI large language model, that means GPT 3.5. okay, this model. And to use it, I can use this class actually chat OpenAI. You can also directly import OpenAI. It is completely fine, but we can also import like that. Okay, both way you can import. And if I am importing like that, so here I can also give my model name. That means which specific model I want to use, whether I want to use, let's say, GPT 4 model, 3.5 model, you can use. So let me show you. So this is the code snippet. So chat OpenAI, inside that you can give the model name. Let's say I want to use GPT 3.5 turbo model, and this is the temperature parameter. You can also give max length parameter and so on. So temperature parameter is a creativity parameter. I already explained. Okay, what is the temperature parameter? Now let me define my LLM. Now here I already created one prompt, guys, prompt template. Let me show you. So this is the prompt I have created, guys. You can see you are an expert at creating questions based on the coding material and documentation. See, whenever I designed this prompt, actually I was like generating coding related questions. And now I'm using any other documents. You can see that means the this one, sustainable development goal and statistics one. So if you're using statistics one, that time you need to give statistics material. If you're doing sustainable development goal, you have to give sustainable development goal here. That means whatever subject you are referring, you have to give the prompt with respect to that, because it's a changeable prompt. Is changeable. Okay, you have to change every time based on your requirement. Now your goal is to prepare a coder for a programmer for their exams and their coding test. you do this by asking the questions about the text below. That means whatever, let's say, data user will provide, that means these chunks. Okay, based on that, it will create interview questions that will prepare for the coder, a programmer, for their exam test. Okay, make sure not lose any important information. Okay, this is the prompt actually I have created, and I already taught you like how we can design a efficient prompt. What is the art of, let's say, design a prompt? I already took on session on the prompt engineering. That session you can refer. Okay, so that's how always you have to prepare a good prompt. Whenever you are preparing good prompt, that means you will get a good response from the large language model. This is the idea. Now let me define the prompt. Now to use this prompt, I think I already taught you one concept called prompt template. You have to use something called prompt template from the LangChain. So let me show you. So this is the code snippet, prompt template. Okay, so here I'm passing the prompt template I've created, and this is the input variable is text. That means user will give this data. Okay, this is the input variable. I think it is clear. Now let me execute the prompt. Okay, now this is my template right now. We can do another actually very important, let's say, technique here. See, if you're not doing it, it's completely fine, it will work. But I was going through some of the research article, and I got to know people are using something called second layer verification. That means they are doing refined prompt template. So what is refined prompt template? Let me show you. I created one prompt template. See, this is the prompt template I again created. That means whatever questions actually your model will generate from the first prompt, you have to give those questions to the second prompt. That means it will refine that particular question. Let's say if there are some issue with the question, if let's say this question is irrelevant based on the topic you are asking, again this refine prompt template will try to refine, and again it will give you some new questions, okay, on top of it. So here you can see I've written the same prompt again, but one more additional information I have added. We have received some practical questions to certain context. That means it will give me some question. Okay, this question actually I have to give to my second prompt, and second prompt will try to check. We have the option to refine the existing questions or add new one only if necessary with some more context below. That means if some issue is there, if let's say it is irrelevant, that time what it will do, it will try to rectify that question. Okay, this is the idea. Give the new context, refine original question in English. If context is not helpful, please provide the original questions. This is the idea. So this will actually refine prompt template. You are refining the questions here. That is the idea only. And this is like very powerful method, guys. If you are using, you will see that your result would be pretty good. If you're not using it, it's completely fine. No need to worry. But I'm showing you because see, we are creating it an advanced application, and in advanced application, we have to take care. These are the part. Okay, this is super important. Let's also define this refine prompt template. Again, I'm going to use prompt template. Inside that, I'm going to pass the input variable. Now input variable is two. One is this existing answer. The existing answer I will get, and the text. That means again you have to give the entire text. That means the chunks. Okay. So these two input now you have to give. You can see text and existing answer, and it will give me the refined prompt template. Fine. Now I'll generate the questions. For this, I need to integrate my large language model as well as the prompt template. For this, I'm going to use one function from LangChain called load summarize chain. Okay. Previously, I think I showed you we can use chain. Okay, only chain we can use. Now there is another chain actually called load summarize chain, because inside LangChain you are getting different chains. Okay, we are using this particular chain, actually load summarize chain. Now we'll be creating my entire chain. See, this is the entire chain. First of all, you have to give the large language model. Okay, the LLM we have defined GPT 3.5. Then chain type is equal to refine, because we have prepared one refine prompt template. Okay, that's why it's a refine. Verbose true, that means it will show you the execution, all the, let's say, logs. Then here I'm giving the question prompt. First of all, the prompt I have defined at the very first. Okay, this is the question prompt. Okay, because it's a chain, it will execute after one after another. Okay, first of all it will execute, and whatever question actually I'll be getting, I'll pass to the refine prompt template. Okay, you can see refine prompt template. Okay, now this is going to be my chain right now. And now simply I'm going to pass the document question. That means this one I have to pass. This one. That means the entire document. Okay, this document I have to pass right now to my large language model, and it will give me the questions. Okay, it will give me the questions, and these questions I'm printing. Let me show you. See, it is generating, and it is giving all the information because you have defined verbose is equal to true. Now see, these are the questions I got. I got 10 questions. Now if you want to get 100 questions, you can define here. You can define inside the prompt. I need 100 questions. Okay, you have to generate 100 questions. It will generate 100 questions. By default, it's generating 10 questions. Now if I want to show you, I will open in a text editor. See all the 10 questions I got here. But apart from that, I'm getting some more additional information. I don't need them. I only need the questions. You can see 1 to 10 questions it is giving me. What is the main goal of the sustainable development goals method? What are the some key achievements in the see? That means if you read these questions, it's pretty good. Nah, as a human, if I tell you just prepare the question for me, I think you will be thinking in that way. Okay, this is the idea. That means my answer is pretty good, guys. And why I got the pretty good answer? Because I used the refined prompt template. Okay, so this is another powerful concept you can use. Okay, so now we'll be creating the next part. That means we'll be using the embedding model, we'll be generating the vector embedding, and we'll be storing to the vector database. Okay, because I also need to generate the answer right now. Fine. So this is what I have to perform. So let's do it. So for this, first of all, I have to define one embedding model. So here I'll be using OpenAI embedding model. So for this, you can import from the LangChain embeddings OpenAI. I need OpenAI embedding model. Okay, so let me initialize. So here I'm going to use OpenAI embedding model. So if you go to the OpenAI website and if you go to the model section, you'll see that OpenAI also provides lots of embedding model. Okay, so you can use any of them. Now I also need to initialize my vector database. So here I'm going to use FIES vector database. I already told you. So it is available inside LangChain vector store FIES. You can also use ChromaDB, Pinecone, Weaviate. It's up to you. But I'm going to use the FIES because I need to show you the FIES as well. Okay, and FIES is very like fast. Than your ChromaDB. Okay, you'll see that it's like very fast, quite fast. Now let's initialize my vector store. See, that's how you have to initialize the vector store FIES from documents, and you have to give the documents here, like which document you want to create the embedding. I think remember we created the chunks. These chunks, I think remember. Document answer gen. These chunks I have to pass, and I have to create the embedding. Okay, and I have to give the embedding model. This is the embedding model I'm passing. So this will give you the vector store, and it will save locally, guys. Okay, it will save locally. You won't be able to see that. Okay, it will save in memory actually. And if you want to see that, you can store in the cloud-based. You can use the cloud vector DB that time. In the cloud, you can save. I think I showed you the Pinecone. There you can see the visualization of your vector. Okay, it's possible. Now let me again initialize my large language model. You can see again I'm using GPT 3.5 Turbo large language model to generate my answer, because you can see I told you the question I'm getting, I'll again pass to my large language model. Large language model will give me the answer. Okay, that's why I'm initializing my LLM again. Now previously I got some questions, I think remember. So this is the questions I got. Okay, these are the questions I got. If I show you beautifully, so what I can do, I can split with the help of /n. So it will give me line by line everything. Now this is the question list. See, so this 10 question I got. Now I have to generate the answer of this 10 question. Okay, with the help of large language model. Now for this, let's create a retrieval QA. Okay, question answer, let's say chain, because inside chain we are having different chains. I think I told you. Now I'm using retrieval QA chain. This chain I already used in my vector DB. I think you remember. Let's create it. Now let's initialize my QA chain. So here you have to give the large language model first of all. Now you have to give the chain type is equal to stub because it's a QA chain. Okay. Now you have to give the retriever object. That means your vector store. That means you are connecting with your large language model right now. See, LLM, you are connecting with the vector store. Okay, for this you have to write this code, vector store as retriever. That's it. Now this is going to give you one chain. Now you can give the, let's say, question and you can get the answer. For this I written a for loop here. See what I'm doing, whatever question list actually I'm having, I'm looping through it. That means I'm taking all the question one by one. Okay, you can see, then I'm printing it. Then I'm generating the answer. You can see I'm calling this chain run question. That means I'm giving the question, it will give me the answer. This answer actually I'm also printing. After that, I'm opening a txt file. Inside that, I'm just saving it. Okay, inside that, I'm just saving it. That's it. As of now, inside a txt file, I'm saving it. Going forward, inside a CSV file, I have to save it. Okay, this is the idea. Now let me execute. See, first of all, this is the first question. It is generating the answer. See, this is the answer. Okay, second question, it is generating the answer. Third question, answer. Fourth question, answer. So that's how it will generate for all the questions. Let me show you. See, beautifully it is generating. So we have created one amazing application, guys. Now we have to convert it the modular coding. That's the idea. Now see all the answer I got. And if you read the answer, guys, if you open your text editor and if you read the answer, it's pretty good. It's pretty good. If you see that question and answer, it's pretty good. Now you can use as it is. As it is for any kinds of exam, any kinds of interview, you can prepare. It's amazing, right? Okay, so this is the entire actually, let's say, notebook experiment of our project. Now let's try to convert everything in a modular coding. Modular coding is, I just need to write everything in a function. That is the idea only. Okay, I'll refer the same notebook only. I'll copy paste the same code, but I'll write everything in a function. Okay, there is nothing new I'll be doing. So let's start the modular coding. So guys, now let's start the modular coding. But before that, let me show you this answer.txt. Now see, inside answer.txt, it has saved everything, all the question and answer. But again, it's not readable. So next time what I will do, I'll save everything in a CSV file. In one column, I will add the question. In another column, I'll add the answer. Okay, that would be more readable. So what I'll do, guys, now let me close everything. So left hand side, I'm going to create a folder and I'm going to name it src. Okay, src, because this is going to be my source folder. Inside that, I'm going to write some helper related function. That means if you open up any kinds of, let's say, real-time implementation of any kinds of package or any kinds of project inside Python, let's say if I open this one, Keras, GitHub, you will see that they have also created this kinds of folder structure. See, this is the Keras. Now Keras is also using this. See, it is having one root folder Keras. Inside that, they're also having the source src, and inside src they have created all the, let's say, utility related functionality. That means whatever functionality they need, let's say activation function, application, backend, callbacks, they're writing everything here and they're integrating in the endpoint. Okay, it is also having some endpoint. See, API gen, this is the endpoint, and they're importing it here. If you open it, any kinds of endpoint, they're importing it here. Okay, this is called actually modular approach. That means instead of writing everything in just one file, we have to create a separate file, separate function, and whenever I need it, I'll just call it, okay, from that particular, let's say, a helper function. This is the idea. So inside src, I'm going to create a file called __init __.py. Okay, this is the constructor file because this folder would be considered as my local package right now. See, this is the modular concept, guys. This modular concept I already explained in my Python session. Okay, so I think you know. So guys, this is our YouTube channel. So here, if you go to the playlist section, I already created complete Python course. So here I already explained about modular coding, everything. What is this constructor file? What is modular coding? How we can write any function in any other file, how we can import it in the endpoint, everything I have explained. Just try to go ahead and watch that one because modular concept is required here. Okay, I'm expecting you are already familiar with this kinds of Python concept. Fine. So you can also see the master OP actually playlist. So there also I have covered lots of advanced topic related Python. So that's why I'm creating this constructor file because this folder would be considered as my local package right now. Okay, and inside that I'm going to create a file called helper.py, and I'm going to create another file called prompt.py. Okay, prompt.py. So inside prompt.py, I'm going to mention my prompt. So let me show you. So the prompt actually I showed you in my Jupyter notebook. So here I'm going to just define. See, this is my prompt template, first prompt template, and this is my define prompt template. Nothing new, guys. I'm just copy pasting from my notebook only. See, the same prompt I just copy pasted because prompt is a changeable. Okay, it's a changeable, it's a static one, people can change anytime. So that's why I've written inside prompt let's say file. So user will open the prompt file and there actually they will change, so that they don't need to open the actual code implementation, and inside that they don't need to change. Okay, I don't need to hard code these are the value. That's why I kept this separate entity. I hope it is clear now. Now let me close it. Now inside helper.py, see, whatever code I have written so far, that means I loaded my documents, I performed the chunking operation, then I created the questions. Okay, these are the thing I'll be writing inside a function only. So inside helper, I created two function. First of all, you have to import all the required package you need. I think you remember these are the packages actually I need. I loaded in my notebook. Then I need to load my I need to load my OpenAI API key and I have to set as environment variable. I think you know, got it right. Now the first function I have written called file processing. Same thing, guys. If I show you the same thing I'm performing here. First of all, I'm loading my documents. I'm adding all the, let's say, content inside one variable. I was performing this one. Chunking operation. First of all, I was doing with the help of 1000 token. Then next time I was doing with the help of, first of all, I was doing the 10,000. Okay, 10,000 chunk. That means one chunk I want to consider as 10,000. Then I was doing for the 1000. That means the same experiment I did here. Remember, same experiment. See, same experiment. I just written inside a function only. That's it. That is the difference only. So this is called actually modular approach. You can also create a Python class, but as of now, it's a very, let's say, a small implementation. That's why Python class is not required. But if you see the actually very big implementation, any ML project or deep learning project, you will see that there I've written like lots of class. Let me show you. So inside US Visa, if I open the components, that let's say data ingestion, you can see I've written a class that time. Okay, so class is required because you can see lots of function I have to handle. And whenever you are having lots of function, lots of method, that time you can write a class. But here I don't have actually lots of method. I only have 1 to 2 method. Okay, that's why I've just written directly a function, not a class. Okay, this is the idea. So that's how you have to design your own project, whether your project size is very huge or not. If it is huge, try to maintain the class, otherwise try to maintain the function. This is the difference only. So if you see any kinds of GenAI project, so most of the time actually we create, let's say, inference on top of large language model, we create a RAG application on top of large language model. Okay, that's why the code implementation is not big that much of. But whenever actually I'm creating any ML project, DL project, there actually we are training our custom model. That time actually lots of method we have to handle, very big code base we have to handle. Okay, that's how we need class concept. This is the idea. Now you can see, guys, I will get my object. Okay, object related my chunking. You can see it will give me document question gen. That means after performing the chunking, and document answer gen. Okay, both actually it will provide. So question gen is nothing but you can see I'm converting to the documents this question, whatever questions actually I was getting. So this is the document question gens. That means after converting to the documents, whatever documents I'm getting, this is my document question gen. And after doing the chunking, this is my document answer gen. So this question generation and this document I need for the answer generation. Okay, the same thing I perform it by notebook. I think remember. See, first of all I was using document question gen just to generate the question. Okay, then I was using document answer gen just to generate my answer. Okay, I hope it is clear. So this function I have created, guys. Now the next function I have created, my LLM pipeline. That means I will be using my large language model. I'll be creating the vector embeddings. Okay, so everything will happen inside this function right now. LLM pipeline, first of all, I'm calling the file processing. That means this function, inside that whatever file user is giving, this file would be processed and it will give me document question and document answer gen. I'm creating my large language model, creating the prompt, both prompt actually. That means my prompt question as well as the refined prompt. Okay, both I'm creating. Then I'm first of all creating load summarize chain. I think remember load summarize chain I was creating. Okay, this one. So it will give me the question. It will give you the question, and I was creating the vector embedding after that. Vector embedding. Then I was creating the vector index. You can see vector index. Then I was creating the retrieval keyword at that time. Okay, it will generate you the answer. That means question answer. That means here you will get answer question generation chain and filtered question list. Okay, both actually will get. So these two function I prepared here. Now let me save. Now let me create the endpoint. So here what I will do, I'll create a file. I'll name it as app.py. Okay. Now this is going to be my endpoint. So inside that I'm going to call this function actually, this LLM pipeline. Because inside LLM pipeline, I'm calling my file preprocessing. That's why I don't need to call separately. So let me open it up. But before that, let me initialize my fast API related code. So if you go to the fast API documentation, guys, you will see this is the starter code. That means this is the demo code they will also give you. So these are the library you have to import one by one. Okay. Then you have to initialize the fast API. So how to initialize the fast API, guys? So that's how you can initialize the fast API. Okay. See, this is the code to initialize the fast API. Now here you have to create two folders, static and templates. Inside that you have to create the index.html file. So inside template folder you have to create a index.html file, because index.html file would be your home page. Okay, that means the user interface. So you need some HTML code. Let me show you. I already created. So guys, as you can see, I already created one template folder. Inside that I created a HTML file. Okay, now see, inside that I have written already HTML code. Okay, that means my front end part of my application. And how I created, again, I referred that Bootstrap website. I think you remember. I also used the Bootstrap website. If you don't know about HTML code, it's completely fine. You can skip this part. You can use, let's say, any other framework, let's say Streamlit on. And see, this HTML creation would be done by the front-end developer. As of now, just to beautify this project, I created the HTML, okay, from my end. That's the idea. And there is another folder I created called static. Inside in static, I created two folders called docs and output. See, whatever documents user will upload, that PDF, it will save inside documents folder. And whatever output you will get from the, let's say, application, that means the question and answer in a CSV format, because you can see I've imported the CSV, it will save inside output folder. And from output folder, actually, I will get that particular, let's say, CSV output. Okay. And inside documents, it will store the PDF. That's the idea. Now, this is the fast API code, guys. Fast API will handle each and everything. Now, I also need to import this one. That means my LLM pipeline. Let's import. So it is available inside, I'll call it form. Let's say src dot, let's say, helper import LLM pipeline. So it is inside helper. I need to import LLM pipeline, because inside helper I have this LLM pipeline. Okay. Now see, if I am importing like that, from src helper import LLM pipeline. That means src is now considering my local package. And if I want to use src as my local package, what I have to do, I have to create one file called setup.py. Okay, setup.py. So this is the modular coding concept, guys. Again, inside setup.py, you have to write some setup related code. Let me show you. So this is the code, guys. Setup tool. First of all, give the project name, version, author name, author email, package, and install requires. That means this find package will try to find, okay, wherever this constructor file is available, this folder would be considered as my local package. Now you can see constructor file is only present inside src. That means src would be considered as my local package. Now see, if I show you pip list inside my environment, see, src is not mentioned. Src is not a package. Okay, see, src is not a package. But whenever I will install it, whenever I will install this setup, you will see that this src would be considered as my local package. That means there would be a package name called Generative AI project. You can give any name. I've given Generative AI project. Now let me save. And to install it, in the requirements, you have to add one more line called -e space dot. Okay. So this -e space dot will look for the setup.py and it will install this package. Okay, let me show you. Now if I again run, let's say pip install -r requirement.txt. See, this would be installed as my local package right now. Done. Okay, now see, some egg info file would be created. Okay, whenever this egg info file is created, that means this setup is successful. Now if I again open up my environment, let's say pip list. Now see, there is a package it has created, Generative AI project. Okay, now see, it is my local package right now. That means this src would be considered as my local package. Now I won't be getting any kinds of error right now if I'm importing like that. Okay, so this is called actually modular approach. I think you got it. So here, first of all, user will upload one PDF. For this, I have written a function with the help of first API. So this is the function. So there is a route called upload. User will upload one, let's say, file, and this file would be saved inside my documents, inside statics documents. Okay, it will save. Now there is another function I will create called get CSV. That means the complete results. Okay, I want to save as a CSV file. So this function will help me to do that. That means the file actually I'll be receiving here. This file I'll give where in the LLM pipeline. And LLM pipeline, what it will do, it will pre-process. It will create the, let's say, prompt and everything. Then it will give me the that means chain, entire chain. Okay, and that chain actually I will utilize here. You can see. So you can see I'm getting the entire chain, and whatever question list actually I'm having. Okay, question list. I'll pass the question inside my chain and it will give me all the answer. And this answer actually I'll save inside my CSV file. You can see right row. Okay, CSV writer right row. And with for this actually I'm using CSV package. You can see CSV package. Very simple code, guys. Only have written inside a function only. You just need to go through this code. You will able to understand. Okay. Then I need another function, guys, called chat. So this particular function, what it will do, it will load the output file. That means the CSV file. Okay, and it will show. It will return you. Okay, it will return you. That means you can also see the complete PDF. Okay, in the UI. Let me show you how this application will look like. So now let me execute my first API code. See, this is the first API code. If you can run app, this is the local host and this is the port number 8080. Okay, now let me save and now let me execute. So I'll open up my terminal. So python app.py. Now see, it is running. Let me give the allow permission. Now I'll go to my Google Chrome and here I'll search for localhost 8080. See, this is the user interface, guys. Okay, now here you can upload a file. First of all, let's say I'll upload this file inside data. Let's say I will upload this SDG. First of all, this sustainable goal development, and here I'll generate the question and answer. Let's see. It is generating. This is the user interface we created, basic user interface. Now see, it's loading. And how this loading is happening, animation is happening, because I written everything inside HTML code. So guys, you can see I got the output. Now left hand side you can see it has rendered my entire PDF. Okay, the PDF I uploaded, and right hand side it has given me the CSV download. And now see, if I click here, it will download the CSV file. See, QA CSV. Now let's open the CSV. How I can open? Let's open it here. So I'll open it. See, this is the CSV. I don't have Excel right now, guys, in my system. That's why I've opened in a VS Code. You can see this is the question, this side, and that side actually I have the answer. You can open in a Excel viewer. You will see that it's a beautiful format I have just stored. Okay, so that's how actually things are happening. Okay, now I think you got it. why we have written these are the function. So this function will help you to render your PDF documents, as well as it will give you the download option, okay, to download this particular PDF. Now let's upload another PDF. Let's say I will upload this statistics one right now. Now let's generate again. So guys, as you can see, I got the results, and this is my PDF I uploaded, and let's download the QSCSB as well. See, this is the correlation answer and question I got. Fine. So yes guys, this is the project actually. I hope you liked it, and this is like very interesting project guys. If you develop it, you will feel like it's like very interesting. Going forward, we'll be also implementing lots of projects, no need to worry. Until then, thank you so much for watching this video, and I will see you next time.